17. Okay, so I'm very pleased to participate at this conference. Daniel, I can say that is the man of God for us, for the new researchers as us. So I'm very happy to participate at this conference.
I want to say that you are always a faithful participant. You are always there, and you are always from among our members from Cote d'Ivoire. You are the most faithful. You always accompany me in every event, and yeah, you are very faithful. I'm happy to have you. Yeah. So, who else wants to say something about you, present himself and talk about your research? Because we still have 8 minutes for those. I'm seeing an Ogadis May. Can that person present him or herself?
Okay, good morning.
Good morning.
I'm Ogadi, a student at Multimedia University, pursuing the postgraduate,
Okay.
and was invited by my lecturer, Dr. Kesa, and my research is based on the renewable energy, the optimizing the parameters, so that
Okay.
we can get the best of the cricket. Thank you so much.
So what I will encourage you is to join the network ANSOL. And for those who have not yet joined the network, actually also, Prof. Asmo, I want you to be a prominent person within ANSOL. So I will send you the membership form if you. It doesn't cost much money. It's just 30 euro per year. So, but yeah, we have been working a lot together, Prof. Asmo. So it will be good for you to be a member of ANSOL, and we can do more together. So I encourage all those who are not yet member of ANSOL to join this dynamic network, which has a very great outreach, and not only within Africa, but at the meantime worldwide. So, and we, as a member, I feel that I would trust people to say, okay, you are now a member. You could take this duty to do this and that and that. Yeah. We had when it comes to South Africa, we had only one big event. That was 2013 with at Stellenbosch with a timber lab. Mali Maza. I don't know. Some of you know Mali Maza. For those who, yeah. That was 2013, a long time ago. So more than 12 years already. So we can, at one point, organize a big ANSOL conference in, yeah, depending where, maybe in, I don't know, Maiken is, it can be a good venue or somewhere else. So, yeah, let me say 2027 or 2028 or anything of the sort. Or we target the 20th anniversary. But for that, we have to go at the seashore to go to. But Ashmore, you came from this. You did your PhD in Durban, or you did something in Durban. Your undergraduate. Ashmore, is Ashmore there? This is disappeared maybe for a while. So Maria, Kisa, good morning. She's also not maybe on our spot. I'm seeing Andrew. Andrew, can you present yourself? Andrew is also.
Sorry, Daniel, I was listening, but the unmute button was a bit hard for me to find easily. I was listening. So.
Okay, just I was. I wanted you to maybe present yourself, say something, and I want also to encourage you to join our network, the ANSOL network. And you are a dynamic person. Join the network, you will be an added value for us. And I think we can do more. Our network, as the time goes on, is known at the planetary platform. People know us, whether it's Latin America, North America, Asia, and so on. So we are getting strong publicity, and we can do a lot in different African countries if we have dynamic people like you, Maria, and others who are here. So I will send you the membership form, and you join. You will think what we can do together with our other members in Uganda. So I was in Uganda 2019. I was in Uganda 2019, where we had a meeting in Kampala with our group, our members there. So and we decided actually we were supposed to do a lot of activities within Uganda, but the COVID came and disrupted a lot. So the plan was even to create a solar company and all those type of things, but things could not go in the right direction because of the COVID. Yeah. So Mr. Andrew, you are speaking. Can you present yourself? I have 2 more minutes before, or let me hand over the floor already to the chairperson, because I have just 2 more minutes. And the chairperson of this session is Jerome. Yeah. So I'll just hand over Jerome and Emanuela Fassino. It seems where is she? She's not yet there. So everyone should mute him or herself so that only the chairperson and then the presenter should be speaking. So let me allow you to start.
Okay. Thank you very much, Professor Egbe, for giving us the chance to chair this very first session of day 2 of the ANSOL online conference. I just wish to find out if, because I've not seen Emanuela online, if she's there, can she indicate? Because we are supposed to share this session together. Emanuela? Okay, if she's not, probably she'll join later. I will wish to just make a recap of yesterday's activities. We had in total 4 sessions yesterday with quite a good number of presentations. The sessions went through presentations of from initiatives and organizations. And then we went through presentations on advancing solar energy deployment in Africa, mini grids, and then through session 4 with the main theme being thermal, solar thermal energy. So today we will be moving into the next aspect of solar energy, which is photovoltaic solar energy technologies. So in all, we will have 5 presentations, and we will begin immediately with the presentation from WAITRO. I can already see him online. So WAITRO, the floor is yours. Thank you very much. Yeah, WAITRO, you need to unmute your mic because we can't hear you.
Tabii ayılan üstünde ondan sarhoş. O bir ayılsın gelsin de ben onunla böyle erkeğe bir konuşayım.
Sadık saçmalama. Bu meseleyi onu kınadığımız yöntemle...
Good morning, everybody. No, this is not the same. Oh, here. I start with my presentation concerning advanced organic materials for solar photovoltaics. You know that it is enough wide
Oh, it's another presentation.
area.
Check, please. Remove and
Okay, Petro,
do you
I
listen
see.
me?
Yeah, we can get.
Do you see my presentation?
this is presentation number 2, Petro.
No, this is the first presentation.
But we are seeing the number 2 on the screen. We are seeing functionalization of silicon solar cell.
No. Advanced organic materials. This is the first presentation.
So you have to upload it. It's not what we are seeing.
Maybe it doesn't matter. We can change it and return back.
So we have to start with the second. With this?
No, because you played the second. You did not play the first. So I'm seeing only the second presentation.
So what presentation would you like to see?
Number 1,
Functionalization
advanced organic materials. That was the title of the first presentation.
Yes, this is the first. I would like.
Sorry, Petro.
I would like to make
the file,
accent.
Petro.
Yeah.
Please change the file.
Change the file, because what we are seeing is functionalization of silicon solar cell. That's what we are seeing, Petro.
Do you see my screen or
we
not?
We are seeing the screen, but we are seeing the wrong presentation.
This is carbazole derivatives, Petro.
No, this is advanced materials.
No.
No, this is the first.
Okay. Petro, stop this change, then you start again and look, because what we are seeing is different from what you want to say.
Yes.
You can stop the sharing, then you go again and look for the right presentation.
Can I start?
No, you cannot start, because what you are seeing is the wrong presentation.
Prof, if I may suggest, if he has the functionalization of silicon cells, which is the second presentation, he may just go on and present it and then come back to the first presentation.
Start with the second presentation then, okay? Because he's going to be the one to present both.
Yes. So, Petro, can you go on with the presentation we are seeing on the screen?
We are seeing this functionalization of silicon solar cell. That's what we are seeing. We are not seeing advanced.
This one.
Functionalization of silicon cells.
That's what we are seeing on the screen.
We have started with this.
Yeah, you can start with it.
Yes, we can start with it.
Okay.
Thank you.
All
right.
Презентацию номер 2. Организация. Она сейчас на экране у всех. У всей вашей конференции.
This presentation represents 3 organizations. Our Institute of Semiconductor Physics of National Academy of Science of Ukraine in Kiev, Kaunas University of Technology, Kaunas, Lithuania, and Riga Photonic Center, Riga, Latvia. I would like to present new ideas of functionalization of back contact for silicon solar cells using organic carbazole derivatives, and to show some features of self-assembling of thin film carbazole derivatives on aluminum C back contact. And it is well known scheme of silicon solar cells. Our consideration will be on this back contact. It's a very important contact for efficiency of solar cell, and there are many methods to improve this contact. One of them, back contact passivation. For this, usually use ultra-thin dielectric layers like silicon oxide, aluminum oxide, hafnium oxides to remove reduce surface combination. Combined passivation, for example, silicon oxide and organic molecules of or nanostructures, using titanium oxide layers to improve charge transfer. The second, a big approach, optimizing contact morphology, using textured surfaces to increase contact area, nanostructured metal layers to reduce contact resistance. There are chemical modification of contacts, using self-assembled molecular monolayers to control energy level, functionalization using electron acceptor on donor groups. The fourth group of approaches, nanomaterials and hybrid coatings, addition of graphene, carbon nanotubes, metal-organic frameworks to improve contact, combination of organic materials, carbazole derivatives, perovskites with silicon structures. There are some deposition techniques. One of them, very big use for researchers and production, organic vapor phase deposition. This method gives high quality films, smooth films with precise thickness control, a wide range of substrates, a more uniform film compared to liquid-based techniques. Spin coating approaches. We have such advantages: simple and inexpensive, high quality, uniform and smooth films, small scale applications. Deep coating approaches, advantages: simple and inexpensive, high quality, uniform and smooth films, small scale application. Thermal evaporation, it used for high purity films, smooth film with high control over thickness, for organic semiconductors with relatively low volatility. Organic vapor jet printing, such advantages like non-contact, scalable, film in specific design, low material waste. Our approaches consist from such things: use of low-cost organic materials, carbazole derivatives, use of self-assembling of thin organic films on pattern substrates, silicon, use spin coating and drop casting methods, use of a dimensionless sensitivity approach for diagnostics of current voltage characteristics. We use silicon substrates with 1 square centimeter aluminum back contact, self-assembled carbazole derivatives, thin films of aluminum back contact, room temperature conditions, spin coating and drop casting methods. Our substrates were pattern silicon, 100 direction and type with a resistivity of 1.7 ohm centimeter with aluminum back contact. Carbazole derivatives, 5 materials with substitutes. Dihydromethan, acetone, tetrahydrofuran, chloroform, ethyl acetate. You can see a chemical formula of these materials. Features of the morphology of carbazole derivatives films deposited on aluminum back contact were studied using metalographic microscope MIY4. Here we can see some films deposited on silicon substrate. First 3 photos concern to spin coating method, and the second 3 for drop casting method. We can see the different carbazole derivatives make different morphology. Mainly, this is net-like morphology. And for DB73, we can see square-like morphology. It differs this material from another materials. Such carbazole derivatives like DB70 and DB74 show us net-like morphology. This is a very important morphology for high efficiently solar cell. We found this previously in our investigation for aromatic heterocyclic organic materials. And some carbazole derivatives show fiber morphology. DB58 for spin coating and DB72 for drop casting. So when the film is enough thick, we can see such fiber morphology. For analysis of current voltage characteristics, we use dimensionless sensitivity. I taught last year in detail this. Here I would like to remember some points for understanding what we will see and what we obtain from our investigation. Dimensionless sensitivity means the differential slope of curve in log-log scales. So if we have some points in our experimental curve, our dimensionless sensitivity will be between 2 points. And this slope we present from our bias in our current voltage characteristics, and this slope show some physical processes like recombination mechanisms. What we can see at our interface from cathode and anode. Here we can see forward dark characteristics of our samples. We can see that very unusual behavior of current voltage characteristics. At low voltages, we have slope 0.5, what is usually distributed for rectifiers. So in right direction, our carbazole films make a rectification at low voltages. So it change injection properties at interface. And we have such behavior for 58, 70, 72, and 73 films. And here we show current voltage characteristics of silicon substrate. Here we can see usual ohmic behavior at the low voltages. At higher voltages from 0.1 to 10 volts, we have injection behavior of forward current voltage characteristics. And if we have dimensionless sensitivity equal to 2 here for silicon substrates, in our functionalized surfaces, we have dimensionless sensitivity 1.5, what is correspondent to B-molecular recombination. B-molecular recombination is a mechanism of recombination when we have enough number of positive and negative charge carriers. And such mechanism show us that we change our current voltage characteristics to direction from monomolecular recombination for silicon to bimolecular recombination for functionalized surfaces. Reverse dark characteristics begin from ohmic for silicon at low voltages and then go to dimensionless sensitivity 0.5, what is usual for back for reverse characteristics. But functionalization of this silicon substrates with aluminum contact show a very interesting situation. When we have in reverse direction dimensionless sensitivity equal to 1, which is character for ohmic characteristics for dB70, dB72, and for dB73 and 74, we have even bimolecular recombination, which we have not for silicon substrate. So functionalization of back contact in reverse direction change radically our current voltage characteristics. Forward characteristic under illumination for silicon is usual with bimolecular recombination, and dimensionless sensitivity is equal 1.5. And our functionalization actually change for monomolecular recombination, so it restrict injection of one type of charge carriers for DB70, DB72, DB73, and DB74. And for high voltages, injection increased, and we have dimensionless sensitivity, what is has to be for silicon. So injection from the contact gives us bimolecular recommendation for all materials besides DB72 when we have ohmic behavior at high voltages. Reverse characteristics under illumination. In silicon, we have a deep restriction of current, so we have saturation current voltage characteristics. Functionalization by carbazole derivatives change this situation, and we have complicated behavior when we have ohmic behavior for low voltages. Then we have bimolecular recombination, so we have enough number of charge carriers for many of our samples, and in such a way we can increase injection of minority charge carriers in reverse direction.
Pedro, can you be concluding the first presentation?
Yes, yes.
Oh, okay.
So the morphology on functionalized surfaces studied by optical microscopy showed fibrous-like morphology, square-like one, and network-like morphology. The morphology of carbazole derivative modified aluminum pattern silicon back contact correlates with the current voltage characteristics. Samples DB70, DB72, and DB73 with network-like morphology have similar behavior of current voltage characteristics. The sample DB58 with fibrous morphology has lower currents compared with unmodified back contact, while the sample DB74 with square-like morphology has highest currents among all modified contacts. Due to the functionalization, the current decrease for 3 DB58 and DB74 to 10 times at low bias, and even still time 100 times at middle bias at forward direction. In the reverse direction, the situation is different. The curves of samples DB58 and DB70 are almost identical at low bias, whereas the current values of samples DB72 and DB73 are 10 times lower. At high bias, the currents are almost the same, This illustrates the functionalization of the interface itself. Thus, carbazole derivatives can be effective materials for backside contact functionalization in different structures, including solar cell. Thank you for your attention.
Thank you very much, Petro, for that very wonderful presentation, even though we took a little bit more time considering what happened at the beginning of the presentation. I will open the floor now for one or two questions, or anyone with a question or reactions to that presentation.
I have a question, Petro. I was looking at the photographs of your film morphologies, and I'm a little confused as to whether the films are actually continuous. Is there continuity across the whole substrate? Or...
But it's very important thing that our film can be self-assembled, and the form of self-assembled morphology effect directly on current voltage characteristics of such structures. Carbazole derivatives show the same behavior like aromatic hydrocyclics materials we studied before and I presented last year. So for our opinion, it's a very interesting and useful approach for change our interface for enhance the efficiency of solar cells. Next, our step to make solar cells with such modified contacts and show improving of efficiency of modified solar cell with modified contacts.
Okay. All right. Thank you very much, Paul, for your question. And thank you, Petro, for the very brilliant response. Petro, I may just invite you to queue up and do the second presentation.
Okay. This presentation had to be the first, but no matter for us, but I would like to present our institute here. And I will talk some words about modern organic photovoltaics and show diversity of organic materials for organic electronics, including photovoltaics, and to give examples of the best organic photovoltaic cells. I will tell a little a history about Ukraine, Kyiv City, National Academy of Science of Ukraine, and Lashkarov Institute of Semiconductor Physics. I will show types of organic photovoltaics, organic materials, give some examples of best organic photovoltaic cells, and make a conclusion. Kyiv is the country in the middle of Europe, near Black Sea. Kyiv is in the north part of Ukraine. Now I make my report from Kyiv. Ukraine is about 600,000 square kilometers, 45 places in the world. It had 43 million people, and now estimation of about 25 million people. Kyiv is the capital of our city, about 4 million of people. Some our points of view. This is the square of independence. This is Kiev, Pechersk, Lavra, and then after them we can see river Dnieper. Our Academy of Science is founded in Kiev in 1980. We have about 160 research institutes and about 36 research plants. Staff of about 21,000 employees, including 12,000 researchers. Activity of Academy of Science is fundamental and applied research and development of the most important problem in the field of modern science. Our institute was founded in 1960 on the basis of several departments and laboratories of the Institute of Physics in Kiev. We have 10 departments and 1 center for collective use. In our institute works about 500 employees, including 1 academician, 6 corresponding members of National Academy of Science, 82 doctors, including 49 professors, and about 180 PhD candidate of science researchers. Main directions of our institute are physics of low-dimensional structures, micro and nanoelectronics, optoelectronics, photonics and photovoltaics, semiconductors, functional microwave, terahertz and infrared techniques, semiconductor sensor systems and technology, semiconductor materials and their diagnostics. I would like to show you and tell you about war in our country. It's unthinkable. War, it's impossible to think how it can be. You can see the terrible photo when usual houses in fairs, we can a place when big rocket came in Ukraine. This is a hospital for young kids, and this is terrible. What is the country which can do such horrible things? Let's go back to organic photovoltaics. Organic photovoltaics is one of a big segment of solar energy. It started visible in a table of efficiency of photovoltaics from 2000, and we can see increased efficiency of solar cells. We have organic cells directly and organic tandem cells. This is a table from National Research Energy Laboratory from United States of America. Here, I took efficiency of organic cell from a table 64. This table every half year we can see in progress and photovoltaics journal which show records all over the world, which made in 5 main centers, one in Australia, the second in Germany, Fraunhofer Institute, in Japan, and so on. So the biggest efficiency of organic self itself, 15.8%, organic mini model, 15.7%, and organic submodel, 14.5%.
Pedro, we are not seeing your slides. We can't see your slides.
Can see?
I can see it from my end here.
I see.
I can see slides.
Okay, all right.
I can see it.
Okay, go on. Sorry. Maybe.
I would like to present some types of organic photovoltaics. Organic cells, organic tandem cells, perovskite organic cells, organic silicon cells. And what we expect from organic materials. A prospect of creating more flexible, lightweight, and cost-effective solar cells, advantage of the low-cost manufacturing potential, inkjet printing, or roll-to-roll production. This main direction for investigation and looking for ways for production. Organic materials what used in organic photovoltaics mainly conjugated polymers. This is organic macromolecules having alternative sigma and p bonds along their backbone. The localized pi electrons cloud over the backbone chain is responsible for attractive optical and electrochemical properties. The conducting nature of conducting polymers was first discovered and developed by Mark Diamond, Hideki Shirakawa, and Alan Higer in 1977, which led them to win the Chemistry Nobel Prize in 2000. This is some example on conjugatics. A polymer like a polyphenylene, a polyphenylene vinylene, a polyphenylene ethylene, a polyfluorine, and so on. A way we can use conjugatics polymer. There are some main areas of application. First of all, is solar cells, light-emitting diodes, organic electrochemicals transistors, field effect transistors. Here I shows one of a huge number of references, but it's for my opinion enough a good described application of this material. Conjugatics polymer used in energy storage system, imaging, catalysis, flexible displays, chemosensor, biosensor, direct delivery, and therapy. Organic molecules, we can use small molecule. This is allow molecule with weight organic compound typically involved in the biological processes as a substrate or products. Metabolomics usually studies small molecules within a mass range of 50 to 1,500 daltons. Here I show some examples like glucose, stearic acid, cholesterol, lysine. This is small molecule can be used. The second types of molecule copper phthiothionine and fullerene derivatives. This material of fullerene derivatives were used for enough high efficiency of solar cell in the beginning of organic photovoltaics. And we have such a group of materials like perylene derivatives. I show some examples of such material with increasing several extension of perylene atomic core.
So, WAITRO, can you conclude in 1 minute?
Oh, yes.
Okay.
Yes.
Thank you.
Here is some material, and I would like to show some example of the best materials. So this is example how we can use anti-reflection coating and increase efficiency from 15.24 to 15.80%. And researchers from China have fabricated an organic solar model with certified efficiency of 12.38%. By their panel was built by connecting 7 solar cells in series with an efficiency of 16%. This enough high efficiency. And the record efficiency of model from international research team led by German Friedrich Alexander University, London, Nuremberg, and the architecture of the cells substrates based on glass and indium tin oxide, electron transfer layer based on zinc oxide, organic materials, PM6, a whole transport layer relying on the polymer P dot and the silver metal contact. So we can say from this short review on organic materials, they have great potential for use in organic photovoltaics. The main expectation from organic materials are cleaning more, creating more flexible, lightweight, and effective solar cells, taking advantage of the low-cost manufacturing potential of inkjet printing and roll-to-roll production. The main materials studied are perovskites, carbazoles, fullerene derivatives, perylene derivatives, and many, many others. Records for organics PV for this moment are 14% for large PV modules and 16% for solar cells. Thank you for your attention.
Okay, thank you very much, WAITRO, for that very touching presentation, particularly the section presenting the effects of war in Ukraine. we really share with you the pain of the effect of the war, and we admire your courage to stay strong in your research, which goes a long way to improve on the being of humanity. Thank you very much for your presentation.
Thank you.
We have some hands. I think Paul wants to say something myself because it's my field. So just give us even 1 minute to ask you say something. Paul.
Okay, Prof. Okay.
Actually, that wasn't Paul putting his hand up. That was Paul doing the applause thing on this.
Okay.
But I will make a comment, Petrov, because I don't know if you know, but my entire career was actually in organic semiconductors back when I used to do useful things instead of just playing at being a Secretary General. And most of what I did was actually in organic light emission. And I never really bought the argument that organic materials would lower the cost of manufacturing for a very simple reason. Most of the cost of a solar module, at least, is not in the deposition of the thin film. It's in the encapsulation, the module, the balance of systems. So I'm interested, how would you defend the idea that organics will actually make cheaper solar cells, regardless of everything else?
As usually we use usual methods. We don't investigate special approaches for defend our solar cells. Our main task to look for new materials, new composite materials for photovoltaics. And when I started my activity in organic materials area, my colleagues told me, what would you like to cover silicon by organic? Silicon is good enough. It's not necessary to improve him, but new tendencies in development of photovoltaics, we can see that organic photovoltaics now enhance its position, and my opinion is enough good.
Well, actually, I've got to say that enhancing silicon is probably the best chance that organics really have, because like you said, silicon's good enough, but putting an organic, and they've also done it with perovskites, right? You put a thin layer of a perovskite or an organic to make a tandem, and you capture that little extra bit of spectrum to just increase the efficiency of silicon by 1 or 2%. That's enormously significant.
Yeah,
but I'll say no more. Thank you for your presentation, and my sympathies for the state of your country as well. I'm heartfelt sympathies.
Thank you, Paul.
Okay.
Thank you very much.
For me, just to say quickly something, I'm in the field of organic also, and I always tell my students never to write in your publication or in your work that organic are coming to replace. It's just an alternative. And the organic material that we are doing, as he showed, are not only for photovoltaics, but they are for many other stuff. I got my first nature photonic paper where we did the same material that we use for organic photovoltaic. We use it also for thin film polymer light emitting diodes, which help us to have a nature photonic paper. So you have many other things. I use those material to do arts and science. So this field of research is so interesting, colorful. I love it. So I encourage Petro to go in that direction, and I thank you for your slide. They are so educative. I hope you will share it. You will send it to us to share it to everybody, because through you, I'm getting the state of the art on photovoltaics and so on organics. So thank you very much, Petro. Yeah. Okay.
I'm on your side, Jerome. I've been an organics guy for my entire career. Don't worry.
Yeah.
All right. Okay, thank you very much for your contributions. I think we have to move on. We are almost 10 minutes behind our time schedule. I would like to invite the next presenter, that is Emmanuel Kingel. Is he there? Emmanuel?
Yes, please, I'm around.
Okay, you are invited to present to us the techno-economic feasibility analysis of grid-connected PV systems using monofacial and bifacial modules in public senior high school in Ghana. The floor is yours. Thank you.
Okay, thank you very much. Okay, so my name is Emmanuel Penjodanko from the Kwame Nkrumah University of Science and Technology, and I'll be presenting on the topic techno-economic feasibility analysis of grid-connected solar PV system using monofacial and bifacial models in public senior high school in Ghana. And this is going to be my presentation outline, starting from background, problem statements, aims and objectives throughout to our recommendations. For background, so currently, Ghana will largely rely on non-renewable energy sources, particularly thermal and large hydro, with thermal representing about 66% of the electricity generation mix, large hydro representing 33%, while the renewable subsector has about 1%. So due to the overdependence on non-renewable energy sources, there has been a release of harmful gases such as carbon dioxide, methane, nitrous oxide into the atmosphere, leading to climate change, global warming, and greenhouse effects. Additionally, the cost of electricity from these non-renewable energy sources are very expensive, making it very difficult for most institutions to operate, especially the public senior high schools. So currently, the Electricity Company of Ghana, they are in charge of distributing power in Ghana. They disconnected the infantile secondary schools. And the reason was that they were owing electricity amount of $20,937.75. So due to this adverse effect from non-renewable energy sources, it is paving way for renewable energy sources, particularly solar, due to its ability to provide clean, cost-effective energy with zero or almost zero emission of greenhouse gases. However, the big question is utilizing energy from the sun requires the use of PV models, being it monofacial or bifacial. So the big question is which models should we use in Ghana in adopting energy from the sun? Various researchers try to compare monofacial and bifacial, and Yakubu and all realized that the bifacial gain in West Africa, of which Ghana is in West Africa, is between 5.65% to 10.15%. However, their study did not conduct techno-economic analysis to scale the effects. Again, Yakubu and also realized that when PV models are tracked, they yield better performance compared with models without trackers. And again, they did not conduct techno-economic analysis to scale its effects. Therefore, we realized that currently in Ghana, most public senior high schools rely on non-renewable energy sources, and they suffer high electricity tariff, unreliability of power supply, emission of greenhouse gases. And to talk about it, recently I went to Presbyterian Boys Senior High School where I completed my secondary education for my certificate. And they needed to go through the system to check whether I owe school fees or not. And it was a broad daylight and there were no lights in the school. So I had to wait for about 2 hours and still the supply was not coming from the ECG. So I was asked to go home. So the big question I asked myself, why don't we integrate solar into the grid of the school? Additionally, there's limited study on techno-economic analysis of monofacial and bifacial PV system in Ghanaian's public senior high school. Therefore, this study aimed to conduct a techno-economic feasibility analysis of grid-connected PV system using monofacial and bifacial PV system with a specific objective of one, we want to assess the current state of energy consumption in the Ghanaian's public senior high school. So we want to know where they are getting their consumption from. Then once we assess the current state of the energy consumption, we design grid-connected PV system for these public senior high schools using monofacial and bifacial models. So once after the design, we perform simulation using PVC software to see how our system will perform. Then we conduct financial analysis based on comparative results from the monofacial and bifacial PV systems. So the methodology, Though there are several public senior high schools in Ghana, but in our research, we made use of Presbyterian Boys Senior High School due to the availability to obtain data. And the school is built on approximately 85 hectares plot of land. About 65% of the land is used, whilst the remaining 35 is covered with green vegetation. So methodology, we categorize the methodology into two: technical assessment and financial assessment. So we wanted to see technically, is this integration of solar feasible, and financially, will it be cost effective to integrate solar? So for technical assessment, we are looking at the site assessment, solar radiation, selection of PV components. Then for financial assessment, we're looking at the cost of the PV models, the current rate of electricity in Ghana. Then we simulated with PV-SYST. And from PV-SYST, after the simulation, we're looking at the indicators from the technical analysis resulting to reference yield, capacity factor, long-term performance. Then for financial indicators, we are looking at the payback time. That is the number of years it will take the system to fully pay itself. Looking at levelized cost of electricity, return on investment. So for technical assessment, the various rooftop of the buildings were assessed, and we realized that most of the buildings are detreated and of complex design, making it very difficult to install the panels on rooftop in the school. In view of that, an area of 1,500 meters square as seen in the project area be cleared and covered with white sand, and the reason is to increase the surface reflectance of the on ground. Then we need to know the meteorological data in the school. So since there's no on-site weather monitoring station at the school, we resorted to the default PVC software database as seen. Then to integrate solar into the grid of the school, we need to know the amount of energy that the school consumes. So we took upon ourselves to take the readings by plugging Fluke Energy Analyzer Plus into the school's power system for a period of 1 month. That is starting from 6 March 2024 to 6 April 2024 to know the amount of energy that the school consumes during daytime. So we realized that during the daytime, between the hours of 8 a.m. to 5 a.m., the school consumes energy of 23.513 megawatt hour. So once we know the amount of energy that the school consumes, we need to select PV models, and we selected models from Trina Solar, and the reason being that they are available in the Ghanaian market and cost effective. And for model capacity of both system, monofacial and bifacial, we consider the same capacity: monofacial 584 watts, bifacial the same 584 watts. And in terms of inverter, we decided to use inverter from Terro Eco, and because they are also readily available and it has high efficiency. So a capacity of 50 kilowatts, we decided to use 3 of them. Therefore, to design of the PV system. So for us to design a PV system, we need to know the maximum or active power that the school recorded during the daytime. So between the hours of 8 to 5, we realized that all the phases, the 3 phases, summing up, we had about 183.28 kilowatts. So in view of that, we decided to design a PV system using 2 scenarios. And the first scenario is design and simulation of 190 grid connected PV system using monofacial models. Then again, we also designed and simulated 190 kilowatt grid connected PV system using bifacial models. And here for both design, we used AutoCAD for the design and PV-SYST for simulation. And so this is the design of grid connected PV system using monofacial for the school.
Emmanuel,
so hello.
Emmanuel, can you round off in 1 minute?
Okay. So this is the design of the school using monofacial, and that of the design using bifacial. Then for financial analysis, we consider the cost of the PV system, and we realize that the cost of the bifacial is quite large compared to the monofacial. And again, these prices were taken from Tino Solutions. So for results, we realized after the simulation, we realized that for total energy yield, the bifacial outperformed that of monofacial. In terms of performance ratio, the bifacial giving us a performance ratio of 92.4%, whilst the monofacial gave a performance ratio of 83.1%. So this is a graphical representation of the results. So in terms of the total energy generation throughout the year, the bifacial performed better than the monofacial, same as compared to performance ratio and capacity factor. Then for financial analysis, we use PV6 for the financial analysis to see whether this project is cost effective. And for payback time, using at the current rate of electricity in Ghana, which is $0.14 per kilowatt, we realize that the payback time of the monofacial is 6.9, that of the bifacial is 7.4. And here we try to vary the tariff, because in Ghana, the tariff has been increased, keeps on increasing within the year. So we realize that as we increase the tariff, for payback time, it reduces for both monofacial and bifacial. Then in terms of internal rate of return, as the tariff increases, the internal rate of return also increases. The same happened to the net present value return on investment. Then in terms of emission savings, the grid connected PV system in scenario 1 saved 1,200.91 tons of CO2. Then the bifacial saved 1,380.194 tons of CO2 emissions. So this, using the current rate of electricity, the payback time for monofacial is 7.4 years, bifacial is 6.9. This, the net present value for bifacial is 84,062.54. That of monofacial is 29,387.33. Then the important parameter, which is the levelized cost of electricity. In terms of the levelized cost of electricity, the bifacial gave $0.112 per kilowatt hour, and that of the monofacial gave $0.128 per kilowatt hour. So in conclusion, considering all the financial matrices, the LCOE, payback time, internal rate of return, and MPV, and the technical matrices, which is the total energy yield, final energy yield, performance ratio, the bifacial PV system in scenario 2 outperformed the monofacial PV system in scenario 1. Therefore, the bifacial system's superior efficiency and economic benefits makes it a preferable choice for maximizing return on investment and overall profitability of solar energy projects at Presec Legon. Thank you.
All right. Thank you very much, Emmanuel, for your very brilliant presentation. 1 or 2 questions from the participants.
Yeah, thank you. If I can go first.
No, we were asking if someone has a question.
Yeah, I'm saying I have a question to Emmanuel.
Yes. Go very fast.
Yeah, Emmanuel, thank you so much. If I understand, this is which level? Is it a master's study?
Yes, please. Yes, a master's study.
Yeah, I think I must first of all commend you for the effort. I'm so keen on the bifacial, because from your summary, the bifacial will be the best option. But maybe you could tell us, because you're talking about a grid-connected system, and when it comes to bifacial, it's very sensitive to the reflective surface. So I'll be keen to know which reflective surface are you talking about? Is it vegetative? Is it roof, maybe like iron sheets? Is it gravel? So if you could just shed some light on that, and maybe also bifacial being sensitive to the surfaces, but it's also sensitive to the tilt and also the elevation height. So if you can shed some light on that.
Okay, thank you. So if you, for my presentation, I said the ground, we are going to use an area of 1,500 meters square, and the land will be covered with white sand. And the reason is to increase the surface reflectance, which is the albedo on ground. So here we want to use a surface whereby you cover it with
I think
definitely
you
use white
Emmanuel,
sand.
you have answered my question.
Okay. All right.
But
Okay.
just
Thank
do
you.
more studies on the best optimal reflective surface for bifacial.
Okay. Thank you very much, David, for that intervention.
Jerome, you've muted yourself.
Sorry. Yeah, I was saying thank you very much to David for his intervention on the presentation by Emmanuel from Ghana. And I was welcoming Emanuela, who has just joined us. And I would like her to briefly introduce herself and then take the moderation of the last two presentations for this session. Thank you, Emanuela. The floor is yours.
Thank you so much, Dr. Jerome. And thank you, Prof. Daniel, for the opportunity to co-moderate and be a chairperson for the photovoltaic session. My name is Emanuela, MPhil Renewable Energy graduate from KNUST, Kwame Nkrumah University of Science and Technology in Ghana. And next, we go straight into the presentations after. Thank you so much, Emmanuel, for such a wonderful presentation. So next to present is Dr. Milmo Amos Nalianya, and he's from the Department of Physics from Masinde Muliro University of Science and Technology in Kenya, and his presentation is on interface study and charge carrier dynamics. Doc, please, if you are ready, kindly take the floor and present. Thank you.
Hello, thank you for the welcoming notes. I hope you can hear me.
Yes, we can hear you.
Yes, please.
Thank you. I would like to welcome you to my presentation on interface study and charge carrier dynamics in 2D, 3D heterostructured mixed cation lead mixed halide from vanadium cesium lead iodide bromide perovskites. My name is Milimo Amos from Masinde Muliro University, as introduced, in Kenya. So perovskites have gained interest in the renewable energy or solar energy research community due to their high performance in power conversion efficiencies, almost rivaling the market dominant silicon-based solar cells. But the three-dimensional perovskites that are performing well in the laboratories and the cells are inundated with some challenges on exposure to oxygen, moisture, and high radiation like UVVs. So some scientists have come up with ways in which they can enhance their stability, because they will usually degrade on exposure to those environmental conditions. And some of them are employing what you call cross-linking agents that can enhance or hold the molecules together. Others will play around with the cations, the chemicals that we use in building up the perovskite structures themselves. So they will exchange or replace them with other chemicals in the periodic table just to enhance the stability so that they don't degrade. But what we are interested in from this research is we have another dimension or another structure of the perovskite, which we call the two-dimensional perovskite, where we can introduce organic spaces, organic molecules, bulky organic molecules, into the layers of the 3D perovskite. And the 3D perovskite, as I alluded earlier, has a good performance, but its challenge is the degradation part. The 2D perovskites don't really have high degradation or exposure to the environmental conditions. So we would like to leverage on the two properties so that we can enhance the stability and also capture the performance. So we set out to build a 2D on top of a 3D. So basically a 2D has different dimensions. We can have the organic spacers slicing one layer of the lead halide octahedral layers of the 3D perovskite, or they can slice 2 layers or 3 layers, and so on and so forth. So those that can slice 2 layers are called Rudelsden Popper 2D perovskites. Those that can slice 3 layers and above We call them Dion-Jacobson 2D perovskites. We could also have a mix of organic spacers so that they give us another structure alternating cation interlayer spacing. So we set out to solve the problem of ion migration in the 3D, first segregation on exposure to the environmental conditions that I had alluded earlier, surface recombination, and degradation due to exposure to oxygen or humid environment. We also want to know the influence of two organic spacers. Most of the studies have done a single organic spacers and looked at their properties and influence on the optoelectronic performance. We set out to use a mixture of two, that is ethylene diammonium diiodide, which is a divalent molecule, and N-butyl ammonium iodide, which is a monovalent molecule. Each of them will contribute differently, so we want to also capture and leverage on the two. So we would like to see the effect of the ratios, because if we vary the ratios, the properties are also contributed differently to the perovskite that we get. So our objectives, as indicated, is to see the influence of the ratios on the morphology and crystallinity of our films, our 2D on 3D film. We get the optimal ratio that can enhance the optoelectronic performance. We also investigate the effect of on stability after long time storage. We store them and then we look at how they perform after some long-term storage. That's 2 months, 2 weeks thereafter. We also did some measurements, and we can see a very interesting feature that I'm going to share in the presentation. So basically, we took an ITO and cleaned it standard-wise with standard procedure. Then we deposited a 3D perovskite on it, but in two approaches, 3D on ITO via solution processing, that is spin coating, and we also got a 3D on the ITO via vapor deposition, thermal vapor deposition. Then now we have two, solution processed and vapor deposited. Then we deposit the 2D layer on top of the 3D, one that has been solution processed and one that has been vapor deposited. We just wanted to see the influence also of the deposition approaches. So here is a schematic of the deposition procedure. So at A, we first deposit on the ITO stoichiometrically measured 3D precursor, which we spin, dynamic spinning, 2-step. Then 5 seconds to the end of the deposition, we bring an anti-solvent, that is anisole. Then we hit the 3D perovskite structure, which gives us the black faces we are seeing in diagram B. The B diagram is the solution processed. The C diagram is the vapor deposited 3D perovskite structure. Thereafter, we deposit 2D perovskites on top of the 3D. And again, we anneal them for 5 minutes at 100 degrees Celsius to get the 2D on 3D perovskite film. Thereafter, we go to characterize, and we looked at the UV-Vis characterization, PL and TRPL, that's photoluminescence and transient photoluminescence. We also looked at photoluminescence quantum efficiency, scanning electron microscopy, and XRD. So on your page, you are seeing the UV-Vis spectra, and we can see that the ratios of the ligands, the binary or double ligands in the 2D perovskite, varied 1.5 milligrams of ethylene diammonium diiodide, then 0.5 milligrams of N-butyl ammonium iodide. So allow me to call it a di and bi, and the ratios, like the first one, to call it 3:1, a di bi. The second one, the red one, is showing 1 milligram and 1 milligram. So this is equal ratio, a di bi. Then I have 1:3, a di bi. Then lastly, we have the pristine 3D without the 2D on top. So we like to compare the two. So looking at the UV spectra here, we can see that the equal ratio, the red graph, is performing well. And we would like to attribute this to the limited conversion of the 3D layer to 2D by this ratio of the ligands. And this creates a quasi 2D nature on the surface, which has a mixture of 2D and 3D structures, and this creates a high scattering and reflections in the surface layer that we've created, and this enhances a longer path length for the light, and it enhances absorption of this light because of the reflection and backscattering of the quasi nature created. That is not a highly crystalline material, and that ratio of 1:1 is the one that we attribute this high absorption to. The pristine one is the one following, followed by the 1:3, then the 3:1 film in that manner. So we're interested in the 1:1 or equal ratio by a dye because of its performance in the subsequent characterization. For instance, we looked at the microstructure by the scanning electron microscope. We can see the top surface morphology. The first one is a 3:1, a dye by, which we can see it has some cracks in it, and we can see that the structures have some hollow structures. If you look at the grains, you can see some darkenings which are hollow, and we are attributing these to the high dye content, the 3:1. 3 is for 1.5 milligrams of dye, and 1 is 0.5 milligrams of bi. And these hollow structures were also reported by Weijun et al. In 2017 and Senocrat et al. In 2021, again by using a dye on 3D perovskite materials, and they attributed it to high content of a dye, which we have also seen here. The B, we're showing equal ratio film of the divalent or the binary organic spacers on the 3D, and we can see that we have a more compact structure, just like the C1, which is a B is 1:1 and C is a 1:3. We can see a compact structure, albeit C having smaller grains than B. So as we come from A to B to C, we decrease the ratio of a dye or ethylene diammonium diiodide and increase the ratio of bi. So increase in the ratio of bi here, we've achieved smaller grains at C. Number D is the pristine 3D without the 2D on top. We can see it has large grains. Large grains are good, but the 3D is still inundated with the challenges of exposure to or degrading on exposures to those environmental conditions alluded earlier. So our best performing large grained equal ratio B is our favorite because it's offering longer lifetimes because of the grains that are being large, charge carrier lifetimes before they reach the grain boundaries, unlike the 1:3 film. And moving on to the photoluminescence performance. As alluded earlier, we had a 3D that was vapor deposited and a 3D that was solution processed. So A is showing vapor deposited 3D with 2D on top, 2D similar conditions, same variations. We can see that the equal ratio, 1:1 a dye by, and 1:3 are having the highest intensities in terms of photoluminescence, photoluminescence on the vapor deposited 3D. Diagram B is comparing the 3D of solution processed and the 3D of vapor deposited, both of them having the 2D perovskite layer on top. And we can see the top 4 graphs are having for solution processed, while the lower ones, 4 graphs, low intensity, 4 of them are for vapor deposited. So we realize an interesting feature here where the solution process is showing higher PL intensity. But now in terms of performance of the ratios, equal ratio is leading with or equal footing with a 1:3 on the vapor deposited film. But if we compare on the next slide, diagram C is showing the solution processed extracted now. We can see that the red one is trailing all of them. It is now at the bottom for solution processed 3D, but with the same conditions on 2D. So we are attributing these to the nature of the solvents being used, that is for DMF and DMSO mixed together as solvents in creating the 2D solution process 3D perovskite material. which influence or bring about what we call solvent engineering, because when the formation or crystallization of the perovskites will have some intermediate structures because of the evaporation of the solvents as we heat them, so that we crystallize them. The grains are formed, then they crystallize to form the 3D structure. So the vaporization of the solvents influenced this low performance at this ratio. And this ratio is that initial measurement after deposition of the films. So we see that on solution processed, the equal ratio film is trailing the other films. The top performing is the 1:3 film again. We also looked at how they performed in terms of time-resolved photoluminescence. And again, looking at diagram D, we have 4 graphs doing well in terms of PL intensity, and the other 4 trailing. The other 4 trailing are the ones on vapor-deposited films, and these ones at the top are the ones for solution processed. And looking at the top performing, because we gain interest in the high performance films, so we are narrowing down to solution processed films. Looking at the top one, we are seeing the 3:1 film having a better performance. The equal ratio film is now trailing in the solution processed, because we are attributing these to the channeling of the absorbed energy, because initially at the UV spectra, we saw that the equal ratio film was the one absorbing highest, but now it is trailing. So it can absorb because of the quasi 2D nature, but it's not giving out the absorbed energy. So it is doing it non-radiatively at this point. Again, we are attributing that to the quasi 2D nature of the film, which is limited transformation of the 3D to 2D phase. So that is how they performed at this point. We didn't really get concentrated on the vapor deposited 3D films because of their low performance in this comparison. So we went ahead, and after storage of 2 months and 2 weeks, that's averagely 1,700 hours, we see an evolution in the performance of the solution processed films, 3D solution processed with the 2D on top. Looking at our PLQE, that is photoluminescence quantum efficiency box profile here. 1A
please,
is...
sorry, there should be a wrapping up because of time.
Okay, thank you. Let me finish up quickly. So the 1A is a 3:1 film. 2A is the equal ratio film, which is having the highest performance of PLQE, which means it has evolved with it has a higher charge carrier diffusion time, and we also have enhanced film crystallinity or morphology in this film, which was performing poor and TRPL. So it has enhanced or gradually evolved to give better performance of PLQE after storage. And we want to attribute these to the double or divalent nature or bonding nature of the ethylene diammonium diiodide it has, and the ratio, which is the optimal ratio for this effect to be realized. So there's a leveraging of the monovalent and divalent properties of ethylene diammonium diiodide and butyl ammonium iodide. Lastly, we looked at the XRD spectra, and diagram A is initial after deposition. Diagram B, we considered the vapor deposited 3D, but if we want to do a better comparison, we'll do diagram A and diagram C. Diagram C is after 1,700 hours or after 2 months of storage. We see that the red graph in A had low peaks or lower crystallinity, but the peaks have enhanced in their intensity after storage. And we are attributing these on the solution processed films due to solvent engineering, that is Ostwald ripening, where the 2D crystals will dissolve in the residual solvents after we've annealed our films, then redeposit on energetically favorable grains of the 3D to enhance their crystallinity. For instance, if we narrow down to the 100 peak, which was lower than 110 peak in the red one, that is the equal film of our interest, equal ratio film, we can see that after deposition, the 100 film is now having a higher intensity. So that is enhanced crystallinity, and we are attributing that to the solvent or the ostwald ripening, where the smaller grains will dissolve and redeposit, influenced by the Biden-Dart property of the ethylene diammonium iodide. And we also leverage that with the butyl ammonium iodide. Butyl ammonium iodide is hydrophobic, while ethylene diammonium iodide is hydrophilic. But we have this enhanced performance after storage, and we see a degradation 3:1 film where, for instance, if we go back to the PLQE performance, the 3:1 film shows a very low PLQE. We're attributing this to degradation because of the high content of ethylene diammonium diiodide, which was also influencing the hollow structures that we had seen at the SEM structure. So this is a preview of what we did. Our study was done at Clarendon Laboratories at Oxford University under the sponsorship of the Africa Oxford Initiative in collaboration with the MasterCard Foundation. So these are the pics. The one on the left is in the solution deposition lab under Professor Henry Snaith. The one on the right, that's me in the vapor deposition laboratory. So thank you. That's a walk around of the structure.
Amazing.
Yeah, thank you. Thank you. I welcome
Thank you
your
so
comments.
much. Thank you so much, Prof, for such a wonderful presentation. Because of time, we'll just take one question, if there's any. Okay. Okay, then we'll move on to the next presentation. And the next to present is Dr. Manel Hanaki and Professor Zai Ruban. They are from the Laboratory of Physical Chemistry of Materials, University of Amar Teldi, and University of Mohammed El Bakar El Ibrahim, all from Algeria. Please, you can take the floor and move on with your presentation. You are welcome. Please, is Dr. Manel?
It seems as if they are not here. I'm not seeing her in my list.
Okay.
Now, if they are not, let me check. I'm not seeing her. Okay. So, then we've gained time. Let me see, the break will have been from 11:25 to 11:40. So it's okay with the time that we lost, we can regain it now. So what I will do, I will ask all of us, those who are here, to put on their, before we go for the break, want to do a group picture for this moment, and then we go for a short break of 10 minutes and come back and continue. So I'll ask everybody to put on his camera, and myself, and let me see. I will try to. I have to put my camera myself also. Catherine, can you put on also a camera? I don't know. You are supposed to do, let me see. How do I do this? Retake, okay. Yeah, retake. I'm trying to use my system, take photo. Zulassen. What I've taken is those who put on their camera. So you have to put on your camera for you to be taken. So let me go back again and try. Somebody else can also take take a photo. So you have to have zulassen, okay. Then I'll take another picture. Yeah. Then download. Okay. I hope I've taken two pictures. Okay. So we have a short break until 11:40.
Is it possible to take the picture again? I just want to check something.
You speaking? Retake.
Well, someone was requesting if you can take the picture again because I think it's Assumpta, she had an issue with her camera.
Okay, let me retake again and try. Take a picture. Create group picture. Retake. Take picture. Create group picture. Why am I seeing all my image? I'll download this one. I'll close the whole thing. I hope Catherine is also taking, I hope. Yeah, so it's not only me taking. Good picture. Two. Nice, it's fine. I think it's okay. I hope Catherine has taken some of the pictures, so you've taken some of the group pictures, so it's fine. And this screenshot. Yeah, we'll along the day we'll be taking more pictures. So okay, so we'll go for six more minutes to restart. So you can go and have a cup of coffee or anything, and then come back, ease yourself, and continue.
All right. Prof, please, there's a request from Dr. Nalianya regarding his presentation. Like while we are in the break, if there are any questions or comments on his presentation, he would really love to have the presentation that was on the perovskite. So please, members and participants, if there are any questions or comments, we would love to take it as an unofficial one while we are still in our break. If you have any comments as well, you could also type in the chat box.
No, I want to say, okay, he did the last two presentations, and all the presentations so far, this first session has been wonderful. I was so amazed about the presentation of WAITRO, which is more or less educative about organic electronics, and I could be updated on the last when it comes to efficiency of organic solar cells and so on. So I hope, WAITRO, you will send us the slide so that we can share with others. And then the other presentations from Ghana and from Kenya were of great interest from the students, and were well presented. And let me say well presented and you could understand, you can follow. There was some logic about how things were presented. I'm so happy that you did those presentations. So I think, so far I'm pleased with everything here. So if somebody has questions, we can ask to the last presenters.
Okay, I would also like to specifically request if it's possible for the slides of Dr. Nalianya to be shared, his presentation on the 2D perovskite. I have some research interest in it, and it would be glad to have his findings as a foundation. So, Doc, I'd be glad to have your presentation slides shared with me personally. Thank you.
Most obliged.
Okay, so what, as we said, everyone you will send your presentations to us. We'll transform it into PDF and then compress it and all the presentation and send to the participant. Yeah, so that what we are doing is we are doing capacity building so people can go through the various presentation and learn about update themselves in the various field, because you are expert in your specific field of research, and I think we are learning. We are not only here to present, but we are also here to teach each other. And so we are here students and lecturers or professors, all of us. We carry those both hat as student and as lecturer here. So I think for the next session, which will be session number 6, photovoltaic 2, we are now in 3 minutes time. It will be chaired by Dr. Victor Dari and Judith Letswa Lo. So Victor is there, and Judith, are you around? Yeah, she's also around. Judith, can you say hi?
Hello.
Okay, you are there. So because you are chairing together with Dr. Victor Odari. And Victor is there.
Yes, hello, how are you?
I'm fine.
You said in the next 3 minutes, so I believe we are taking a short break.
Yeah.
Good.
And the presenter can already share his screen so that we can gain time. Because I think it's you can already start introducing the person so that we gain time. We have 1 more minute for starting, but Victor can start, I think.
Okay, thank you everyone. Welcome to our 6th session. And our presenters, we have 5 of them. 1, 2, 3, 4, 5, yes. So the first presenter will be Sefako. Sefako, are you there?
Yes, I'm here.
And you're also going to share the session with Judith. So Judith, you will take, do you want 2 or 3?
2 is fine.
So I'll take the first 2, you take the last 3. Great. So Sefako, kindly, please confirm that you are with us.
I am here.
Great. Kindly upload your presentation.
Is Tebogo who is presenting?
Yes.
Is Tebogo from
Sorry. It's Tebogo Selema. Great. So Tebogo is going to present on the combined effect of thermal treatment and cerium doping on black titanium dioxide particles for perovskite solar cell applications. And he's going to do that in hopefully less than 15 minutes so that we can have 1 or 2 questions for your presentation.
Can you please confirm if it's visible?
Yes, I can see your screen and you can start.
All right, thank you very much. Allow me to greet you all, ladies and gentlemen. My name is Mr. Tebogo Selema, and I'm from
Sorry to interrupt, your voice is a bit low. Kindly be a bit audible.
Okay. Allow me to greet you, ladies and gentlemen. My name is Tebogo Selema, and I'm from Sefako Health Sciences University in South Africa. And I'm going to be presenting a portion of my master's study, which I have titled The Effect of Thermal Treatment on Cerium-Doped Black Titanium Dioxide Nanoparticles for Perovskite Solar Cells. So this study my table of contents, and these are the points that I'm going to cover throughout my presentation. You will see them unfold as we get into the contents. So first of all, the question we should be asking ourselves is that why did we use black titanium dioxide instead of the conventional white titanium dioxide? Well, from research, we know that the white titanium dioxide has been commonly used in perovskite solar cells as an electron transport layer, which promotes the collection of photogenerated electrons from the perovskite layer to the bottom electrode, as well as suppressing recombination. However, this titanium dioxide has some drawbacks which are associated with it, and that includes the large band gap, which ranges from 3.0 to 3.4 electron volts, and also the fast charge carrier recombination, which generally limit its application in solar cells. So with an attempt to mitigate or come up with an alternative material for the ETL, we opted for the black titanium dioxide because it was reported to have superior properties compared to the white titanium dioxide, and that includes the reduced band gap of approximately 1.54 electron volts, and that also allows it to potentially harness more solar energy and increase the overall efficiency of the solar cell. Furthermore, we doped this black titanium dioxide with a rare earth metal, which is cerium, and reason being is that this cerium exists in 2 oxidation states, which kind of provides the stability and durability to the material, and it also acts as a recombination centers and also has a high refractive index. So in terms of the synthesis method of this material, we had 2 beakers, of which in 1 beaker we were preparing the titanium solution by mixing 2 grams of cerium with 10 milliliters of titanium tetraisopropoxide together with 40 milliliters of ethanol. And in another beaker, a dilute nitric acid was prepared by mixing 10 milliliters of nitric acid with 14 milliliters of distilled water. So these solutions were allowed to stay at room temperature for 1 hour. Then after 1 hour, the dilute nitric acid was then added into the titanium solution dropwise, and the solution was then stirred for 6 hours up until there was a formation of a gel. This gel was then dried for 24 hours in an oven at 80 degrees Celsius. And then after that, we had some yellowish aggregates for the material titanium dioxide, which was then put into a furnace to allow hydrogenation to take place up until we had black titanium dioxide. And in terms of our sample size, we only used 5 samples for the study, of which we went further to study the properties of this material. We kept one as prepared. It was not subjected to any heat treatment. So when we did our X-ray diffraction, we saw that from the XRD spectra, we were able to see that we were able to synthesize a anatase phase, meaning when we synthesize our material, it was in a pure anatase phase. And we see that because of the that is, peaks are even smaller. The intensity of the peaks are even a little bit weaker. However, as we continue to anneal this material, we see an improvement in the peaks at 400 and it's actually 650 degrees Celsius. We see now there's an improvement in terms of the peak intensity, and they're becoming more narrow compared to the ones that was annealed at 450. And then when we further increase the temperature to 600 or rather 850 degrees Celsius, we see 3 things happening at that particular stage. Number 1, there was a phase transformation from the anatase to the rutile phase, which is reported to take place at temperatures above 800. Number 2, we also see that there is a presence of the cerium dopant in the material. So meaning now our cerium became well crystallized with the material when it was annealed at higher temperatures, right? However, also another thing is that the peaks are now narrower compared to the other ones, which suggests that the crystallinity of the material is now becoming improved. However, when we anneal, when we further increase the temperature to 1050, we saw a reduction in the PL intensity, and the cerium peaks that were noted at 850 are no longer there. But at 1050, we now see the emergence of the brookite peaks, which result in us having a mixed phase of rutile and brookite, and as a result affected the intensity of our peaks. So furthermore, we continued to estimate the average crystallite size using the Shearer equation, and what we noted was that there was an increase in the crystallite size from 3.5 to 0.02 nanometer, and this increase in crystallite size suggested to us that there is an enhanced carrier mobility, and also potentially this material, as we increase the annealing temperature, potentially this material can have reduced defects in it. So we continued also to study the optical properties of this material, where we did our UVVs, and on our UVVs we're looking at the absorbance of the material. Initially, before it was annealed, there was an absorption peak at approximately 330 nanometers, but when we subjected this material to heat treatment, there was an improvement in a sense that now the absorption is shifting from 330 to 340 for the sample that was annealed at 450 and 650, and it further increases when we increase the annealing temperature, which suggests that annealing the temperature increases the absorbance of the material and causing it to move to longer wavelengths. We also went further to study, or rather extrapolate, the band gap from the UVVs, and for the band gap, we saw that there was a decrease in the band gap as well. Initially, the material had a band gap of 2.76 electron volts. Then as we continued to anneal the material at 850, we saw that the minimum band gap that we got was 2.11 electron volts. However, when we further annealed the temperature, when we further increased the annealing temperature to 1050 degrees Celsius, we saw that there was a slight increase in the band gap of the material, which was not a shock, because we remember from the XRD spectra the presence of the rutile and the brucite, that mixed phase of the rutile and the brucite phase also affected the intensity of the material. So hence even here we see that this material for this particular sample, there was an increase in the band gap of the material compared to the other ones. So furthermore, we also studied PL just to study the transfer of the photo-generated electrons, and this material was excited at 259 nanometers in the label that we see. Now, one see it extinguished between the two peaks that were annealed at lower temperature and the two peaks that were annealed at higher temperature. And the one at lower temperature, we see that there is a decrease in the PL intensity, and that was attributed to the higher density of defects as well as the cerium aggregation, meaning that the cerium dopant did not was not evenly distributed in the lattice of the material. So as a result, it was causing this aggregation and affecting the PL intensity. However, when we increase the annealing temperature, it is actually the opposite of so now is the density, and instead the special cerium dopant was able to disperse uniformly, be uniformly distributed along the lattice of the material, and as a result increase the intensity of the material. Then we also went further to do FTIR, of which figure A represents the material before it was annealed, and figure B represents the material after it was annealed at different temperatures. So before it was annealed, we see three major peaks which were attributed to the stretching vibration of the titanium and the oxygen element, and also the bending vibration as well as the stretch vibration of the oxygen and the hydrogen bond. However, when we annealed this material, there were no significant peaks that were observed, and this could be because there were no impurities and titanium, oxygen dopant. Lastly, we did TEM and SEM just to look at the morphology, the surface morphology, as well as the composition of the material. And what we saw was that there was an agglomerated surface morphology in the material, and this agglomeration was attributed to the force of repulsion that was produced by the cerium 3+ ions. Then furthermore, we did the SEM, of which we saw the fragments of clustered nanoparticles. However, when we annealed the material, we saw the formation of aggregates in the material. So after that, we went further to fabricate our solar cell device just to study the overall performance of the material in perovskite solar cells. So an inverted solar cell device was fabricated, and the diagram simply shows the deposition steps that were taken in that fabrication. So first we deposited the cerium doped black titanium dioxide on the ITO substrate. Then we went further to deposit the methyl ammonium lead iodide, which was our perovskite layer. Then also we spin coated with spiral using a two-step procedure. Then lastly, we deposited the gold on top of the on the substrate, making our inverted organic solar cell device. Then after that, we went further using a solar simulator to study the performance, the overall performance of the device, and just drawing your attention to the efficiency of the material. We see that initially, before it was annealed, the efficiency was sitting at 1.44%. However, when we continue to anneal the material at different temperatures, we see an increase in the overall efficiency of the material, right? So our maximum efficiency that we got was at 5%, which was for the sample that was annealed at 1050 degrees Celsius. So in conclusion, cerium doped black titanium dioxide was successfully synthesized and annealed at different temperatures. XRD revealed the presence of an orthorhombic. It was actually an evolution of structures. Initially, when it was in its anatase phase, it had a tetragonal structure. However, as we continue to increase the annealing temperature, we saw a change in the structure of the material to an orthorhombic structure. which can facilitate enhanced light absorption and scattering. Also, a decrease from 2.76 to 2.11 electron volts was observed in the band gap as a function of annealing temperature. And more importantly, the combined effect of cerium doping and thermal treatment resulted in an improvement in the overall efficiency of the device as it increased from 1.44 to 5%. And these are the following parties that I would like to acknowledge and thank my supervisor, Prof. Malevu, as well as the two institutions. Thank you very much.
Thank you, Salema, for making this wonderful presentation in less than 15 minutes, which is good, and also showing how promising the black TiO2 is. Funny enough, I met your supervisor recently, and it's good to see him here. So I want to welcome questions, 1 or 2 questions. Anyone with a question? Seemingly there is none for now. But I'll say this is a presentation, and you can actually try other absorber materials to see whether the efficiency will improve, but that is nice. So let's move to the next presenter. And our next presenter is Sewela. That name is tough for me. Segofatso, who is presenting on advancing perovskite solar cells, that is optimizing TiO2 graphene electron transport layers for enhanced performance and future standardization. Savella?
Good morning. I just want to confirm if you're able to see my screen.
Yes, I am.
Yeah, we can see it.
We can see.
Okay.
But there is another screen showing up again, covering your presentation. I don't know which one that is.
It's presented from your iPhone.
That's the power of iPhone.
Mm-hmm.
Okay. Is it fine now?
Not yet. Now it's Daniel's.
I'm not the one. She's the one playing with my picture.
I don't know.
If it's an issue, I hope it will not affect much of your presentation. Then you can start so that you can save time.
Okay. Good morning to everyone. My name is Tsakofatso Sewela. I am from the University of Sefako Makgato Health Science University in Pretoria, South Africa. I am supervised by Prof. T.D. Malevu, and I will be presenting a portion of my master's research titled Advancing Perovskite Solar Cells by Optimizing the Titanium Dioxide Graphene Electron Transport Layer for Enhanced Performance. The outline of my presentation is as follows. More than 80% of the world's energy mix is derived from fossil fuels. Fossil fuels are largely responsible for global warming, which is concluding 85% of the world's carbon dioxide emissions, and that they come from fossil fuel combustion. This has led to things such as the SDG development goals for clean and inexpensive renewable energy, including biomass, wind, and solar energy, which are strongly encouraged. Solar is the most attractive renewable energy source since it is easily accessible, abundant, and has a high prediction potential of becoming the main successor of fossil fuels. This is because the Earth receives over 174 tetrawatts of incoming solar energy continuously. According to the National Renewable Energy Laboratory chart of 2025, the first generation solar cells, which are the wafer-based, have a PCE percentage currently of 25 to 46%. However, this has led to the development of second generation solar cells, which are the thin films, because of their high cost. The second generation solar cells currently stand at percentages of PCE between 13 to 20%. This led to the development of third generation solar cells, which aim to bridge the gap between cost and high efficiency. Currently, the efficiencies for the third generation solar cells stand at 15 to 30%, being the perovskite solar cells, which my research focuses on. Why perovskite solar cells? Perovskite solar cells utilize low-cost materials and are inexpensive in their fabrication processes. They are compatible with lightweight substrate materials such as plastic. They have good mechanical and environmental stability. They are also very environmentally compatible. Titanium dioxide has been the most popular electron transport layer within the perovskite solar cell fabrication. This is due to its strong energy alignment level with the perovskite solar cell layer, its wide band gap, and its chemical stability. However, it has a lot of drawbacks and limitations, which are namely its low electron mobility, which leads to recombination of electron hole pairs, and the ability to only absorb UV light. This has led to many research prospects, such as the entirely replacement of the titanium dioxide electron transport layer with others such as zinc oxide. Others have also opted in research to find ways in doping and integrating other materials to improve and mitigate these limitations. This has led to my research of the doping with graphene in order to improve the limitations that come with titanium dioxide. In theory, graphene has the ability to, number one, with its unique properties, which are high carrier mobility, which in theory could mitigate the low electron mobility of the titanium dioxide. It has high optical transparency, high tensile strength, and the ability to improve stability and UV resistance. It also have the ability to improve the interfacial contact between the titanium dioxide layer and the perovskite layer. It also has zero bandgap semiconductivity, which is a good factor for photoconductivity of electrons within the electron transport layer. The synthesis of our titanium dioxide and titanium dioxide graphene nanocomposites was done using the sol-gel method, which offers high purity, homogeneous material, and low processing temperatures. In this process, we utilized two solutions, which were the TTIP and ethanol solution, and the distilled water and nitric acid solution, which were utilized and mixed together to form a gel, which was later dried at about 120 degrees to form our titanium dioxide nanocomposite, which was then taken and mixed at varying weight percentages of 4, 8, 12, 16, and 20% of graphene, and integrated together through a process of physical mixing, which was then annealed at about a temperature of 450 degrees Celsius to form our varying graphene titanium dioxide nanocomposites. Our perovskite solar cell was synthesized and fabricated using the sequential vapor deposition method, and we did a solar cell architecture of gold spiral, methyl lead triiodide as a perovskite layer, and titanium dioxide, and the varying nanocomposites of titanium dioxide graphene being 4, 8, 12, 16, and 20%. For our results, we used XRD to determine the effects of doping on the structure of our titanium dioxide. We found that during research, the as prepared titanium dioxide was related to the JCPDS code of 1272, which is the annotated. Sorry?
Please proceed. Amos, kindly mute.
Okay. We saw that it's related, which is the anatase form. Then we see as we increase the graphene content, we are able to see at the 101 peak that there is now an addition of a graphene peak, which indicates the successful integration of graphene into our titanium dioxide nanocomposite. Also, we see that there's an increase in the crystal size from 4 to 17 as we increase our graphene content within the titanium dioxide. This indicates that with increasing graphene content, it leads to an increase in crystal size, which could also mean, in theory, according to the research we've done, it could minimize the recombination rates and improve the electron mobility of our nanocomposites. We studied also the effects of UV transmission on the effects of doping on the UV transmission. As we can see from our UV spectrograph, with the increasing content of graphene, there is an increased absorption, the increase in the UV absorbance. The high UV absorbance could mean that there could be better electron transport properties, leading to improved efficiency. We can see from our graph that the 8% nanocomposite had the highest absorbance peak, as we can see. And from our results as well, we were also able to study the effects of doping on emission and excitation. From our excitation graph, we are able to see that the higher the excitation peaks get higher with the addition of the graphene, with the increasing content of graphene content. This could also suggest the enhancement in light absorption and the facilitation of charge separation. From the emission graph, where there is the 8% graphene content being the highest, this could indicate the improvement in charge transport that has begun and started. Also, we studied the effects of doping on our chemical composition, which we studied from our FTIR graph, from which we can see that we have 3 prominent peaks from our as prepared titanium dioxide, in which then we further see that the graphs are then now stretched out, but we can also still see the peaks that there is a successful incorporation of graphene into titanium dioxide, with still being the key peaks of carbon there indicated. From our SEM analysis, we were able to study the effects of doping on our morphology. From our first graph labeled A, that is the titanium dioxide as prepared, which we see a more homogeneous surface. At number B, we see our 4% graphene content graph, which we start to see a more rough surface occur. At number C, it's the 8%, which we see an increase in the roughness of the surface, while at D, with the 12%, and E and F, which are 12, 16, and 20, we see agglomerations, and this could also be then indicative of now a negative effect due to now the excessive addition of the graphene, which now these could also lead to charge trapping, which will not be favorable for our electron transport layer as we are trying to improve electron mobility. And we then did our analysis in terms of our electron properties, in which the PCE, we see a trend of increase in PCE with the increased graphene content up to the point of the 8% graphene content, in which then we begin to see a decrease, which could also be related to, as we saw in our SEM, that the agglomerations begin to become excessive. So this leads to the limitation and the drawback in our PCE, with 8% being the optimal PCE at 5%. For our conclusion, the graphene titanium dioxide nanoparticles were successfully synthesized. The structural and optical properties showed clearly that the synthesis of graphene titanium dioxide are good crystal quality. The study demonstrated the successful fabrication of solar cells employing the graphene titanium dioxide as an electron transport layer. The 8% graphene titanium dioxide indicated the optimal composition, and the solar cell with graphene titanium dioxide as an electron transport layer showed higher PCE compared to that which only had titanium dioxide as an electron transport layer. Thank you.
Thank you, Sewela, for also the good presentation that you've made and keeping time, doing it in less than 13 minutes. I wish to welcome questions, if any, 1 or 2 questions from the participants. Maybe as we wait for them.
A question. She mentioned in her introduction, you mentioned in her introduction that perovskite are environmental friendly. How can you explain it? We have the power of lead in the system. How is it environmental friendly?
Yes, in comparison to what we currently have as the non-renewable aspect, it is better. Also, with my research that I haven't indicated due to time, the graphene and the titanium dioxide reduce the degradation within the solar cell itself, which makes it more environmentally friendly, because it has what we call the photocatalysis, which now then reduces degradation within the solar cell itself.
My question is, does your perovskite have lead or not? What you are studying, or in general, because you gave a general introduction where you spoke about the perovskite and said they're environmental friendly as compared to other systems. But I would say I doubt it, because people are trying to make it environmental friendly by exchanging lead with something else. Okay, it's fine. Okay, just wanted to point out this aspect about the environment friendliness of perovskite. They are not so. It depends on, if you remove the lead, that will make it more, at least, environmental friendly. Okay.
Okay, thank you, Prof.
Any other question?
Can I ask?
Please go ahead.
Tell me, please, your effect of enhanced efficiency due to absorption in ultraviolet region, or enhanced injection due to graphene component?
I'm sorry, Prof, I wasn't able to hear your question properly. Can you please repeat?
Do you have effect due to UV absorption, or
Yes.
due to increase of injection?
Absorption.
Absorption. Okay.
Yes.
Okay, thank you.
Maybe the last question or concern for me is the doping level. I don't know whether we have a defined concentration whereby you can say it's up to this point that you've done doping, but I believe in most cases, up to 5% addition of impurity on a material is referred to as doping. I may be wrong, but above that, it could be some sort of alloying. So what's your understanding of doping and alloying?
Yes, I understand what you are trying to say, but I was doing it based off the previous research which had been done to understand the optimal point, which now has been determined at 8, of which then we will look into further now between that range, now lowering maybe the concentrations that which we are doping with. I understand what you're saying, which it does become excessive, so it's no longer considered doping.
Thank you. For the sake of time, I think we can move to the next presenter. Judith, do you mind taking from there?
All right. Thank you so much, Dr. Odari. My name is Judith Letwalo, and I'm an MSc student from Northwest University, South Africa. So if patients on the line with us, yes, patients, if you may please share your presentation with us. Thank you.
Good morning, everyone. Can you please see my screen?
Yes. May you please put it in a presentation mode?
Yes.
All right, there we go. Thank you.
So my name is Star Patient Stifu. I'll be presenting on 4 diagnoses using machine learning models. Can you please hear me?
Hearing you, we are hearing you.
Hear you.
Okay. So my name is Star Patient Stifu. I am from the University of Bamenda, and I'll be doing a presentation on 4 diagnoses in photovoltaic systems using supervised machine learning models, and a list of co-authors have been provided below. I'll begin with the introduction. Looking at the global context, energy is the backbone of every economy. Hence, there's been a consistent effort to look for more sustainable energy sources because, as we see on figure 1, the conventional energy sources such as coal and fossil fuels have led to what is called climate change. And we all know about the ravaging effects of climate change, which I'm not going to dwell on. And these have encouraged the transition to renewable energy sources such as solar, biomass, hydro, and wind, with a particular focus on solar energy. In the year 2020, over 760 gigawatts of PV systems were installed globally. Large-scale deployment of solar energy systems raises questions regarding maintenance and sustainability. Statistics shows that the failure of a model affects 18.9% of the system's power output. Hence, fault diagnosis is a crucial issue regarding the sustainability of PV systems. Now, when we look at machine learning, the advent of machine learning presents better options when handling the non-linear data, which is involved in PV systems. And this is because machine learning models make use of features and labels which can accurately classify data. For us to understand fault diagnosis, it is important that we have an understanding of the kind of faults that exist in photovoltaic systems. And these faults have been classified into 3 broad categories. The first one we look at are physical faults. Physical faults are typically faults that result from the frame or the structure of the solar module. It could be damage to the PV module, cracks in the module, degradation fault. These faults are all categorized as physical faults. When we look at the second category, environmental faults arise from the environment. This could be partial shading, permanent shading, which could eventually lead to hotspot faults. And lastly, we look at electrical faults, which are faults which result from the electrical wirings within the PV array. Now, looking at fault diagnosis, specifically using machine learning, we see that there are three data sources which have been used for fault diagnosis based on literature. And the first one is the non-electrical data, which includes visual and thermography data. Visual and thermography data are made up of images that are captured by unmanned aerial vehicles or specialized cameras. Now, when we look at electrical parameters, we have current and voltage values, which are either captured through sensors, or current and voltage curves, which are analyzed to determine the behavior of a system. Looking at previous works, we see that this topic is a prominent research topic. However, the current research, they present differences in terms of the features, the data sources, and the kind of faults that have been experimented or simulated. Hence, our research is going to be focusing on fault diagnosis using simulated data on the MATLAB software. For the procedure, we have an outline here on how this research was carried out, and the first thing we look at will be data acquisition. On figure 4 here, we present a PV simulation setup, which was done in MATLAB Simulink to generate data for our simulation. Here we have a PV array. Next, we have an MPPT inverter working on the perturb and observe algorithm. And next, we have a DC-DC converter to optimize the power output. Now, when we look at the PV array, an expanded view of the PV array is provided, which consists of a 6x3 PV array consisting of 18 panels, and each panel produces 414 watts, leading to a system of 7.5 kilowatts, which was used to generate the fault. Now, when we go to the data set, for us to analyze these data using machine learning, we had to attribute certain labels to the data set. So for this case, we had used 4 fault cases, 3 fault cases alongside a normal case, giving 4 cases for the machine learning training and testing. So for the first case, which was attributed class 0, we have a normal case. For the second case, we have a string-to-string fault, string to string fault, and eventually a partial shading fault. Now, when we go to look at the machine learning models, 5 supervised machine learning models and their variants were used. When we look at machine learning, we see that machine learning is divided into 2 categories. We have either supervised machine learning and unsupervised machine learning. The advantage with supervised machine learning here is because it makes use of features or labels which can be used to attribute certain classes to particular events. Now, the next thing we look at is the validation criteria. Based on literature, we have selected the cross-validation criteria of k equal to 5 and k equal to 10. In the case of cross-validation, what happens is the machine learning model divides the data set into k cross-faults, which are used to test and validate the data simultaneously. In the case of holdout validation, the data set was divided into a ratio of 80 to 20% to test and validate the data. Next, we look at is our results. Since we are looking at fault diagnosis, it's important we have an idea of the effects which these faults would have on the system. So figure 5 here represents the PV curve for all the fault cases which we are working with. We have figure 5A, which represents a normal case where we are looking at optimum power output of 7.5 kilowatts. And in the second case, we have a string fault. Here, we can see how much decline in power compared to the voltage is experienced whenever a string fault occurs in a PV system. And for case C, we have a string-to-string fault, and for the third case, we have a partial shading fault, which was obtained by varying the irradiance by 30 and 60% respectively. When we go to the next figure, figure 6, we have a representation of the IV curve for the 4 fault cases from the normal to the string fault. So this IV curve represents a correlation between the current and the voltage between the various fault cases. Now, when we move next to look at the performance of the machine learning model. We had earlier said that 5 machine learning models were trained, and these machine learning models are the 3 support vector machine, k-nearest neighbors, ensembler, and the neural network algorithms, and these are the variants. Now, when we look at the validation criteria, we see that all the validation criteria are presented for each algorithm. When we look at this table, we would see that the neural network obtains high accuracies or better accuracies, followed by the ensemble algorithms. In the next slide, we are going to look at the detailed performance evaluation based on the validation criteria. So here we are looking at, we are paying attention to the validation criteria and how it influenced the performance of the algorithm, both during the training and the testing phase. So here we have the crop. Yes, please.
May you please in 2 minutes?
Sure, thank you. So this here is a detailed evaluation of the machine learning training and testing using the validation criteria. Lastly, we have the most accurate algorithm represented here on a confusion matrix, which is another evaluation criteria which is used to evaluate the performance of a machine learning model. So just to say that the highlighted diagonal here represents faults which were correctly classified, giving an accuracy of 98.39%. To conclude, based on this research, the neural network and ensembles presented the best accuracy. And this research highlights that the performance of the machine learning models is dependent on the features and the validation criteria. Another thing worth noting is we made use of 3 features, which are the current, voltage, and power, which significantly affected the computational time of the machine learning models. And the neural network and variance obtains higher accuracies for testing and training the machine learning models. We want to acknowledge RAINCA, which supported this research, and these are a list of references which were used to carry out this research. Thank you all for your keen attention.
All right, thank you so much for the wonderful presentation on supervised machine learning models. Do we have any question or two for patients before we move on to the next presenter?
Yes, I have a question. Hello? Yes.
Yes, sir, I'm listening, sir.
Yeah, patients. I just want to ask, there are different type of neural network models, is it? Which particular one, you just called them variants, which particular one did you use?
Thank you, sir, for your question. If I can go back to this slide here, you'd see that I presented the variants of the machine learning models, and I went ahead to highlight the fact that the most accurate algorithm was the wide neural network. So we had used the wide neural network, tri-layered neural network, and a host of others, but this was the most accurate algorithm which we got, the wide neural network.
Okay, another question is, why do you think the neural network model was more accurate than the other models? Is it because you trained more data sets or what? Or the data sets you were training, were they the same? Or that's my question. Why do you think it was accurate than the other models?
The data sets, we trained the models using the same data set. Now, the neural network algorithm was the most accurate because of how the algorithm it's built. The neural network is made up of many layers which are used for the training. Unlike the other algorithms, which are made up, for example, compared to the decision trees, which is made up of leaves instead, the neural network algorithm is made up in such a way that the data is trained on multiple layers. Hence, it was able to
Yeah, but that's my question exactly. How many layers did you? There are multiple, but it has to have so many layers. How many layers did you use?
For the wide neural network, I said we trained a lot of neural networks, and each contains different layers. For example, the tri-layered here was made up of 3 enhanced layers. The bilayered made up of 2 layers which were enhanced. For the wide neural network, it was made up of multiple layers. However, a single layer was
Don't
given
worry.
more depth.
Maybe we can discuss that, because I just want to know how many hidden layers you used to do the thing. That's why you got so much accuracy, you know. Okay, thank you very much.
Thank
All
you,
right,
sir.
thank you so much. Thank you so much, Prof. Mawira, for the question. Thank you so much, patients, for presenting. Due to time, we will now move on to the next presenter, which is Dr. Henry Alombo. Dr. Henry, if you may share your presentation, please. Thank you. Dr. Henry, are you there?
It's not around. Let's just put, it's there, it's there. Okay.
All right. Is this Dr. Henry's slide?
Yes, yes, I think.
Okay. All right, please, you may proceed. Dr. Henry, you may proceed.
I think it's an audio problem, maybe.
Telling you, it is.
Okay, can you get me now? Can I proceed?
Yeah, you can proceed. Yeah.
Yes,
Lord,
please.
sorry for the delay. I said the presentation is based on an advanced Internet of Things monitoring system for real-time photovoltaic performance evaluation. We're concentrating on the conception, development, and experimental validation. The presentation follows a four-topic: design, introduction, methodology, results, and conclusion. There is a current energy deficit in Cameroon, particularly. This is general for most developing countries and the world at large. The situation of Cameroon is a little bit peculiar, and that is why this result or this research is focused mostly on Cameroon. The trend in the energy supply and energy demand in Cameroon is on the increase, and it's projected that by 2030, we need approximately 6,000 megawatts of energy. This energy deficit is evident in Cameroon and maybe in some less developed countries by power outage, load shedding, just to name a few of such situations. So to be able to handle these situations, we need to resort to renewable energy resources, and particularly photovoltaic systems fall under a class of energy resources that are widely used because of the myriad of benefits that they present. So for the purpose of this research, we're looking at the various problems that are involved with the installation of PV systems, particularly in developing countries. And as we all know, high initial costs is one of them, technical expertise, the lack of infrastructure. And we, for the purpose of this research, will concentrate on monitoring challenges. We understand that there is a lack of monitoring of infrastructure. Data collection is a serious issue, as well as the issue of remote location. So for the purpose of this research, we intend to develop a system where data can be collected, the operation of the system can be monitored remotely. So the objective of this work, first of all, is to develop an experimentally validate an intelligent Internet of Things photovoltaic system, and to be able to store the collected data locally and on a remote servers, which can be accessed anywhere in the world. Another peculiarity of the work is to be able to perform statistical operations on the data that is collected. For the purpose of methodology, figure 1 is a block diagram of the intelligent Internet of Things system that was designed, and the figure 2 gives us the packed electronic hardware. And for the purpose of the audience, this system is tagged trail monitor system because it's a kind of a 3-in-1 system. We have the hardware assembly, we have the desktop application, which is developed, and we also have the website, which is developed to be able to access the data remotely. Figure 3, the desktop application, it permits us to be able to sense 6 parameters, we can be able to sense the operating current, the operating temperatures, ambient temperatures, the module temperature, the relative humidity, and the irradiance, as you see on the desktop application. We also have a web application which permits us to be able to access, we can access the data, we can follow the evolution of the parameters anywhere in the world. For the purpose of this research, we did an experimental studies around the University of Chang, the west region of Cameroon, as you can see, and we collected data. The setup for the experiment is shown in figure 7, the trail PV monitoring system in operation in Chang. We collected data to be able to experimentally validate the instrument. So our results, to present our results, we started off by testing the sensors, calibrating the sensors appropriately, and then we moved on to the PV system performance results, and then we also tried to evaluate the website, the performance of our site. So for the purpose of sensor testing, as you can see in table 2.0, we were able to obtain very minute differences between the sensors and the reference instruments that were used for the purpose of calibration and comparison. We also observed, because we did the experimentation for 3 days in the rainy season and for 7 days in the dry season, so as to be able to compare the performance of our system across climatic seasons in Cameroon. So the experiment was done in the dry season as well as in the rainy season across Cameroon. As you can observe in figure 8, this is a screenshot of the data visualization of the app that was filtered on the 2nd of March 2024. So the app permits us to be able to collect data on the PV operating current, the PV operating voltage, the power, the temperature, ambient temperature, relative humidity, and the irradiance of the system. This is obtained concurrently with a time resolution of less than 1 minute. On figure 10 presents to us a screenshot of the app's graphical setting with PV temperature and ambient temperature highlighted. We want to note here that we could, at the discretion of the user, you can select the variables that you want to plot, and the app permits you to be able to plot the variables that you do select. Figure 11 is an experimental measurement of the ambient and PV module temperatures recorded by the Trail Monitor PV system for a 30-watt PV system on the 4th of March 2024 from 6 a.m. to 6 p.m. in Chang. The system also permits us to be able to collect data and plot it for various days. What you see in figure 14 is an experimental measurement of the system operating from the 3rd to the 5th of September 2023. And in figure 9, we would see an experimental measurement of the PV system recorded by the Trail Monitors device for the same 30-watt peak power system on the 3rd of September 2023. All the parameters can be plotted for the same time span that the user chooses. Then in figure 16, we did a study for 7 days from the 2nd of March to the 8th of March, and we're able to plot all the system parameters that were monitored by the system. A unique function of the system is the fact that we can carry out statistical operations using this app. We understand that solar information on the performance of a solar system is not too vital if we don't study it within some time zones. It is of great interest to know what is the average daily irradiance for a particular location, what is the average daily temperature for a particular location. So this app or this system permits us to be able to perform statistical analysis like the mean, the average, the median, whatever statistical value you want to get, you could get it from this particular instrument. So we want to conclude by saying that the developed instrument, it's a big breakthrough, particularly in the developing countries where data acquisition and monitoring is a big problem. And particularly in Cameroon, this is going to help a lot, particularly in solar installations, in the solar dryers, This instrument is going to help a lot in the acquisition of data relating to this. We want to note that we use the cost-effective sensors, and we also use weatherproof sensors. That is why we're able to carry out the experiment both in the dry season and in the rainy season, because the sensors we use are weatherproof sensors. So we think that this research is of great importance, particularly to the developing countries. And the instrument for the meantime costs just about $60, with the exception of the pyranometer. And we're looking forward to another experiment where we'll be able to replace the costly pyranometer with other algorithms or maybe with lock sensors that will permit us to cut down on the costs. So this is what we have on this topic. We use the following references to be able to enhance our work. We want to thank you for your keen attention.
Pure Sophia, may you please mute yourself? Thank you. Thank you so much for the wonderful presentation, Dr. Henry, and for kind of like bringing us back into keeping the time. May we please have a question, maybe two for Dr. Henry?
Yes, I have a question. Dr. Henry, thanks. The system is quite cheap. It's $60. What sort of pyranometer are you using? You remember you said it's expensive. I mean, there are cheaper versions that you could obtain. And the other question I want to ask is, what is the communication protocol that you're using? I mean, are you using fiber, GSM, and all that stuff for the new type of 3G, 4G communication protocols? And is it compatible with a cell phone, for instance? Sometimes you might not be you don't have access to a computer. Can you access the data via cell phone?
Thanks a lot for your questions. The first thing is that the desktop app, you can access the data on your cell phone as well as using your computer. Yes, that is permissible. That goes through very successfully. Now, you did ask about the pyranometer. We are using a silicon-based pyranometer, which cost us about $150. $150. One of the reasons why we resorted to that is because the spectral range of pyranometers is so important. If you go in for a cheap pyranometer, you might have 40 values of irradiance because it will not be able to cut across the spectral range. So we're developing a separate research on that to be able to cut down on the cost of irradiance measurement. This will significantly cut down on the cost of the instrument as well.
Yeah. Pyranometers are very expensive. Pyranometers are very expensive. We've actually done a study with one of our MSc where we've developed a low cost. Then, because as you say, the spectral range is not covered, we had to use artificial neural networks to correct the response so that it compares to a class 1 or a class 2 pyranometer. But anyway, it's a very interesting thing that will solve a lot of problems in terms of data acquisition, because data acquisition systems are very expensive. And I work with this type of things, and I know. Thank you very much.
All right, thank you so much. We will now have the privilege to hear from our last speaker of this session, which is Dr. Ambe Harrison. Dr. Ambe, are you ready? You may share your presentation. Thank you.
Hello, can you hear me?
Yes, I can hear you. If you may, yes, I can hear you. If you may, please put your key. Here we go. Thank you.
Can you hear me?
Yes, we can hear you,
Okay,
Dr.
thank you.
Harrison.
Oh, thank you very much. I would like to first of all express gratitude, thanking all those who have been involved in the organization of this program, and especially I thank Professor Daniel, the ANSOL, who has been doing a lot to advance the mission of ANSOL. And I'm really, really grateful for everything. And this piece of work entitled Bridging Data Scarcity in Africa, a novel synthetic climatic model for machine learning driven renewable energy optimization, was jointly researched by my humble self, Harrison, Jimbo Henry Alomba, Dr. Jimbo Henry Alomba, sorry, and Dr. Fenzi Mbazo. And I would like to say that before proceeding, this presentation is aimed actually at projecting the outcomes of the intensive research currently being undertaken in alignment with the problematic of bridging data scarcity in Africa. And it's actually a big issue because it's no news that Africa, especially the sub-Saharan sub-region, has a huge renewable energy potential. However, it appears that there is little or no concrete information with respect to location-specific renewable energy potentials. For instance, in Cameroon, we have no renewable energy map, so it's difficult to tell which location, which specific location precisely has potential for this renewable energy. So it's actually a problem. So going forward, that we understood that the problem of data scarcity is at the epicenter of this issue, and we have been working on trying to address this problem. And presentation, we are going to be addressing concretely the problematic of data scarcity in Africa, and to propose problem. Moving forward to the introduction of this work, we're going to mention multidimensional challenges facing specifically energy shortage and climate change. Of course,
I think Dr. Harrison is encountering signal problems. So I'm not sure if he'll be able to log back in and join us, but we can give him some few seconds.
Sorry, I
Looks like we lost him.
Yeah, this is Cameroon.
Please, can you hear me?
Yeah, we can hear you. Can you come back and continue your presentation?
Can you?
Yeah, we can hear you.
Hello?
Yeah, we can hear you. But you have to share your screen again.
Hello?
We can hear you, Dr. Harrison. May
Can you
you
hear me
please
now?
share your screen again? Yes, we can hear you.
Sorry.
Share your screen again.
Sorry for the network instabilities.
It's okay. Just share the screen with us.
Hello? Hello?
Yeah. Okay, continue your presentation quickly.
Sorry for the network interruption.
It's okay.
Yeah, I was saying that amidst the multidimensional global challenges, renewable energy stands as a turnaround remedy
And of course, it has multidimensional potentials to address all these multidimensional global challenges. And I can say that the world is experiencing a high adoption level of renewable energy sources, and there is actually a high penetration of REs in diverse sectors, electricity, heat transport. And last year, the International Energy Agency showed that PV and renewable energy actually has a very, very bright future globally. And according to projections, in 2026, wind and solar power generation will both surpass nuclear power. And by 2030, renewable energy sources will contribute to 46% of global generation. And just to say that this will represent about 90% of increase from the year 2023. And this would be sufficient enough to meet the combined energy demands of the United States and actually China. This is actually to say that renewable energy has a wonderful future. And we are going straight forward to a literature. And I would like to say that and the main outcome of contemporary research spotlights the variability of renewable energy sources. It's actually a serious concern because it brings a lot of issues on the picture. Firstly, the grid stability and reliability issues, because in high renewable energy penetration grids, we face the problem of fluctuations in renewable energy sources, and this has serious issues. And equally, the problem of the need for energy storage, because renewable energy are not continuous. We need batteries and storage devices to address this. And this other concerns are actually summarized in the table presented. We are not going to overemphasize on that. And in terms of, as a continuation of the outcome, talking about the variability of renewable energy sources, we just want to mention these two pieces of work. Firstly, by Kabi et al. They actually underscore the intermittency of renewable energy sources and their impact in power system operation, precisely energy curtailment and price volatility. In fact, Kabi et al. Examined the impacts of renewable energy covariability across multiple spatial and temporal scales on the New York State power systems. They highlighted that with a variability of just 17%, annual average electricity price variability was induced by up to 9%, with about 56% variation in the frequency of price peaks. And this is just to emphasize that the variability problem, the renewable energy variability problem, is a serious issue. And equally, Stoop et al. 2023 emphasized the importance of understanding climatic variability, where they proposed a new climatic variability index. And still within contemporary research, another issue posed by variability of renewable energy sources is actually at the level of operational level. For instance, in photovoltaic systems, climatic variability CV causes probabilistic variation of the maximum power point, and this actually complicates maximum power point tracking or photovoltaic systems optimization. And here we want to what's happening here? Here we want to look at briefly look at the survey on how we can address the CV problem, the climatic variability problem. It's worth mentioning that it's actually complicated to directly tackle this problem because we are faced to an intensively stochastic problem. And amidst this complication, it's possible to augment the efficiency of renewable energy systems. In this light, intelligent paradigms have revealed potency in addressing this problem in terms of efficiency optimization. In the same light, machine learning models like artificial intelligence have gained massive entrance into this problem. However, the application of machine learning comes with a lot of issues which are especially preoccupying in developing regions. And here I want to highlight some issues related to the use of machine learning in renewable energy applications, an African perspective. Firstly, the deployment of machine learning demands offline preparation where substantial data is required to train them. And equally, access to representative data is crucial in machine learning deployment of PV systems. In most parts of Africa, where cost and infrastructures remain prohibitive, real-world data is difficult to obtain. And in the Central African sub-region, for instance, there are a lot of issues with related to data access, information access pertaining to renewable energy systems. And this is a consequence of little or no access to reliable operational data, as was highlighted by Dr. Alomba. In many applications, therefore, researchers resort to random data due to data scarcity problems. And while it can be argued that resorting to satellite-based data is a way out, there are still several issues involved. For instance, satellite-driven data has issues of frequency. The data frequency is mostly constrained to hourly and yearly-wise collection, and some databases are not free of cost and are often restricted to some locations. And faced with this problem, we propose a new approach to generating data for renewable energy optimization approach applications. We propose a synthetic data model approach where data is synthesized, and this model has so many features. The first feature is that we capture environmental conditions using sinusoidal modeling, introduced with Gaussian noise. We equally model seasonal variations and as well location modeling with multi-frequency adaptation as well, which means that it's possible to customize the data to a particular location. And for this reason, we propose 3 equations. The first equation, the G model, models irradiance. The second T model models temperature, and the third models seasonal variations. And these are the 3 equations we propose to synthesize data specifically for machine learning driven renewable energy optimization applications. And this model has been deployed and tested simulation wise first. In the figure 2 and 3, we present different plot of data at different intervals, different frequencies specifically, and as well for different days, modeling as well different periods of sunrise and sunset, as presented in the different graphs. As well, we equally wanted to experimentally validate this synthetic model, and for this reason, we constructed an experimental setup. And just to mention that this setup is actually driven principally by the trial PV monitor, which was just presented by Dr. Henry Alomba. And we want to say that the trial PV monitor has a lot of potentials, and it offers a lot of opportunities. And here we actually leveraged it as a wonderful Internet of Things application to experiment this new approach. And the setup is presented on the slide, and a small the architecture of the PV monitor device, the trial PV monitor device, is equally presented. We actually collected experimental data.
If you may please wrap up. If you may wrap up in the next minute.
Thank you very much. We collected experimental data for 3 days, and I want to mention that the intention here was we trained a machine learning model to predict the maximum power of a photovoltaic system. So the idea is a machine learning model trained by the synthetic data model compared to a real experimental system. So we trained a machine learning model with synthetic data, and we deployed it in an experimental system. And the figure 7 shows a plot of the experimental power, the actual experimental power, and the ANN, the power predicted by the ANN as trained by the synthetic data model. And we actually see that there's a strong correspondence between the predicted power and the experimental power. which actually speaks volumes about the performance of the synthetic model. And as we mentioned previously, in the literature, researchers resort to random data model amidst the problem of data scarcity. So it was equally a question to compare the proposed synthetic model with the existing random data model. So we trained the same neural network with a random data model and compared with the proposed synthetic data model within the experimental facility. And we see that, for instance, at the level of the mean squared error, we see that the proposed synthetic model achieved a mean squared error about more than 100-fold better than the random data model. So this actually shows that the proposed synthetic model is better placed to address the problem of data scarcity in Africa. And to conclude, we want to mention that this study developed a synthetic data approach to address the problem of data scarcity in renewable energy applications. And by incorporating several patterns, we showed that the model could produce realistic data for irradiance and temperature. And we confirmed the suitability of this model so far experimentally. And we want to mention that this work addressed a critical gap in renewable energy research by offering a scalable and adaptable solution to data scarcity. And the proposed model holds significant potentials for advancing deployment of predictive and optimization tools in renewable energy, particularly in regions where access to data is actually limited. And in terms of recommendations, I want to mention here specifically, and this is the last point, I'm concluding on this, that the proposed model applies specifically in situations or in contexts where emphasis is not placed so high on the accuracy of the data, but in applications where the representative data is actually a priority, not necessarily accuracy issue. And that is why we're able to deploy this model in an experimental facility, and we show that it can produce better performance than the existing random. Very good. Here are some relevant references for this work.
Yeah.
All right. Well, thank you so much, Ambe Harrison, for presenting your work.
Thank you.
Yeah, the network was challenging, but either way, you were able to deliver. Is there
Thank you.
any
My network
question?
was really challenging.
Yes. Do we have any questions for Ambe before we wrap up and go for lunch?
I'm open
One.
to any question.
All right.
I'll be more than happy to address any question and any concern related to this piece of work.
So if there are no any questions from anyone?
No.
Okay.
I think
All right. Okay. If you'll come up with any questions, we can just type them in the chat, and Ambi will be happy to answer them. Otherwise, this is the end of our session today.
so.
Thank you.
Thank you, Victor and Judith, for chairing this section number 6. And now we have, I think 25 or 26-minute break, lunch break. You can go and have something to eat and relax yourself, and then come back. We'll continue at 1:30 our time. Yeah, and as I was saying, I want to thank everybody who has presented so far, from the fifth section and the 6th section. And then I want to say I thank those the few people who could pay their registration fee. If you were not exempted from registration fee, please try to do so. And yeah, it is important for ANSOL to get some funding to pay its daily cost. Yeah, we we have a lot of expenses that and that's why if we're not exempted from paying a fee, please do so or contact me personally for us to discuss. Okay. I want to thank those who have done. I thank especially from Northwest University, those, professor, and also, you know yourself. Okay. So we see in 25 minutes at 13:30. Yeah, 13:30 means 1:30 to go to do the session number 7, which will be chaired by Professor Louisa Budiba and Patience Tifuta. We could also do, I can say we could also do, for those who are around now, we could also do a screenshot. You can open your camera, we do a screenshot then before going for lunch, if you want, those who want. Catherine, you are the one doing the screenshot.
I'll try and do the screenshots also on my end, but you also do it on your end kindly.
Yeah, okay.
Thank you.
Yeah. Okay, let me take group photo. So you have to press something so that I can take the group photo.
I think, Prof, I think they all have to let you in.
They have to let.
Option, like to allow.
You have to allow. If you don't allow, I cannot get
yeah.
you. So you have to allow me to take you to be part of the group. So if you've done it, then I will create a group photo. So far, I have only 1, 2, 3, not many people have allowed. So let me. Why am I getting just a few people? But I'm seeing more people who have opened their camera. Let me close this one and try again. A group photo. Retake. Take. Do you know? Go to what? What do I do?
Oh, I don't know. People with videos. Where is it? Just videos. Should be somewhere.
You know, where video, I'm not.
People that put on their videos, that's how you.
They make it. But I thought they should, because this system gives me, so like I said, group photo. So people should have sent, a message has been sent, you have to say allow so that you can be taken. So if you've said it, then I think it will be possible for me to create a group picture. Yeah. Now I think I will just try like this. Taking what I have taken. Download. Yeah. Okay, thank you. Yeah.
Thank you, Chico.
See you in a while.
Okay, so, and Louisa Budiba is around. She's going to chair the next session. So, and I think the others who are going to, those who are going to present are also around. I think Mr. Noel Ukwa Awangum. I hope he's already here. Then Nancy, Rupali Nancy is there, but Rupali, let me check. Rupali is not yet here. And yeah. So we just have actually three presentations in this section 7. So okay. Let me see. Good afternoon. Pass, okay. Yeah. So, but you wanted to give a presentation in between, but you were not there. So we had the opportunity to. There was somebody who did not come, Dr. Manel from Algeria. So you missed that opportunity. Okay. Hello, Prudence. How are you? Yeah, let me.
But I wanna know what's what, you know, but I'm not worried. I'm chilled, you know. I'm a chill guy, you know. Yeah.
we should continue our conference. I think it's 1:30. So, Louisa, you take over. Louisa and Patience, you take over the chair and do the presentation. You do the moderation. Louisa, you are muted. Can't you unmute yourself? So let me do it. Oh. It's funny. It seems as if but I'm trying myself to unmute you, but it's not just working. This is funny. I'm trying to unmute her. I think it's not working. I'm trying to.
She's not online. She has been.
No, she's there.
I'm saying, oh,
she's there. She's there.
Is that network?
But I'm trying to unmute her. It's not working. It's not working. It's not working. Where is her? But where's the other Patience? Are you online? Patience Tifu.
Sir, I am online.
So can you start with the moderation, because Luisa, she is muted. I'm trying to unmute her. It's not working. I don't know what is wrong.
Okay. Can I begin?
Yeah, you can begin. Yeah, to present the next person.
Greetings, everyone. You're welcome back to session 7. I hope we've all rested well and we're ready to commence another session. This session is titled Photovoltaics 3, and we're going to be beginning with a presentation by Noel Nkwa Awangum on machine learning models for solar PV power forecasting, a performance evaluation. Mr. Awangum, if you're here, can you please unmute and begin your presentation?
Okay, let me share my screen. Please, can you confirm that you see my screen?
Yes,
Yes,
we
we
can
see our
see your
screen.
screen.
Okay. Just a moment, please. Okay. Thank you for giving me the floor. I am Noel Nkwa Awangum from the School of Engineering in the University of Bamenda, Cameroon. On behalf of my team, I'll be presenting on machine learning models for solar power forecasting in the northwest region of Cameroon. So here's the outline that this presentation is going to follow. We are going to begin with an introduction, followed by methodology. Thereafter, we have results and conclusion. Energy is considered to be an important factor as far as economic development is concerned. And energy exists in several forms, one of which is electrical energy. And electrical energy is considered to be the most essential form of energy because it can be easily converted into other forms of energy. Electrical energy comes from two primary sources, which are renewable sources and non-renewable sources. Non-renewable sources include fossil fuel sources as coal, natural gas, and crude oil. And these fossil fuels are converted into electrical energy through a combustion process. And in that process, a lot of greenhouse gases are emitted into the atmosphere, leading to climate change. On the other hand, we have renewable energy sources that are environmentally friendly and have high potential to reducing climate change. Among the different renewable energy sources that we have, solar power is very prominent because it's available in large quantities and is found everywhere around the world. So solar power can easily be used to replace fossil fuels, thereby helping to reduce the impact of climate change. One major challenge that comes with the use of solar energy is that the source is intermittent. That is to say, the energy output that we get from the use of solar energy system depend on environmental conditions that vary across the day. So because the weather conditions vary, it makes it difficult to balance power supply and demand in systems that make use of solar photovoltaics. But then, since solar photovoltaics can easily be used to reduce climate change, it's important to maximize its use. And this can be achieved through efficient forecasting techniques. That is, it's important to be able to know how much power is expected to be produced by a particular solar energy system on a particular day, so as to help the users or solar power operators make informed decisions. The focusing of solar photovoltaic power is complex, but the advent of machine learning has come to make the process easier, faster, and more accurate. By machine learning, we mean the ability of machines like computers to learn from data and to make predictions on the data. So here is the methodological procedure that we use in this research. First, we started by acquiring data from PVGs, which is a platform that provides information about solar power production in most locations around the world. So after we got the data, we had to clean the data to prepare it for the training of machine learning models. After the cleaning of the data, we split the data into two sets. One set, which was made up of 80%, was used for training the models, while 20% was used for testing the models. So after the splitting of data, the data was imported into the MATLAB software and used to train the machine learning models. After the training of the models, there was a validation in order to pre-test the performance of the models after training. So in the validation, we use two techniques. One is called hold out validation. In this technique, 25% of the training data was used to pre-test the performance of the machine learning models. Meanwhile, 75% was used to train the models. On the other hand, we had a resubstitution validation technique. And in this case, we use the entire 80% data set to train the models, and we still use the 80% to pre-test or to validate the models. After the validation, the models were tested. That is, the performance of the machine learning models in the real world was evaluated. After the testing, we did a performance evaluation in order to identify the most accurate model that can be suitable for forecasting solar power in the northwest region of Cameroon. And in this evaluation, we use a graphical method by observing the actual versus predicted plots. And then we also use a numerical evaluation using a root mean square error value and the coefficient of determination. After the evaluation, we're able to identify the most accurate model, and we use that model to make some power predictions. So we actually use a total of 24 machine learning models classified into linear regression, regression trees, support vector machines, ensemble of regression trees, Gaussian process regression, and neural networks. So here is a sample data that we obtained for the solar photovoltaic power in the specified location. So the solar power varied across the day from 0 to about 17 kilowatts. Then in the data, we study the relationship between the dependent variable and the independent variables. So here we have a plot that shows all the relationship between direct beam irradiance and the solar photovoltaic power. So we find here that an increase in direct beam irradiance leads to a corresponding increase in solar power generated and vice versa. So this is the result that we got after training and testing the models. So this is the predicted versus actual PV power plot. So in this case, we find on the left fine Gaussian support vector machines, which was the least accurate model. And if we observe well, we see some data points in blue. The data points are spread farther away from the regression line, indicating that the accuracy was poor. On the right, we have the most accurate model, which was white neural network. And we can observe that the spread of the data points was very close to the regression line, indicating a good accuracy. Here we have the comparison, or we have the results of the root mean square error values and the question of determination R-squared values for the different models. So model number 11, which was fine Gaussian support vector machines, was the least accurate, yielding root mean square error values of 458.97 and 443.50 for whole earth validation and resubstitution validation. So from here, we find that this model had the highest root mean square error value, which was very poor. On the other hand, we had model number 22, which was a white neural network, which was the best model. It had the lowest root mean square error value of 9.377 and 9.5279 for whole earth validation and resubstitution validation, respectively. So after we identified white neural network as the most accurate model, we used that model to do power forecasting, which is shown to us in figure 6. So we see actual PV power in blue and forecasted PV power in green. So we can observe from here that we had a very minimal variation between the actual PV power and the forecasted PV power of the next day. So to conclude in this research, we're able to compare the performance of 24 machine learning models and to observe the ability of the most accurate model to perform power forecasting, PV power forecasting in the northwest region of Cameroon. So we're able to do the evaluation using two performance techniques. And sorry about that. So we observed that white neural network was the most accurate model because it had the least root mean square error value, and it had the most, or it had the highest R-squared value, and that model was then used to forecast PV power in the northwest region of Cameroon with a good accuracy. We would like to acknowledge Responsible Artificial Intelligence for Climate Action in Africa for supporting this research work. These are some references that we made use of in this research. Thank you for your kind attention, and I'll be glad to welcome your questions and contributions.
Thank you, Mr. Wangum, for the presentation. We are looking forward to questions. Is there anyone who would like to ask a question regarding the previous presentation?
Yes, I have a question. I just want to ask, how did you implement this wide neural network? Which software did you use?
Okay, thank you, sir, for that brilliant question. That's one thing that I omitted in my presentation. I use MATLAB software.
Thank you very much.
You're welcome.
Do we have any more questions? If not, we are going to proceed to the next presentation, which is titled Numerical Study of RBCFAPBI1 XBR Perovskite for Photovoltaic Applications by Nancy Obare. Is Nancy available? Okay, Nancy, you have the floor.
Yes, I'm available. Are you getting me?
Yes.
Mrs. Da, do you hear me?
We are hearing you. We are hearing you. You can present.
Ah, okay. Are you seeing my screen?
Yes, we can see your screen. Go in presentation mode, please.
Yay. Thank you for the opportunity. I'm Nancy Obare from Kenya, University of Masinde Muliro, University of Science and Technology. I'm going to present on numerical study of a triple cation perovskite for photovoltaic applications by SCAPS one dimension. The perovskite solar cells have attracted so much attention of researchers because there is a continually increase in power conversion efficiency. The solar cells, that's perovskites, the major one is utilizing the methyl ammonium, and it has given a promising efficiency of more than 25%. However, there is a challenge with it. The perovskite is facing high challenge like long-term instability because of moisture, heat, and light. So there's a need to get more other materials that can be able to get out the rid of that problem by mixing the perovskite. So for molybdenum-based perovskite solar cells have attained the keenness so much from the researchers because it has shown a good incorporation of more components of cations and halides, which suppresses the carrier recombinations that is major problem. So in this, we have multiple cations that is in 3 dimensions, and we are mixing
Nancy, you muted your speaker.
I think she lost the connection, perhaps.
She must have lost the connection. This is
We've lost Nancy.
Yeah. I think we'll proceed with the next person so that we just gain time.
Yeah, the next presentation. I will first of all apologize to be late for the opening of this session. Good afternoon, everyone. My name is Professor Luisa Budiba, and I am honored to chair this session with Mrs. Da. So the next communicant is Rupali Jada Shavan. And the title of his presentation is Design, Synthesis, and Characterization of Conjugated Terpolymers for Photovoltaic Applications. So, Mr. You can start. I'm sorry, am I back?
You are back, okay.
Yeah, you are back. We'll continue.
Good.
So I can continue from where it stopped. So the composition engineering will allow us to adjust the band gaps, charge transport properties, and morphology.
Please, excuse me, please share your screen first.
Share your screen. Share your screen. I'm not seeing anything.
It doesn't appear on my screen.
Shall disappear again? Or what? Yeah, okay.
I stopped. That was the material I'm going to use, the scabs. Under it was developed by the University of Belgium, and it uses the three equations. That's the Poisson equation, electron hole equation, and the continuity equation. And from it, we are going to design a software material whereby it has an interface. I'm going to have an architecture of having ITO as my front contact. The electron transport layer will be tin oxide. The absorber layer will be the triple cation perovskite, and the whole transport layer will be HTL. And I'm going to use gold as my back contact. So this is how it will look like. So I'm going to have my TL, the absorber layer, and the electron whole transport layer, and that's the radiations of the UV. So I'm going to use these simulation parameters. This is the one that we used for our simulation. Then from it, I was finding the thickness of the electron transport layer, the absorber layer, and the electron transport layer. From it, we also varied the doping concentration of the absorber layer. So from that, after the variation, we were able to get this result. So from it, on the ETL, the work of the electron transport layer is actually to generate electrons from the absorber layer and to transport the generated electrons from the absorber layer to the front contact. And from it, we can be able to see that the power conversion efficiency and the fill factor were reducing as we were increasing the thickness. The thickness was varied from 10 nanometers to 50 nanometers. And we realized that when we are increasing the thickness, has more impact on the fill factor and the efficiency. There is a reduction of the efficiency and the fill factor, actually, because the increase in the thickness will lead to charge recombinations on the ATL. And this also might have led to the low transmitters of photons because there is also the reduction of the open circuit voltage, that's a VOC. There is also a reduction of it, which will result in the reduction of the fill factor and the efficiency due to the series resistance that is caused. On the absorber layer, the absorber layer actually determines the efficiency of the solar cell. So this will lead to the proper alignment of the band gap on it. So from it, you can be able to see that there is increase in the short circuit current density up to 700 nanometers. Then it starts to decrease. And we have also the reduction of the open circuit of voltage, which increase of the thickness. This is because there is saturation of current, which is caused by carrier charge carriers recombination losses. We can also be able to see it on the impact of it on this. And as the efficiency is maximum at 700 nanometers, that's the optimal point, and it starts to reducing because there's more increase in charge recombinations. On the whole transport layer, also we look at it. The thickness was also varied from 10 to 300 nanometers. And the role of this HDL is to facilitate the transport of the generated holes while blocking the electrons. There is the reduction of the power conversion efficiency and the fill factor because of the reduced irradiance and on the recombination of the charge recombination carriers. The doping concentration, we varied the doping concentration from 10 raised to 20 to from 10 raised to 10 to 10 raised to 20. And the optimum point was 10 raised to 18 per centimeters cubic. And this shows that there is an increase in current density due to the effective transport. We can be able to see this increase due to the effective transport of charge carriers. The fill factor reduced slightly due to decreasing ratio charge carriers generated and the recombination rates within the absorber layer. Reduction of recombination rate is caused by the rise in generation of free charge as doping concentration is increased. Higher doping also we can be able to see clearly that the higher concentration will lead to forward biasing, and that's why we have the reduction of the efficiency at higher concentrations. In conclusion, we successfully simulated the solar cell, and we can be able to conclude that from the simulation, the electron transport layer has no much impact on the thickness on the cell. And the optimum thickness of the photoactive layer was determined to be 700 nanometers. And the thickness of the whole transport layer was 50 nanometers. And the one for HDL was 100 nanometers. And the optimized the solar cell demonstrated a promising efficiency of 27.4%, which is suitable for application of in photovoltaics. I appreciate and acknowledge my supervisors, Dr. Dari, Mageto, and Celine from the University of Masinde Moreno, and for giving me this opportunity. Also, I appreciate you for listening to me. Thank you very much. And sorry for the disruptions.
Thank you very much for your insightful presentation. We have a few minutes for questions, or 1 minute for questions. Is there any question? So we can move to the next presentation entitled Design, Synthesis and Characterization of Conjugated Terpolymers for Photovoltaic Applications. It will be presented by Rupali Jadab Shavan. Please, you can start.
So, hello all, good afternoon. And I will introduce myself. I'm Dr. Rupali Jadhav Chavan. I'm working as an assistant professor in Dr. Vishwanath Karad MIT World Peace University, Pune. And it is in India So I'm from India, and my place where I work and live is near to Mumbai, which is economical capital of India. So title of today's talk is Design, Synthesis and Characterization of Conjugated Terpolymers for Photovoltaic Applications. So I will close my window, just check that whether my presentation is visible or not. Just give me a confirmation.
Your presentation is visible.
It's visible.
Okay.
It's okay.
It's visible, but it's better if you put it in presentation mode.
In full screen, please. Did you have any problem?
So I'm just checking. Okay, I think now it will be visible in a full screen mode.
Yeah.
It's better, yeah.
Okay. So yes, I completed my PhD in National Chemical Laboratory, which is one of the prestigious institute in India, and the real research work based on polymer solar cells was initiated at Germany with Dr. Daniel Igbe. So I thank him that this work was initiated and later it was fueled and flourished with his guidance. And of course, my PhD guide here also in India, he helped me in getting so many chemicals required for this particular work. So going to the main presentation here, my work is basically on polymer or organic solar cells. And here the pictures are showing the very new functionalities which are imparted by polymer solar cells, that is transparency and flexibility, which cannot be possible with the silicon solar cells. And at the lower end here, we can see the typical solar cell which can be made in the lab. So again, polymer solar cells, they are emerging candidates which can be alternative to the silicon solar cells in terms of the cost effectiveness, because they are solution processable, they are flexible and lightweight, and moreover, some new device functionalities, some new properties can be incorporated in final device when we slightly manipulate the structure of the polymers. So that is the important thing, that we can manipulate the device properties with the help of design structure. So that's why so many polymers, they are there in the literature that act as a donor material in polymer solar cells. Nonetheless, these polymer solar cells also have some challenges like short exciton diffusion length, slow charge mobility, and limited absorptions. So they need band gap control. And here the work of synthetic chemist starts. So in my research work, I have synthesized so many different low band gap polymers, and I have applied various techniques of lowering the band gap energy by introducing anthracene unit, by introducing side chain conjugated polymers, then terpolymer approach, and finally, I have introduced some hydrogen bonding interactions also. So in today's presentation, I'm going to talk about the copolymers and terpolymers I have synthesized. And those are like benzodiethiophene dione containing compounds, which is used as a donor material in polymer solar cells. So to start with, we will see what are these donor acceptor alternating copolymers. So in donor acceptor copolymers, we have Donor unit means electron rich unit, which is attached covalently to electron acceptor unit, which is called A unit. So with this structure in the backbone, there is a quinide mesomeric structure formed. And this quinide mesomeric structure will help in delocalization of the electrons. So DA kind of polymers, they are helpful in maintaining the planarity and effective delocalization of the electrons. Moreover, they have strong intramolecular charge transfer interaction because of the push-pull mechanism, which is imparted by donor and acceptor units respectively. So we can control the HOMO and LUMO of the ultimate polymer by manipulating the design of donor and acceptor. So this effectively decreases the band gap energy of the donor acceptor alternating copolymer. So here in the picture, this whole concept can be explained by MO theory, that is molecular orbital theory, in which we can see here the donor has HOMO and LUMO and acceptor has its own HOMO and LUMO. When we polymerize these two units, and this is the in between, there is a DA copolymer which is having these 4 new hybridized orbitals. Okay, so the HOMO polymers, the HOMO of the donor and acceptor, they interact to form new HOMO and LUMO, and LUMO of both donor and acceptor, they interact to form 2 HOMO and LUMO. Lowered LUMO in case of donor acceptor copolymer, and effectively the band gap is decreased. So in literature, we can find various exciting polymers which are used as donor material along with the PCBM. One of the polymer which was invented by Sun et al., it gave polymer photon conversion efficiency as 9.7% with BDD unit. In another example, Sun et al., they have shown 10% 3 efficiency using the same unit along with the benzodiazepine unit as a donor material. So in my case here, we have used cyclopentadiene thiophene and benzodiazepine dione as an acceptor, and we have synthesized this particular polymer, which was having optical band gap of 1.7 electron volt and PC of 1.6%. So I synthesized 2 different polymers in which one of these polymers, CPDT, is a donor and BDD is acceptor. Similarly, in the second polymer, BT is the donor, BT is bithiophene, is a donor, and BDD is an acceptor. Later on, with the progress of the research in the design of polymers, it was found that some donor acceptor kind of systems, they are not really helpful in enhancing the absorption in the terrestrial solar radiations. So in order to maximize the absorbance in solar flux, there is a need to make certain to introduce more units into the polymer backbone. So in that, with this thought in mind, we also studied terpolymers by introduction of one more electron accepting unit in the polymer structure. So in ideal terpolymer system, there will be 3 different units which have complementary light absorption in both visible and near IR region. In that way, they will harvest more number of photons, and we can be able to adjust this HOMO-LUMO and then ultimately get good charge carrier mobility and good solubility. So terpolymers are the polymers which have 3 different units in the backbone, and they can be formed by 2 different ways, in which first is the donor acceptor system and second is donor system. So among these 2, donor acceptor system is more effective and it leads to high performance solar cells. So here are some of the examples in the literature wherein terpolymers are synthesized. In about 2 examples, these are donor acceptor kind of systems where they could be able to achieve the efficiency of 8.1% and 12.1%. In the second example here, which got 12.1% efficiency, they have merely changed the side chain on the BDT unit. So that gave very different, very high power conversion efficiency. So, and the last example here at end, so it gave PC of 15.3% with the same molecule BDD that I have used, and we using benzothiazole as an acceptor. So this is an example of donor acceptor system. So in my work, I judiciously chose monomers so that their absorption will be throughout the visible region starting from 200 to 600 nanometers. So I used dithiophene, benzodithiophene, BDD, and DPP. So BDD and DPP are acceptors, and bithiophene and benzodithiophene is donor. These are the terpolymers. This is the first set of terpolymer in which bithiophene is used as donor, and along with DPP and BDD are acceptors. Here the change is only in the side chain. In one case, I have introduced ethyl hexyl side chain, and in the second case, we have introduced hexadecyl longer side chain in order to obtain soluble polymers. This is the synthesis, 8-step synthesis. This is the clean spectra of the BDD monomer, which is acceptor. And these are the donor molecules, the H1 NMR spectra of the donor molecules. So in the synthesis, we have synthesized these copolymers using steel coupling reaction, using palladium DBA3 as a catalyst, and along with O-toluene phosphine as a co-catalyst, and toluene as a solvent at 24 hours in reflex condition. This is the NMR spectra of the polymers. This is a synthesis for terpolymers, wherein I have introduced these 3 different units based on benzodithiophene, which is called BDT, DPP, ethyl hexyl, and hexyl decyl chain with BDD. This is DAA system. And in the second set, I have used BT-based donor unit, and DPP and BDD are the acceptors. So again, this is NMR spectra for these terpolymers. So the molecular weights were in the range of 9 kilogram per mole to 28 kilogram per mole. But here, BT-based polymers were shown very less molecular weight, and the copolymer CPDT was having sufficient molecular weight. And these polymers were, they show in thermogravimetric analysis, they show thermal degradation at 10%. They were almost around 350 degrees centigrade. This is the absorption and photoluminescence spectra of copolymers and terpolymers in dilute chloroform solution. So if we see carefully, some of the polymers like terpolymers, they show a shoulder peak on the absorption spectra. So this is an indication of intramolecular charge transfer. So this is a shoulder peak which is showing the presence of intramolecular charge transfer. So absorption spectra of terpolymer with hexyl decyl side chain is redshifted by 167 nanometer as compared to its ethyl hexyl derivative. This is because just increased molecular weight of this particular polymer because of the longer side chain. This is the thin film which is casted from chlorobenzene solution. They are shown here. So in thin film spectra.
I'm sorry to interrupt you, but we need to wrap up to stay on schedule, please.
So I didn't get it. Can you repeat, please?
Try to wrap up, but just continue quickly so that we should gain time.
Yeah.
Okay. Yes, I'm towards the end of the talk. So this is the comparison between the optical band gap, which is around 1.4 and 1.7 electron volt. So these particular polymers, the stir polymers, they show temperature dependent absorption spectra in BDT based stir polymers. It was seen in the solution case. So this particular peak at 715 nanometers, it was due to the pi stacking of the polymer chains. In this we have observed that upon increasing the temperature from 20 degrees to 60 degrees, the shoulder peak at 715 nanometer, it gradually disappeared with simultaneous blue shift. So this heating and cooling process is useful in the case of annealing when the devices are synthesized, when devices are fabricated, they do this annealing step. At this step, this particular observation is helpful whether to give annealing time or not. So this is a comparison between electrochemical band gap and optical band gap. So they are comparable. And finally, going for the photovoltaic study, we found out that among these 6 polymers, 3 polymers were, 2 polymers were successfully, they gave the good efficiency, solar cell efficiency. And it was for the alternating copolymer CPDT BDD. In conventional case, it's shown the photon conversion efficiency of 1.4%, and then in inverted it shows 1.6%. So BDT and DPP polymer, it showed 1.57% efficiency in solar cells. So why the polymer, which is polymer, which is having high molecular weight and good longer side chain, that is hexadecyl side chain on DPP unit, is it is showing AFM topology very drastically change because this hexadecyl chains which causes spherical hindrance, and hence the morphology for the blend was not suitable. Apart from this, the BDT with ethyl hexyl side chain, when it is blended with PCBM, it gave smooth morphology. So this is the reason why the other device showed poor response. So in summary, these copolymers and terpolymers were synthesized. They have broad absorption in visible and IR region. They form the aggregate. At the terpolymers, they form the aggregate. And finally, we achieved solar cell efficiency of 1.63 for devices synthesized from these polymers. So I want to acknowledge both of my guides, Dr. Prakash Badgaonkar and Professor Daniel Igbe, one of my colleague Nitin Walsange, then my device fabrication team, that Dr. Harald and Shahidul Alam from University Jena in Germany, then CSIR for my fellowship, CSIR NCL for infrastructure, ANSOL and WAITRO team, and session chairs, then Faculty of Engineering Technology, and of course the audience. Thank you very much.
Thank you for your presentation. So if there is any question.
Yeah, I think I will ask one question. Rupali, I'm happy that you did this wonderful work. You are one of our first students when we had, in those days, the DFG funding, and you moved from Ilmenau to
Linz.
To Linz or through Chemnitz, so before going to India. So you moved to very laboratory and learned a lot. So I'm happy that you are now assistant or associate professor in your country. So, and what I will ask, you showed these two AFM pictures, one where there's a good mixture and the other one where you can see some green.
Yeah.
How could you, the question would be, for you to have something intermediate, which will improve even the efficiency of the whole thing, how will you proceed?
So, as the AFM study is very clear that in the blend form, these are the hexadecyl chains are really they are causing some large steric hindrance. So they are not forming good structure, which is homogeneous structure for blend in order to have this exciton diffusion and these things. So maybe this particular polymer is lagging.
But I will suggest that's something which we did. You could blend the two polymers. You blend the polymer on the right side and that of your left side, and together with you have at the end of 3 component in your active layer. You have polymer 1 and polymer 2 plus PCBM, and you get something in between and improve the efficiency. Those are things that we've studied. Especially these side chains, you know, that has been my focus over years to see how the alcohol side chain can modify the nanomorphology of an active layer of photovoltaic. So if you can just take 2 of those polymers, you will see an improve and really just blend them. And with PCM, then the efficiency.
That is a very good suggestion, because we were wondering that why these chains which are favoring the molecular weight to build up, why they are now causing the trouble in this particular device.
So just blend. If you just tell Shaidu, okay, he's back in Germany. He's now in TMU in München. That I hope that the polymers are with him or they are with Harald. They can do a blend of the polymers. Then you see and improve. This is the experience that we've made with other polymers.
Yes, very insightful suggestion, sir. Thank you.
Yeah, okay. Let me give back.
Is there any other questions? No. So this concludes our session on photovoltaics 3, part 3. I would like to thank, first of all, Professor Daniel Egbe to giving me this opportunity to share with you in this interesting conference. Secondly, I would thank Mrs. Da for sharing with me this session, and thank all the speakers for their excellent presentations and the audience for their participation. We hope you found this session insightful and enjoy the rest of the conference.
So we'll move to the next session 8, which is chaired by Dr. Rahimat Yakubu and Bernard Wambua. Are you both around? Let me see. Bernard, you are around at least. I'm not seeing Dr. Yakubu. So Bernard, you have to take the floor and start moderating, presenting the people. Is Bernard also not available, or is Bernard?
Yes, can you hear me?
Yeah, we can hear you. So
okay. Thank you so much, Professor, for this opportunity to share this session and also to share some experience from some members here. And then we also thank ANSOL and all the partners for having this conference, which is actually very amazing. And direct to the point, we are going to just have the first presenter for this session, who will be sharing on biosynthesis of silver nanoparticles for electrochemical quantification of sunset yellow. This one is by Dr. Hassan Oriomi Soyiga and Prof. Omolola Esther Fayemi. Thank you so much and welcome our presenter.
Is Dr. Hassan there? Yeah. Okay, something's happening.
Yeah.
Good afternoon, good morning, good day, everyone. Thanks for having me. I hope I'm audible enough.
Yes, you are audible.
And my slide is
visible.
Visible, okay. Thank you very much. And thanks to the previous presenters. Listened to highly insightful talks. So today I'll be presenting part of my research work titled Biosynthesis of Silver Nanoparticles for Electrochemical Quantification of Sunset Yellow. This work is jointly carried out by myself and Professor Omolola Fayemi, who happens to be my host at the Department of Chemistry and Material Science, Innovation and Modeling in Northwest University, South Africa. So here, scheme 1 shows the graphical abstract. So this basically summarizes the purpose of this talk. As we can see from this abstract, we are using our silver nanoparticles to modify an electrode. This electrode is used as a sensing material to sense and quantify sunset yellow using an electrochemical techniques, which the voltammogram is shown in the picture you're seeing. Lately, food safety has raises a bit of concern regarding the use of synthetic dyes, the likes of sunset yellow. As we all know, most of the beverages, fizzy drinks that we all take, most of them contain some food additives, some colorants, which basically they are actually meant to add colors, to add some sort of attractiveness to these drinks. However, these dyes, additives, when taken at a certain as percentage, they tend to pose certain health risks, such as maybe some of them causes some sort of high sensitivity, some sort of, some may cause some malignant cells to start growing. So in order to avert this, there is a need for us to find a way to actually quantify and also determine if this, to what extent do we have these additives in our food that we consume. So in the past, there are conventional methods that have been used, and this conventional method are basically the use of chromatographic method and other analytical techniques. However, these methods are basically expensive, and also they are also not that, they are also very laborious. In order to circumvent this, there is a need for a cost-effective and less laborious techniques. And what comes to mind in order to carry out this is the introduction of nanomaterials. Nanomaterials such as metal nanoparticles have been demonstrated in the past to have high sensitivity due to their high surface area and also high conductivity as well. For the purpose of this presentation, our focus is going to be on the use of the synthesis of silver nanoparticles, which is synthesized using a plant extract. The plant of choice this time around is a Pannonia amygdalina, which is used to fabricate an electrochemical sensor, which was used to detect sunset yellow. And also the electrode that was fabricated as we are going to be saying in later on, shows a promising properties. Now for our synthesis, like I said, we're focusing on Vanilla amygdalina. This plant is popularly known as bitter leaf in the western part of Africa, particularly in my home country, Nigeria, where it is popularly utilized for medicinal purpose and also as edible plants. However, this plant contains series of phytochemicals, which has been demonstrated to act as reducing agents in the synthesis of metal nanoparticles. For us to carry out this, what we did was to pulverize the leaves of these plants. When it was pulverized, it was dried first of all. After drying, it was pulverized into powder, and then this was poured into a round bottom flask, and then ethanol was added to it, and this mixture was heated at 65 degrees Celsius for 1 hour. So this extract, as we can see in figure 1, shows the extract of the leaves. And after the extraction was carried out, then we introduced silver ion, silver salts, which is a source of silver ion. So this was heated at 70 degrees Celsius for redox reaction to take place. So this reduction reaction, like I mentioned earlier, is being done by the phytochemicals present in these plants. And voila, we're able to obtain precipitates, which after washing and drying overnight, we're able to get this biosynthesized silver nanoparticles, and this was confirmed by the TEM micrograph. Furthermore, we're able to fabricate our sensor utilizing the synthesized biomediated silver nanoparticles. So we made a paste from the material that was synthesized. This paste was drop casted on the on the gold electrode. So thereafter, it was used in an application for us to be able to determine the sunset yellow, to sense the sunset yellow in a chemical medium, and also we also use it in a real sample analysis, which I'll be discussing later on. So the technique for this testing, sensing that was used is square wave voltammetry. In order to understand the properties of the synthesized material, we carried out some characterization. So one of the characterization that was done is CEM microscopy was used to determine the morphology as well as the particle size of the material. As you can see from figure 3A, figure 3A shows the TEM micrograph, which can be observed to contain a spherically shaped nanoparticles and with little agglomeration. In terms of the particle size, we're able to calculate the particle size, and the average particle size is around 3.5 nanometers. So which demonstrates that our nanoparticle, it is expected to demonstrate a large surface area. Now, after that, we also carried out XRD diffractal X-ray diffraction, which was used to also study the crystallinity of the nanomaterial. The prominent peaks that are ascribed to silver nanoparticles were observed at it's around 38 degrees. We also have another one around 43 degrees. And then these peaks can be seen to be sharp peaks, and we suggest that the synthesized nanoparticles shows high crystallinity. We also studied the optical properties of the nanomaterial. As you can see also in figure 3C, the optical property shows that there's a huge absorption between 400, and also we also have another absorption around 600 nanometer. So these optical, the absorption that is observed around the visible region also shows that nanomaterial demonstrate a surface plasmon resonance, which is typical of silver nanoparticles. The band gap was also calculated, and the band gap for this particular material is around 2.2 nanometers. Thereafter, we went ahead to carry out the catalysis of the nanomaterial. So, which for us to be able to do that, we fabricated we dropcasted the synthesized nanomaterial on the electrode. So we tested this in analyte, which is a sunset yellow. So the sunset yellow was prepared in PBS, a phosphate buffer solution. So about 0.1 millimolar of it was prepared in buffer solution at a pH of 3. So we carried out cyclic voltammetry using both the bare and the modified electrode. So when I say modified electrode, I mean where we use synthesized nanomaterial to where we dropcasted it on the bare electrode. So sometimes I might be saying modified electrode. So I meant the nanomaterial that was synthesized. As you can see from this voltammogram, our modified electrode performed better than the bare electrode. So which we can see that figure 4
See, you have
shows.
overstayed your welcome.
Sorry.
That's what I'm thinking.
And also, please, can I carry on?
Yes, please.
Okay. So the modified electrode performed better than the bare electrode that you can see from the observed oxidation peak current and the reduction peak current. And the table 1 also summarizes the properties of the electrode. From the ratio of the anodic peak current and the cathodic peak current, which is greater than 1, it can be said that the electron transfer between the modified electrode is diffusion controlled. So the improved modified electrode also demonstrates that nanomaterial is able to oxidize sunset yellow, which we'll be seeing in later on. We also went further to see how well nanomaterial is able to the dynamics in terms of electron charge transfer. So we carried out a scan rate. So we increased the scan rate of our voltammogram, which from 25 millivolt per second up until 500 millivolt per second. As we can see from figure 5A, it is observed that as we increase the currents, the scan rate, the current response also increases. So which also demonstrates that the nanomaterials has a high charge transfer and also high conductivity. So the plot of current against the square root of the scan rate was also plotted, a linear plot. As you can see from the R-square value, which shows that there is high linearity between there's a high linearity between the current response and the increase in scan rate. In order to apply our material to in sensing, so we carried out square wave voltammetry. So from figure 6A, the square wave voltammetry is chosen because it's more sensitive than cyclic voltammetry. So in square wave voltammetry, majorly it's able to detect oxidation peaks at various oxidation states of the material, and that is why it's more sensitive. And the reason we have chosen it, as you can see from the plots between the current and potential, as we increase the concentration of our analyte, which is sunset yellow, the current response also increases as the concentration increases. The another interesting thing I want us to see is that the concentration, the range, the linearity range is between 2.44 nanomolar, so which is extremely diluted. And even at that, our sensor was able to detect a sunset yellow in solution. Now, figure 6b also shows the linearity as we increase the concentration of the analytes, the current response also increases linearly, and our R-square value, which is given as 0.9798, also suggests that. Now, in the case of, so for us to see what is obtainable in literature to actually compare if our material, our sensor is actually doing fine. So we compare it with previously reported works in the literature. And as you can see in table 2, the last line where we have in this study material, you can see that the LOD, which is limit of detection in nanomolar, is quite low compared to the previously reported literatures. What is even interesting is that amongst this previous work, there is a current work which is just done in 2024. And to our surprise, nanomaterial was able to have a better low detection limits compared to that particular one. So which shows that nanomaterial is a promising material for sensor. Now, for us to be able to apply our sensor in real life, in real sample analysis, we need to first of all understand if it will be able to be selective. Because for you to use a sensor in real sample, your real sample contains other materials, other matrix, which may interfere with the effectiveness or with the effectiveness of the sensor. So for us to do this, we simulated this and using methyl orange as an interfering agent, and where we kept the concentration of our methyl orange constant while increasing the concentration of the sunset yellow in the same cell. Now, as you can see from this plot from figure 7, we were able to observe that as we increase the concentration of our sunset yellow, there is an increase in current response at the initial stage. However, when the concentration increased, we were able to observe that the current response of the methyl orange begins to decrease while our sunset yellow increases. So which demonstrates the selectivity of the fabricated sensor. Hence, it shows that our sensor is able to work well under the influence of other matrix. So we went further to apply this. We got a fizzy drink, a particular soft drink here in South Africa, which I won't mention the name. So we used that real sample, and from the analysis, we're able to get a very high recovery percentage. So which shows that our sensor is a promising material to be used as a sensing material. In conclusion, we're able to, from this work, we were able to synthesize successfully silver nanoparticles from Vallona amygdalina extract. Also, we're able to fabricate successfully a nano sensor, which was used in detecting sunset yellow, both the chemical one and in the real sample. The sensor, as you can see, showed an excellent electrocatalytic activity towards sunset yellow oxidation, which further also exhibited a lower detection limit, which is comparable to those reported in the literature. On this note, I would like to appreciate my host and my mentor for this opportunity to carry out my research, my postdoctoral research within the nanosensor group. I also want to thank my colleagues within the nanosensor group for their cooperation and support, members and staffs of the chemistry department and MASIM as well, and also the university and MASIM for the postdoctoral fellowship funding and for providing the facilities as well. And then thank you all, the ANSOL group team, for this opportunity to present my research. Thank you all, and here are my references.
Okay, thank you. Yeah, we are behind the time, so I don't know if Bernard, as moderator.
Yes, thank you so much for that amazing presentation. And I can see that we are a few minutes ahead of time, and we need to really catch up. We'll open the floor for any question with regard to that presentation.
We are behind the time. We have to move ahead.
Okay, thank you so much. So we'll welcome the next presentation.
Thank you for having me.
From Let's all, yes, welcome. Judith, please.
Judith, let's swallow. Can you share your screen? Judith?
I don't know that she is in the meeting. So I think we can skip her and have the next part, which is from John Sekele McCall. Thank you.
John, you can start speaking, please, to gain time.
Oh.
We are seeing your screen.
The challenge is my screen is black.
We are seeing your screen.
So I can't see. My screen is black. May I please stop and share again?
Okay, stop and share, but we are seeing. Rupali, can you stop sharing? Rupali, you have this thing again. Just put it off. Maybe it's interfering. Hello, Rupali, can you stop sharing? You stop sharing your screen. But Mokele is John. You can still share it. No problem. just try to share. Rupali, please, I hope that you are getting me. You stop sharing your screen because it might interfere to other people presentation.
So can maybe Banda please present before me. I think I'm having network issues. I can present after him.
Okay.
Okay. Yeah. Then we
Judith,
can have
has
the,
Judith not come back? Judith is still not available.
so we can have Dr. Karima.
Yeah, but she also is not available. Let me see, Dr. Karima. I don't know why Rupali ought to put off her screen. She's still having it on. So for Dr. Karima, I'm not seeing her also. So
Maybe Nicole can start sharing.
Ajay Galusi is also not around. I told people to be here 1 hour before so that they can present if somebody doesn't appear. So I will just ask Ina Colombo. I know that she's in the next this thing. She will just present.
Sorry, Prof. Can you see my slides now?
Yes, it's now okay.
Yeah, I can see.
Okay.
Okay.
Okay, good day. My name is Mukulese Lege from Northwest University, a PhD student from Northwest University. And the title of my presentation is, my slides are stuck again. The development of green and chemical synthesis routes of gold multi-wall carbon nanotube nanocomposite for the voltammetric detection of methylene blue dye in river water samples. Water is a fundamental element of our daily lives. It is sorry, it is used for many things, including recreation, generate power, agriculture, and water pollution keeps on growing rapidly, with the textile industry being the second most water polluting industry after oil and shipping. It contributes about 17 to 20% towards water pollution. And some of the dyes that are used by the textile industry, such as methylene blue, are discharged into water without being treated, causing problems such as eutrophication, soil pollution, groundwater pollution. And when the contaminated, dye-contaminated water is ingested by humans, it causes, it becomes carcinogenic, mutagenic, genotoxic, and neurotoxic. There are other conventional methods that have been used before, such as capillary electrophoresis, fluorescence, spectroscopy, chemiluminescence spectroscopy, and chromatography for the detection of methylene blue dye in water. But these methods have many disadvantages, including the fact that they are expensive, they take longer response time, they have a complicated pre-sample preparation, and they always require a highly trained professional to always be on site to be able to operate them. And this shows that there's a need for a cheap, stable, reliable, easy-to-use technology that will help with the detection of dyes in water, and also to monitor the degradation of dyes to ensure that water is safe and clean for drinking. So the aim of this study was to develop a highly sensitive, selective, and easy-to-use electrochemical sensor with quick and rapid response by modifying the electrode with gold multi-wall carbon nanotube nanocomposites synthesized using green and chemical synthesis. So the objectives were to synthesize the nanomaterials using green and chemical methods, to characterize the crystalline structure, the surface morphology, the composition, the optical properties, using various analytical techniques to determine the selectivity and sensitivity of the nanocomposites using square wave and cyclic voltammetry, and also to perform, to see how the sensors can be used in real sample analysis. These are the methods that were used, the chemical synthesis route, and also for the green synthesis route. For chemical synthesis, trisodium citrate and sodium borohydride were used as the capping and reducing agents. Sorry. And for the green synthesis, the dry African potato leaves were used, and the proteins acted as the proteins in the roots in the plant acted as the capping and reducing agents in this case. So our nanomaterials were characterized in this case using using UVVs and XRD, and band gap energy was calculated, and that of the nanocomposites here on figure 1D and E are the nanocomposites. C is multi-wall, A and B are the pristine nanoparticles. A is chemically synthesized gold nanoparticle, and then B here is green synthesized gold nanoparticles. The band gap energy of the nanocomposites, both nanocomposites, were smaller than their pristine nanoparticles, which simply means that a smaller band gap energy means high conductivity, reactivity, and easier electron transfer. And XRD was used for calculating the crystallinity and also the particle size of the nanomaterials. We used FTIR here to check the functional groups, and also SAM to check the surface morphology. And then we realized that when it comes to the composites, both the nanocomposites showed that the nanoparticles of the gold nanoparticles are agglomerated at the surface of the multi-wall carbon nanotubes. This affects their reactivity. Their surface area is reduced, their electrochemical reactivity is affected, the mass transport is impeded, which simply means that their reaction time is affected, and also the electron transfer kinetics are also influenced. But the chemically synthesized nanocomposite here, the figure 4D, shows that it's more agglomerated than the green synthesized nano composite. You will see how that affects their reactivity later. So we continued to characterize all our modified electrodes using the nanoparticles and nanocomposites, and also the Bay electrode in ferrocyanide. And the composites performed far better than their pristine nanoparticles. And then we went further to do scan rate studies sorry, to check the reaction processes here. And then we see that both of them increased, the scan rate increased with the increasing in, the current increased with the increase in scan rate. But when we checked, we calculated, and then to figure out the reaction process, we found that the chemically synthesized nanocomposite had a mixed diffusion and absorption controlled reaction process, and the green synthesized nanocomposite had an absorption controlled process. A diffusion controlled process is whereby the rate of reaction is determined by how quick the reactants can diffuse on the surface of the electrode. And an absorption controlled process is whereby the rate of reaction is determined by how quickly the reactant can absorb at the surface of the electrode. And if it's the reaction process is controlled by both, that means the rate is controlled by both of them. Here we did its catalysis. It's whereby we ran both all the electrodes, modified and unmodified, the nanoparticles, pristine nanoparticles, multi-wall, together with the nanocomposites in methylene blue dye. Multi-wall performed better than both the nanocomposites, even though they had the cygenistic properties whereby they combined multi-wall with gold nanoparticles. Here, the reason for this is because of the agglomeration that I showed there. It's because the nanoparticles were agglomerated at the surface of multi-wall. That hinders their reactivity, that hinders the conductivity of the nanocomposites. That is the reason why multi-wall here performed better than the nanocomposites. And then we went further to do scan rate studies. It is observed that the current increases with the increase in scan rate, but the sorry, the reaction process for the chemically synthesized nanocomposite is mixed diffusion and adsorption controlled, and then for the green synthesized, it's diffusion controlled. And then we went ahead and then did concentration studies to check the sensitivity of the nanoparticles, and then we found that the chemically synthesized nanocomposite had a limit of detection of 20.62, a limit of quantification of 62.51 nanomolar, and then the green synthesized had a limit of detection of 20.23 nanomolar and an LOQ of 61.30 nanomolar, which simply means that the green synthesized nanocomposite had better sensitivity than the chemically synthesized. And also we can see that here on figure 11A, the current increases with the increase in concentration, but here the current reduces with the increase in concentration. This the normal way is this one here on figure 11, and then this one here on figure 12 shows that there's mass transfer peak current limit. It's a process whereby the rate of reaction is occurring so fast that the rate of mass transfer cannot keep up. So the only way electron can be transferred is for mass transfer to reduce the current. We compared our work to the previous work that has been done on methylene blue, and out of the 11 materials that have been used, our material was better than 6. Was better than 6 of those 11, and the top 2 of the 11 is the previous work I did on methylene blue, on using silver and multi-wall. This time around, I'm using gold and multi-wall. To check the selectivity, we did interference studies to check whether our electrode will be able to detect methylene blue in the presence of other compounds, such in this case, sunset yellow. We can see that this peak here around between 4 and 6 is for methylene blue, and this one here is for these 2 here for sunset yellow. This one is for sunset yellow. This one again here is for methylene blue. That means that the peak separation was good. We did real sample analysis in river water, whereby both the electrodes performed very well, but the green synthesized nanomaterial had an LOD above 100. And this simply means that it was experiencing what is called the matrix effect, whereby the presence of other compounds in the river water was boosting the recovery of methylene blue dye at the surface of the green synthesized nanocomposite electrode. In conclusion, both electrodes performed very well, but the green synthesized nanoparticles performed better than the chemically synthesized in terms of selectivity. In terms of sensitivity, their selectivity was, both of them was okay. And also the recovery, the recovery of methylene blue in river water, the green synthesized nanocomposite performed better than the chemically synthesized nanocomposite. Here are my references. Thank you very much.
Thank you, John. I'm seeing Bernard is a bit weird. And yeah, we'll just continue to proceed with the next speaker to gain time.
Okay, thank you very much.
Yeah, thank you, John. Karima has not yet come,
Okay.
so Hajer Galusi. Louisa, is this Hajer is your student or something?
I will call her now.
If she cannot, can Same present? If Same can present quickly, if she has something she wanted to.
I will ask her.
If not, we just need to ask somebody else to take this slot.
You can, somebody
Can you
else can start
Thank you.
and we will go after that.
Yeah. Mr. Cabello?
Present.
Okay, Mr. Cabello, you can just present your... Rupali, please put down your... You are still having your lecture on the screen. Okay. Okay.
Yes, and as you start, thank you and welcome Dr. Rupali to this meeting again. You can still help me share the meeting. Thank you.
Mr. Banda, you can start speaking.
Greetings, everyone. Am I audible?
Yeah. Are you using two computers or there's some?
Not anymore. It's fine. All right. Greetings, everyone. My name is Cabello Samuel Banda, and I would like to thank you for this opportunity. I am grateful. Now, I'll be presenting my work. This is in master's. I'm a master's of chemistry candidate, and I am doing this work with Professor Omalola Esther Fayemi here at the Northwest University in South Africa. So the title of my project is Square Wave Voltammetry Determination of Ion Concentration at Screen Printed Modified Speed Panel Electrode. So now this is my presentation content. And then within my presentation, there will be introduction, literature review, problem statement, aims and objectives, methodology, results, and conclusion. Now to my introduction. Now, what is water? Water is a basic human need. Water is used for various applications, and I can bet you 100% that each and every one of you here today have used water. Now, in the human body, water is necessary for hydration, regulating body temperature, and maintaining cellular functions. Now, there are various sources of water. Water can be directly from the rain, dams, rivers, and water reservoirs. Now, within our water, there is a major component, which are heavy metals. Now, there are different heavy metals that can be found in our water, can be iron, arsenic, copper, zinc, lead, and also silver heavy metals. Now, all of these heavy metals, they have a permissible limit they are not supposed to exceed. For example, iron, which is the heavy metal in focus in this project, has a permissible limit of 0.3 micrograms. So if that permissible limit is exceeded, the iron becomes detrimental to the human body. Now, the sources of heavy metals can be from domestic sewage, agriculture source, industrial source, urbanization, natural source, and also mining source. Now, iron has numerous harmful effects. Iron can contribute in laundry stains. It can contribute in ceramic and porcelain. Iron can create stains in your sinks, toilets, and tubs that are tedious and difficult to remove. It can also cause clogging. Iron can clog anything from wells and pumps to dishwashers. washing machines, and other appliances and accessories. So this is why now it's important to come up with methods to detect these heavy metals in our water. Now, there are numerous methods used to detect heavy metals in water, which include atomic absorption spectroscopy, inductively coupled plasma mass spectroscopy, and ion chromatography. But now these methods have two main requirements, which are considered disadvantages. One of them being that these methods, they need a skilled operator, and a skilled operator doesn't come cheap. It requires funds. Another thing is that these methods, they require expensive equipment. And as much as we're trying to come up with solutions to detect our heavy metals in water, we are trying to come up with solutions that are feasible over time. So this is where now square wave voltammetry comes in as an alternative solution. Square wave voltammetry provides a fast on-site detection, fewer complicated operational procedures, high selectivity and sensitivity at a reduced cost. Now, to apply our square wave voltammetry, we use electrochemical sensor. Now, what is an electrochemical sensor? An electrochemical sensor is a device that converts electrochemical information into an analytical signal. Now, our electrochemical sensor can be classified into different methods. It can be potentiometric, amperometric, and impediometric. Now, electrochemical sensors can be applied to different sectors. It can be applied in the agriculture sector, health sector, water analysis, food safety, and the environment. Now, in this project, we used two polymers to modify our electrodes. One of them being polyaniline, which is abbreviated as PANI. Now, polyaniline is a conducting polymer that stands out amongst other polymers because of its inexpensive cost of production, non-toxicity, environmental stability, and conductivity. We can use PANI in sensors, energy devices, catalysts, biomedical applications, and water purification. Another polymer that is used is sulfonated polyether ketone. Now, sulfonated polyether ketone is a thermostatic polymer that has sulfonic acid groups added to its polymeric chain. Now, the problem statement. Now, the problem statement of this project is that the presence and accumulation of heavy metals in water is a severe threat to human health and the environment. One of the illnesses that can result from high exposure of heavy metals in your water can be respiratory illness, headache, kidney damage, and skin irritation. And I'm sure no one wants one of those illnesses. So now exposure of heavy metals to the human body has been proven to be dangerous. So the detection and determination of their concentration in water is essential to ensure human safety. Now the aim of this study is the project aims to determine the concentration of iron at screen printed modified SPIC PANI electrode. Our objectives, one of our objective is to synthesize PANI, SPIC, and SPIC PANI composite to perform optical, morphological, and structural characterization techniques, modify our screen printed electrode with the above nanomaterials using a drop dry method, and also to conduct electrochemical studies. Now, to synthesize our PANI, we polymerized aniline using 2.59 grams of our aniline, and then we also used hydrochloric acid. We mixed, and then we washed and filtered, then dried, and then we obtained our PANI crystals. We also, for the synthesis of our SPIC, we sulfonated the polyether ketone, and we also used sulfuric acid. To the composite formation, we added a mass or volume of our SPIC and PANI, and then we drop casted on our electrode. And then we performed numerous characterization techniques, one of them being X-ray diffraction. Now, we use X-ray diffraction to study the crystallinity of our materials. Now, in figure 1A, the diffractogram of PANI can be seen, and it shows characteristic peaks of PANI. Figure 1B shows the diffractogram of our SPIC, and figure 1C shows the diffractogram of our SPIC panel. And then we also used FTIR to study the functional groups that can be found in our materials. And we obtained a spectra of PANI, SPIC, and the SPIC-PANI composite. And the spectra show the characteristic functional groups which can be found in our materials. Another analytical technique that we used is the SEM analysis. Now, we used SEM to study the surface morphology of our materials. Now, in figure 4A, our SEM image of PANI can be seen. Figure 4B shows our SPIC image, and figure 4C shows the SPIC PANI composite SEM image with characteristic objects, with characteristic functions and formulas that can be seen. Now, we also went on to do electrochemical study. We used cyclic voltammetry for our electrochemical characterization. We characterized our bare electrode, PANI electrode, SPIC electrode, and the SPIC PANI electrode in ferricyanide. And from the voltammogram obtained, it can be seen that our PANI had a high current response compared to our SPIC and SPIC PANI electrode. This is because PANI has very high conductivity compared to our SPIC and SPIC PANI. Table 1 summarizes parameters of the comparative studies in ferricyanide, and it can be seen that our PANI electrode had a high current response, and our SPIC PANI electrode had the second highest current response. We went on to study the effect of scan rate and linear plots, and from our voltammogram, we can be seen that our current response increases as we increase the potential. We went on to do electrocatalysis of our iron using the PANI modified electrode, SPIC modified electrode, and SPIC PANI modified electrode. From the voltammogram obtained, it can be seen that the SPIC PANI electrode had the highest current response compared to our PANI and SPIC electrode. This shows how the ability of our SPIC PANI electrode to now be used to quantify our iron. And now we also went on to study the scan rate effect and linear plots of our SPIC PANI electrode in our iron solution. And from the voltammogram, it can be seen that the current response increases as we increase the potential. We went on to quantify our iron using a square wave voltammetry. And from the voltammogram obtained, we were able to calculate the detection limit of 0.130 micromoles and the limit of quantification of 0.245 millimoles, my bad. Now to my conclusion, the SPIC PANI and SPIC PANI composite were successfully synthesized. The successful synthesis of the materials were confirmed by morphological and spectroscopic techniques. Electrochemical techniques were utilized to investigate the sensitivity of the SPIC PANI electrode for the detection of iron. The detection of iron at the SPIC PANI electrode was successful with recorded limit of detection of 0.130 micromoles and 0.081. Future work, our SPIC PANI modified electrode will be used to do real sample analysis, and we will also be studying the reproducibility and stability of our electrode. Acknowledgement, I would like to acknowledge the Northwest University. My supervisor got support from my research group and support from my family. These are my references, and I thank you.
Thank you. Bernard, you take over.
Yeah, thank you for the nice presentation and also for keeping time. And I will go straight forward to Judith. You can have your presentation and also keep time. Thank you.
Where is Judith? Is Judith prepared? If not, so that I don't know, she skipped that time.
Danielle Hajar is here. She can present
Yes,
her
can we go to
Yeah, okay, let Hajar
presentation.
present. Let Hajar present the next.
Yeah.
Is he sharing his screen? Let Mr. Hajar.
She's here.
Oh,
Yes, I am here.
So she, okay.
Yes, I am.
Okay, please share a screen and present. Hajar, can you share a screen?
Um, I'm here. Can you wait, please?
Can't you share your screen? Do you have problem sharing your screen or? Okay, so if it's not possible, we can move with the next person.
Yes, I will come the next present.
Okay.
Okay, and yes.
Who is the one now? Is this Hajar here?
It's Judith.
Judith. Okay, Judith, can you
Okay,
present?
yeah.
Okay, then.
Yes. All right. I'm really sorry about the delay. I had network issues. But good afternoon. My name is Judith Letwalo, and the title of my research is Electrochemical Sensor for the Detection of Sunset Yellow in Food using polyaniline carbon nanopowder nanocomposite modified electrode under the supervision of Professor Fayemi. My presentation outline is as indicated on the slide. Consumers often base their food selection on a product's color, which gives them a first impression of its flavor, texture, and freshness. As a result, it has become the justification for the addition of additives to food items. Food adulteration, also known as food fraud, is in two primary forms, intentional and unintentional. Both intentional and unintentional adulteration may reduce the safety and the quality of food products, posing health risks to consumers. An example of food fraud is the addition of synthetic azo dye sunset yellow for food coloring with E number 110. Sunset yellow has been used in pharmaceuticals, cosmetics, and food industry. The World Health Organization and the Food and Agriculture Organization have determined the acceptable daily intake for sunset yellow to be 4 milligrams per kilogram of body weight per day. When sunset yellow is consumed beyond this daily intake, it can cause health issues such as asthma, migraines, and eczema. Recently, numerous analytical methods have been developed in detecting sunset yellow. This method include thin layer chromatography, high performance liquid chromatography, mass spectrometry, capillary electrophoresis, and electrochemical synthesis. Nonetheless, none of these methodologies can lay claim to the combined advantages of cost efficiency, portability, rapidity, and vessel manipulation inherent to electrochemical techniques. Khan and colleagues, they have developed an electrochemical method based on graphene in a mesoporous titanium oxide carbon-based electrode, which they found an LOD of 6 nanomolar. And similarly, Gaucher modified a carbon-based electrode with gold nanoparticles to detect sunset yellow, and the LOD they got was 3.0 times 10 to the power 8 molars. In this work, carbon nanopowder and polyaniline composite are explored for the use of electrochemical detection of sunset yellow using square wave voltammetry. To synthesize polyaniline, a polymerization method was used as indicated on the schematic diagram. Nanocomposite was formed by mixing 75 milligram of honey with 25 milligram of CNP in DMF and subjected to ultrasonication to form a composite. To confirm the synthesis of the material and study their behavior and interaction, characterization methods such as TAM, SAM, EDS, and electrochemical techniques such as CV, square wave, and ERS were employed. From my results, FTIR was used to study the functional groups in the nanomaterials. FTIR analysis in figure 1 indicated that the nanocomposite exhibit the same characteristics as the individual materials. However, the corresponding peaks of the penny has shifted to a smaller wave number with a decreased intensity. The shift in wave number could ascribe to the successful incorporation of the CNP and the penny. With the optical properties, the red shift is absorbing at 288 nanometers, whereas the blue shift at 325 and 620 nanometers. As seen on the black shift, which is the nanocomposite, we can see that both individual peaks are present in the black shift, but there is a shift towards the left, suggesting there is interaction within these materials. Figure 2b shows the band gap of CNP, which was calculated using Toxplug and was found to be 5.49 electron volt. X-ray was used to study the lattice parameters and the crystallinity of the material. The Miller indices corresponding to the angle are consistent with values reported in other literatures. TEM was used to study the morphology of the material and also to calculate the particle of the CNP, which was found to be 35 nanometer as indicated in figure 4D. SAM analysis gives us the morphology and the shape of the material, which supports that obtained in TEM results. Pani displays a rod-like morphology with a certain region exhibiting agglomeration, whereas CNP particles are uniform, exhibiting a spherical shape. The nanocomposite exhibit both shapes, suggesting the recent interactions in the nanomaterial. EDS was used to study the element composition of the nanomaterials as indicated by the figure 6. The small traces of copper could be due to the contamination, but since they are very, very small, they could be negligible. Electrochemical characterization were used to study the electrochemical properties of the modified electrodes, which were evaluated using a redox probe. These findings indicate that the CNP nanocomposite successfully enhances the surface property and the electrical conductivity. As indicated on the table, the modified electrode exhibited larger surface area and highest current response. EIS was also employed to further characterize the electrodes. The Nyquist plot in figure A is presented with the equivalent circuit used to fit the ERS data for this electrode. On the table are the fitted parameters such as solution resistance, charge transfer resistance, etc. This result supports those that are obtained in CV. The effect of pH on sunset yellow oxidation was investigated over a varying pH levels using CV at a scan rate of 25 millivolts. The highest oxidation current response was observed at pH 7, hence pH 7 was used to carry out the studies. Electrocatalytic response of the PANI CNP and the composite in SSI was assessed through CV at a scan rate of 25 in 0.1 millimolar sunset yellow, prepared with 10 millimolar PBS. The oxidation current of the nanocomposite electrode was 10 times more than that of the bare electrode, suggesting that the combination of the PANI and the carbon nanopowder provided a synergistic effect that enhanced the electrolytic activity of the composite. The effect of scan rate on the sunset yellow oxidation at the nanocomposite was also evaluated. As seen on figure 11A, the oxidation peak current increased with increasing scan rate. The results indicate that the reaction involves both diffusion control and surface confined processes, as shown by our linear graph. The effect of varying concentrations on the current response of sunset yellow was determined using square wave voltammetry, as shown in figure 12. Oxidation peak increased with the increase in concentration. The linear relationship was also obtained within the linear range of 1:9, 194 nanomolar. The limit detection was calculated to be 181 nanomolar, and the limit of quantification was 5.49 nanomolar. This is a table that compares the previous methods that were used to detect sunset yellow. And from this table, we can see that the results that I've obtained from my own investigation are comparable. Real sample analysis was performed using Mascopa snakes as a sample, so to check the practical rationality of the designed electrode in the real sample that contains sunset yellow. Square wave of unspiked and spiked samples was recorded under optimum conditions. Table 3 shows the results obtained for real sample analysis with recovery values between 95 to 99% with an average RSD percentage of 2.19. The good recoveries confirm that the detection of sunset yellow on modified electrode is reliable for the direct determination of sunset. Sorry?
You can continue, but you can slowly come to an end.
Yes. Figure 13, it shows the interference. So since sunset yellow is an ionic dye commonly found in food alongside other cationic ionic dyes, the selectivity of the PANI-CNP test electrode was examined in the presence of methylene blue. It shows that this figure shows that the electrode exhibited strong selectivity with the constant concentration of the methylene blue. The electrode was able to detect sunset yellow as the concentration of methylene blue was kept constant, and that of the sunset yellow was increased from 14.7 to 32 micromolar in the presence of MB. The stability of the electrode was also investigated. About 29% increase in the oxidation peak current was observed, potentially due to an increase in electroactive surface area. In conclusion, the study addresses health risk associated with food adulteration, and also it develops a detection sensor, which is based on the PANI-CNP nanocomposite, which this material was confirmed using various characterization. Electrochemical analysis, including as square wave and CVNERS, shows that the nanocomposite exhibit enhanced electron transfer and is superior in detecting sunset yellow compared to other electrode. This sensor also demonstrated a low LOD and a broad linear range. Despite moderate stability over 25 scans, the sensor's favorable performance metrics suggest it is a strong candidate for commercialization and point of care in sunset yellow detection in food products. This project was supported by the NRL, Northwest University, MASIM, and I would also like to extend my thanks to my promoter, Professor Fayemi, the chemistry department, and my colleagues in the electrochemical center group for their unwavering support. These are the references that I've used. Thank you.
Yes, thank you so much for that amazing presentation. And we'll have the next presenter to be Aja Galousi. Thank you and welcome.
Thank you.
Bodiba, please stop sharing your screen.
Aja, can you start presenting? We are
Yes,
seeing
Aja, you
your,
can carry on.
we are
Yes.
seeing your screen. I think she's
Aja,
playing. Are you
yeah,
playing? She's playing something which we are not hearing.
Yes, this is a video.
Yeah, but we are not getting. We are not getting the sound. That's the problem.
The sound doesn't work.
Okay.
Can't you speak? You can present it yourself.
Present Hajar.
Il faut parler toi-même.
Hajar, tu peux parler directement.
we still can't hear.
Hello, ladies and gentlemen. I am honored to be here with you today. Before I begin my presentation, I would like to extend my sincere thanks to the organizer for their effort, for tremendous effort. It's making this gathering possible. My name is Hajar Galousi and I am a PhD student at the University Al-Arabi Tbilisi in Tbilisi in Algeria. Today, I am extended to share my research with you and engage it in the future discussion in the subject of electrochemical assessment of the ethanolic extract of an Algerian flora species as an additive in zinc electroplating. Now, it's give me a pleasure to present with you in a small introduction for the part of the work with my team. Zinc electroplating is a relatively common method of protecting steel and either iron alloy from corrosion. It's due to the property that the zinc possesses, such as the natural abundance. The need not only to prevent steel from corrosion, but also to improve the aesthetics value, and using the additive in electroplating both is an important parameter for the improvement of electromechanical and the physical property. In this study, the ethanolic extract of Algerian flora obtained through the following protocol of extraction was tested as an additive in a zinc electroplating in aim to improve the quality of zinc deposit in the milled steel. Experiment and the result. The electrode deposit both consist of H3PO3 and ZnCl2 and KCl and different concentration of the plant extracted ethanolic. Electrode deposition conditions. Electroplating of zinc on steel was performed by immersing the steel specimen and zinc in the plating solution within a distance of 1 centimeter between them. The best experiment condition obtained are current value of 0.09 A and pH 4.5, and the plating time is 30 minutes. The layer deposit was evaluated by brightness, strength of addition, and thickness illustrated in the following table, which indicates that the presence of the additive in plating both gives plat bright and semi-bright for all the concentration tested. Now, the potential dynamic polarization were used to the study of performance of the plating specimen in seawater. The following table presents the result obtained, which evaluate that the presence of the different concentration of the MA led to decreases in the current densities as well as the corrosion rate compared to small obtained in their absence, indicating that the presence of the additives gives the plats less porous and more resistance to corrosion. The potential dynamic polarization measurement for the whited specimens in seawater with and without different concentration of the additive. Finally, from the result obtained, we can conclude that the MA showed the good effect of the quality of the ZM, which gives the plats bright and semi-bright from the concentration tested. The small plated in the presence of different concentration of the plats were more resistant to corrosion compared to the plate in either absence. Thank you for your attention.
So thank you very much. You was concise and precise. So we will just go, because the time is running, to replace Dr. Karima Hanani is
Daniel.
Same Budiba there?
Professor. Karima had a toothache, and she sent you her audio presentation. Can you share the audio, and I will answer the question if there is.
When did she send me
any question?
presentation? Where? Which? I think, okay, what we'll do, we can play it at the end so that we can just get time.
Yeah, we can keep her at the end.
Yeah.
Samah is here. She can present if you want.
The time is also against. Let's go to the next session. Samah and Karima could present towards the end. Okay. I want the people have been waiting. So I will just ask Professor Esther to chair the next session, and with Noel, together with Noel Kwa. Can you? So the last Hanani and Sameh could present towards the end. Yeah, at the end. So that because time is so totally against us now. So
okay,
thank you. Around? Yeah, you are there. So.
Okay, thank you, Prof, for the opportunity. So I think I'll gladly take this assignment with Dr. or Prof. Nkwa. Are you here, sir?
I'm here.
All right, sir. So I think, should I go ahead with the first two presentations? Are you fine to go ahead with the remaining three?
I'm fine with that.
Okay, thank you, sir. So, okay, I will want to know if Dr. Ina Colombo is on board from France.
Yes, I'm here.
Okay. All right, please. You can gladly share your screen with us. Is going to present to us, or she's going to present to us on International Institute of Refrigeration, Sustainable Cooling Funded Projects. So let's wait and engage with the presentation. The floor is yours. Thank you.
Hello, everybody. Thank you very much. I'm going to present to you two funded projects that is going on at the moment at the International Institute of Refrigeration. And after that, what I will do, I will, oh, I'm very sorry. I will share a presentation, a recorded presentation. So let me see if I can do that. I'm not used to Zoom, but I think I'm going to try now. Yeah, this one. Authorize. Yeah. So that the first one, I hope you can see my screen. That will be about the funded project, a new one that started in June 2000 last year. This name is called, the project is AgriCool, is Advanced Sustainable Agriculture through Off-Grid Energy and Cooling Solution in Africa. You've got the QR code now on the screens, if you can flash it, so that we'll try to go fast, so that I know you are a bit late regarding the timeline. So you can flash the QR code and you go to the website, which the International Institute has developed, and you can check what the content. So the project aims to empower African rural community and industry by enhancing food security, reducing waste, and fostering economic growth while contributing to achieve African country target under the Paris Agreement. To achieve this, the consortium will develop containerized solution in which food can be stored and cooled will be cool. So that would be the objective of this project. So it's got 13 partners, and on the next slide you see the different partners. The project is a 4-year funded project. It's got some 4 pilot countries, and the objective is to reduce food security and reduce waste. So here are the various partners. The project is coordinated by the University of Twente in Netherlands, and you've got 12 other partners all between Europe and Africa. You've got South African partners, Italian, from Spain, from France, South Africa, Cameroon, and Capo Verde. And those containerized solutions will be installed in 4 pilot countries: South Africa, Capo Verde, Somalia, and Zimbabwe. Next slides. Oops, I don't know why it's not going to the next one. Yes. So the end of this project is to develop storage containers using photovoltaic technology, thermal energy storage, chillers, and smart control. As mentioned, there is 4 pilot countries who will conduct life cycle assessment to monitor the environmental impact aligned with the Paris Agreement. Will be some training provision for local farmers, technicians, and engineers, and also we organize advanced courses for engineers across Africa. So I will make it short. The project's got 8 months. The website has been developed. You can follow us on the social media. You've got the QR code again of the project. So I haven't got any figures and results to show you. But if you register to the newsletter, the first one will come out next week. So please, you can flash code the QR code, go down to where to subscribe to the newsletter. If you do it today, you'll receive the first newsletter next week. So thank you very much. I will move to my other presentation. Hold on a minute, which is about SOFIA, Sustainable Off-Grid Solution for Pharmacy and, oops, hold on a minute, I'm very sorry. For pharmacy and, hold on a minute. Let me see if I can, how do I, no. Oh, it's got the video that I wanted to display. Oh gosh, I'm very sorry. How can I do that? Oh,
just share your screen there. You share the video, so it's fine.
Yeah, but and by sharing the screen, hold on a minute. Share my screen. I see.
Can open it on your system, yeah, then share.
Yeah.
And this one is okay. Can you see Sophia?
It's coming.
Yeah, it takes time. It will come. It will come. Just wait some few seconds.
It's okay like this now?
Just wait a bit. We are seeing something coming.
Ah, okay. And I hope the video will be displaying. Can you hear?
Not yet. Just wait, because we are seeing Ina Colomba is sharing her screen, so it hasn't not yet gone.
No, I don't think it's working. Hold on a minute. I'm very sorry. Let me just stop this and try again.
And don't forget to share your audio so that we can
that's
hear.
it. I got it. Yeah. And how do you share the audio? Where do you see that?
When you say share screen.
Yeah, we are seeing something. We are seeing something. We are seeing
Let's
Sophia.
see if it will
Tell me
play.
if you hear something. Tell me if you hear something here.
Yeah, you can play.
Play
You can hear?
Not
No,
yet.
so
no. So it's got an issue when I'm.
So on share, then you will share your audio. When you say share, you will see 2 messages under options. So then you click share sound. Then we will be able to hear it.
It doesn't give me that option.
Okay.
It doesn't give me. It said I can't see where I can do with the sound. I checked before. Oh,
just
gosh.
share the slide and you talk. It's okay.
Okay.
Fine.
Okay.
Share the slide which you showed us. You can just be talking and explaining.
Okay, so I will try. So this is, you see, huh?
No, we are not seeing the slide. We are waiting. It is coming.
Oh, good.
But
Oh, sorry,
It's
sorry,
here.
sorry. Yeah, it's here?
It's here, yes.
And here, can you hear the sound? No? No.
We
we are
cannot
seeing,
hear,
we are
but you
seeing
can
that
talk.
you can talk. You can just talk.
Okay, so this is the project. The project. So the project is got started in 2022-21, and the project is to provide safe and clean drinking water, hot water steam refrigeration for medicine at 5 degrees, low temperature storage at -30, and extra low temperature for -70, and provide some electricity. So we've got 13 partners, 5 from Africa, and the consortium is led by the Karlsruhe University in Germany. So here you can see the container that is the water container, no, the cooling container, where you've got various sections within the container, where it's got the machineries, where and we've got some 2 thermal storage to provide chill temperature when the solar powered, the PV system does not provide electricity. To run the refrigeration system, you've got the thermal storage that takes over at 5 degrees. And you've got a storage room at -30. And inside the -30 storage, you've got a small freezer that provides 70 degrees C to conserve the vaccine at very low temperature. The system is a CO2 system, cascade system with propane, and is solar powered by photovoltaic systems. Sorry. And we've got also the water container, where you've got a various system to purify the water and drinking water. So it's 2 containers that we've developed, the cooling one and the water container to provide deionized water, drinking water. And some of the containers will be solar powered by some high quality solar power systems. We've got also another type of solar technology, the PV MedPort, for small off-site clinics, is a 2 kilowatt power PV system that is portable, very easy to transport, and can be used for vaccination campaign in some really rural clinics where people can sit and also have some of the shade of from the sun and be waited to be vaccinated. Okay. So as mentioned, for the Sophia project, we've got similar of AgriCool project, 4 pilot countries: Burkina Faso, Cameroon, Uganda, and Malawi. So we selected with the partnership with the African partners, the hospital. So we've got the Leo Hospital in Burkina Faso. We've got Lyssen Hospital in Edea. You've got the Buvuma Healthcare Center 4 in Buvuma, Uganda, which is an island on the Lake Victoria. And you've got the Mua Mission Hospital in Malawi. Sorry. So here we can see some of the picture of the first container that has been installed in Burkina Faso at the Leo Hospital. They've been built in South Africa by the Overflow partners, shipped to Côte d'Ivoire, and took the road until the Leo Hospital in Burkina Faso, and the team, the technical team, traveled to Burkina Faso to install it. So this is some of the picture of the Sophia system in Burkina Faso with the technical team. We had also the solar cooking Scheffer reflector, high-powered solar technology. You can see in one other hospital, we installed the PV met pot, and we've got also the technology of steam cooking PV steam tube that provide steam water. And we can see here that this technology has been used to cook rice for the patient in the hospital, Leo Hospital. So it's very off-grid green solution technology that can be applied, and we show that it's been applied. At the moment, the 2EI, the engineering school in Burkina Faso, has downloaded the result and interpreting the result in order to provide some academic paper that I couldn't even present in your next conference. But at the moment, it has been so much technical issues that it has been very difficult to really obtain some good data. But things will come up. At the moment, the system, we're installing some other Sophia container in Cameroon at EDEA, is under construction now. I had some picture, but I just received some picture from yesterday, but I didn't have time to integrate them to the videos. And something very important is that we go in, based on the first experience, we going to improve the Sophia system by doing, instead to have two containers, one container, 2-in-1s. You will have one side where we'll have the water, and the other side where you will have the cooling system, 2-in-1s. And this system will be installed in Uganda. For the Cameroon hospital, because the load of cooling was not enough, they decided to send some PV modules to be providing electricity to fridge and freezers in EDEA hospital, in addition to a water container. Something is important in such project is training. We need to train people. So it has been some in the European partners part, some summer schools where some students have been invited to participate to those summer schools, and it's been some local also training in Burkina Faso. Oh, sorry, I don't have the pictures. He has been some training also in Burkina Faso when the system has been installed by the 2EI. Those training were provided by 2EI. And here you can see some of the picture of the trainer session that we've done in March last year to train people to be able to train on site. So this is all, and thank you very much. Sorry, I couldn't make the presentation as I was planning to, but I think I was able to deliver. Thank you.
Thank you. Thank you so much, Dr. Ina. I don't know, Prof. Daniel, do we have time for question or comment?
We can take 1 or 2 minutes for question. This is a technology which it's
Okay.
a great importance and of great technology for rural area. And I believe somebody like Professor Ashmore might have a question.
Definitely.
No,
Okay,
you
so
took me there. Ina, that's exactly what we're trying to propose. Could we collaborate in the near future? I always think about sustainability as one of the things. We have developed solar cookers in the previous years and so forth. We also applied for an EU grant together with Daniel, but we couldn't
Get the money. Yeah, that was
get
the same direction actually.
Yes, containerized solutions, by the way, we had one idea and we threw it away because of the lack of capacity. But my question is, in adopting these technologies, how are you finding it, especially on the African context with people without skills? I see you've actually shipped from South Africa, then you went to some other country to deploy the technology.
To be honest, I'm not into the technical side. I'm at the institute where I'm working. We are working on the dissemination and communication. But it's a very good question. To be honest, things have been seen so far is that you've got the Europeans, you've got the South Africans, you've got the countries sub-Saharan Africa, and it was the first time that the European team had such projects, yeah, and they didn't know the reality on site. Like example,
Exactly.
they were thinking that okay, we send it will be shipped, no issues. They've been facing so much issues. At the moment, we've got 9 months left, and we managed to install only in Burkina Faso. At the moment, they're doing in Cameroon, but the communication is very difficult. It was a first for them. I believe they understand now that what they do in Europe is not the same in Africa, and they had issue of availability of equipment. Like example, they forgot to ship or put in the container some equipment that are bought from China or Europe, and they found themselves waiting for this equipment, or the equipment was not well designed, and they have to wait. And things that they didn't even plan also is the import tax. At the moment, we've got an issue. It's got a technology that is stuck into the port of Douala, and the partner who came on site is waiting for the equipment to be installed, and they do not understand that is a custom. He's got some administration. They do not understand that Friday is half day. They do not understand why they cannot send emails. They do not understand all those things, which make it very, very difficult, even bringing tension within the consortium.
Okay, Ina. So
yes.
I want to add, these are lessons learned. I think Daniel will agree. The thing has to be built by local artisans and it has to be built on site. Shipping, I think you can agree, is not a good idea. People need to be imparted skills from Africa to develop the products themselves. At least they should be training. A person can come from Germany and try to find, the local market, the local people there, and train them.
To be honest, with what they try to do, and it's not like even myself, I've not been growing up in Africa, I didn't do research in Africa and everything. To build the container and ship it to the country, I believe is okay. Because one of the issue of the container of Sophia is they put so many high-tech technology inside. Okay. But the part of when they put on site, what they try to do is to work with the local ones to assemble it, But based on the funds that we had and how the project was done, it was built in South Africa because with this company has got all the equipment and the team to build it. But I believe in Southern Africa, we should be able to build such container locally. Yeah.
Yes, yes, we can. I'm from South Africa. We can build that thingy. But even in other places, I mean, most of these African countries have ports, and ports do have containerized solutions. It's not a matter of building; it's a matter of modifying. That's my worry about it.
Yeah, but
Shipping.
for me, this container, we will see after when it's going to start to run, when we start having some technical issues, will be some problems. I think they make it too sophisticated. They should have made
Exactly.
it simply, but is the fund. They wanted to do some innovation, but now they're realizing, the European partners, that they should have make it simpler.
Okay, there's the
Thank
Dr.
you. Thank you.
Jerome there. Okay, there's Dr.
Please, because
Jerome.
of time,
Okay,
let's
we
give
can
time
talk
to Dr.
after that.
Jerome. Thank you, Prof. Mawire. Dr. Jerome, you can go for it.
Thank you for the opportunity. I was just going to queue up with Prof. Asmore to talk about shipping ready-made project products to Africa. So this is something that could have been done on ground with local experts. And he asked the question of sustainability, which at the end he didn't focus again on it. In Cameroon, right away, the government has a huge project on the installation of solar PV powered mini grid system, with the view of installing close to 300 such mini grids to power local villages. But this far, they've probably installed close to 50. But if you look back, probably 10 to 15 are no longer serving the need for which it was intended. So we need to think about sustainability of projects in Africa. Thank you very much.
Thank you.
Thank you, Doc. I think I agree with that. So we need to delocalize our innovations. So now with that, we go to the next presenter, please. I don't know if Dr. Nandia, if you are available, can you share your screen, your slide with us? Comparison of the performance. Sorry, bro.
It seems as if she's not around. I'm not seeing her.
I'm at home.
All right, thank you.
She's
All
around,
right,
okay.
share your slide with us. She will be presenting to us on the comparison of the performance of biodiesel from Jetrofa and castor oils in an unmodified diesel engine. The floor is yours. Please,
Is a
let's
screen
stick to
share?
15 minutes. Yes. We are yet to see it.
Can you hear me, please?
Yeah, we can hear you.
Sorry,
But share your screen. Share your screen.
I've shared the screen already.
We are not seeing it.
Okay, let me go back.
There's a background noise. Can we try to ask?
The baby is crying.
Yeah, there's a baby crying on the ground. Oh,
that's Africa.
Is a screen shared?
Not yet.
No. When you say share screen, you have to pick the item you want to share. Then you can double click on it, or you click on the item because it will open on your tabs, and then you share.
Okay, thanks.
Thank you.
Something is happening. Yeah,
Is
now.
it done?
Yeah, it's done, yeah.
Presentation mode, please.
Okay, thanks. Good afternoon, everyone. My name is Momo Ngwanevike. I'm honored to be speaking with you today about comparative analysis of the performance of biodiesel from Jatofa oil and castor oil on an unmodified diesel engine. We shall start by introduction, material and method, result and discussion, conclusion and recommendation.
So please go in the presentation mode. We are seeing only the first slide. So
is it okay?
You have to change your slides. Yeah.
I'm changing.
Okay. Me, I'm just seeing just the first slide.
No, it's not moving. It's not
Not
moving.
moving.
I don't know why, but I saw it my first time.
Okay, you can share again.
Share again.
Okay, I'm going back to share. Sorry for the waste of time.
We'll have that patience. Yeah.
It's not shared to.
Yeah, go through the same route. You share, then click on the item you want to share, then share again. Just follow these steps.
I don't know if it's connected.
Recording in progress.
You have two things together. Can you put one of your you have two machines. Nikki, can you close one of the machines?
It's a noise for me.
Sorry, Prof. Sorry, Prof. You are the host. You can mute her. You can mute her on the
Let
other
me mute one of the things because, but if I'm, let me see. Okay, she has. Let me mute this second one. Yeah. So you can go. You can continue your presentation. We are seeing the screen now. The next slide. Vicky, can you speak?
Yes.
You can speak now. We are seeing the slide.
Okay. Okay. Good afternoon once more. I'm Omungwani Vini. I'm honored to speak with you today about comparative analysis of performance of biodiesel and Jatofa and castor oil on the modified diesel engine. First, we shall start by introduction, then material and method, thirdly, result and discussion, and finally, conclusion and recommendations. Access to energy is increasingly regarded as a fundamental essential for any development process. The availability of energy resources, therefore, plays a crucial role on the development by strengthening economic activities and improving the quality of life of its population. However, petroleum, mineral, coal, and natural gas account for more than 80% of the global energy. The polling statement on this, the polling statement here is the energy crisis presents a global challenge in addition to the issue of waste management, which generates greenhouse gases. Moreover, global energy demand continues to rise. However, it is essential to be dependent on fossil fuel with the alternative energy source, reason why we try to work with Jatofa and castor oil. The research question here was how to optimize the diesel engine performance by using different types of biodiesel. key question was asked that has to be answered here in this research, which are, what are the different oil and biodiesel obtained from jatropha and castor seed? What is the different characteristic of the produced biodiesel? And what are the performance characteristics of each biodiesel in a diesel engine? The main objective here is to contribute to optimize the optimization of engine performance by using different types of biodiesel. Now, the method used here when we presented the study area, then we evaluate the oil extraction yield and biodiesel production. Then later we got the characterization of the biodiesel produced. Then we put in the biodiesel into an unmodified diesel engine to be able to see whether our biodiesel is productive or not. Our study area was in Cameroon, precisely in the West region at the Minwa at Cham. After the recall of the jatropha and castor seed, we went through drying, then through weighing, then we used an oil pressing, that was a hydraulic press. Then we went to the laboratory for analysis and for the production of the biodiesel through certification. This is the method that we use. The jatropha method was different from that of the castor oil because both do not, firstly, the viscosity are different. So firstly, on the physical appearance of the oil, we have different methods that we use. But both of them went through certification after 24 hours separation. Then here are the material that we use and the different things that we use: the filter system, the twin neck crown bottom, the speed regulator, temperature adjustment. Here is the separation of biodiesel and glycerin. I hope you can see it on the pictures. Chemical characteristics here. The acid index, saponification index, and iodine index that we calculated this. And the physical characteristics here, the viscosity, the density, the Stetson number, the calorific value, the flash point. Now the performance test. We cannot just produce the biodiesel without trying to inject it into the diesel engine, and we use an unmodified diesel engine to see the performance of the produced biodiesel that we use. And we tested it also with the local diesel that is seen in the market. We calculated the sound with an Android phone to calculate the decibels to compare with that of the local diesel that we use. The obtained result, we can see from this result that so far gave us less result yield than that of castor, or that is 27%. The biodiesel yield, that so far was still less than that of castor, So we can, from this comparison, we can just say that the castor has more yield than that of the jatropha. There's other characteristics that we calculated. Then we tried also to evaluate the production cost, because it's not just to produce. The reagent that we used, the sodium that of jatropha was methanol and sodium hydroxide, while that of castor was ethanol and sulfuric acid. And jatropha gets of a global result of 725 pounds per hour, while that of castor gets of a global result of 1,550 pounds per hour. The power, we also tried to to draw a histogram to compare Jatropha, castor, and the diesel, the conventional diesel that is in the market. And that gave us that the following histogram. And we can see that the castor is less than that of Jatropha. And in this histogram, we mix this day 100, meaning that there was no mixture with biodiesel. Day 50, 50 of biodiesel and 50% of diesel. Day 20, 20% of diesel and 80% of biodiesel for both Jatropha and castor. Now we compare the comparison of biodiesel power related to conventional diesel. We used here the fish test, and there was no significant value, only 0.05. DPR variation, we can just see here that the Jatropha and castor ones are almost at the same level here, and diesel is more than those ones. For DBC variation, it is alike like the DBC. Now for the comparison of DBA and DBC of the comparison of the two biodiesel, we can see at the on the table there's no relative, no slight, there's just slight difference between them. Now to conclude, castor still gave us a bit of 27% and 83.3%, while Jatropha gave us a yield of 17% and 99.4% of the oil and biodiesel. The physical characteristics of Jatropha and castor diesel calculated regarding the biodiesel as follows. The viscosity was higher than that of Jatropha was higher than that of castor. As earlier said, the tenor same, combustion same, flash point same. Reason why the production cost of 1 liter, because we try to evaluate the production cost for 1 liter of Jatropha and castor. And that gave us a reasonable amount of 725 pounds for Jatropha and 150 pounds for castor. Now the application of the student test on Jatropha and castor oil sample at 5% probability level, using a reference mean of 24.76 for biodiesel, revealing a significant difference between the analysis of Jatropha and castor biodiesel from different blends. However, no significant difference was found between Jatropha and diesel under load. The power output of the oil compared to diesel was 11.7 watts, and compared to Jatropha and castor, it was 6.63 watts, resulting in a difference of 5.08 watts in favor of Jatropha. The sound was calibrated at 94 decibels. And after data processing, diesel was found to have the highest sound level at 135 decibels. Now, the recommendation here that we did for the study as it was in Cameroon, we raised awareness among the population about biodiesel technology in the transportation sector and electricity production using biodiesel generator, because we realized that biodiesel and Jatropha are common plants that are usually used as farm fences here. Now, establish a legal regulator framework for setting standards for biofuel analysis in Cameroon. Support the development of biofuel through incentives, policies, and production. Support the scientific research at the university level, which is not really done. Then adopt an effective decentralization approach to enable local communities to develop their resources from energy production with what they have at their local level. Now, to conclude, for future projects, we just we recommend here that they conduct a very deep physicochemical analysis of biodiesel to compare the blending properties and clarify the obtained result. Then conduct a comparative audit of different biodiesel production technology to determine the most efficient method in terms of yield. And lastly, study the valorization of oilseed cakes after oil extraction from the true state of the production bioethanol, charcoal, and biogas. That is really necessary for the local ones, and that are also good residues that can help for many other things. Thanks for your kind attention.
Okay, thank you, Dr. Vicky. Do we have any question for Dr. Vicky? Comments? Yes.
He's still a master student, I think.
I have a question for her.
Okay.
Okay, thank you very much, Dr. Nadia, for your wonderful presentation. In one of your slides, you mentioned that data was collected using a mobile phone. I would like to be clarified. In one of your slides, you mentioned that data was collected using a mobile phone. So I would like to be clarified on the type of data that was collected and how the data was collected using the mobile phone. Thank you.
It was an Android app to measure the sound. Yes,
Okay.
it's what we use. It's what we had in our.
Thank you.
Okay.
Yes.
Thank you.
An app.
Okay, I think because of our time, if we don't have any comment or question for Dr. Vicky, I guess we will move on right now. I'll hand over to my next chairperson, Dr. Unkwa. The floor is yours, sir. Thanks.
Thank you very much, Professor Omolola, for handing over to me. And it's a great pleasure to chair this session together with you. So right now we are going to move to the next presentation. That is going to come from Dr. Rela. Some noise in the background. I don't know where it's coming from. Okay. So do we have Dr. Mirela from Tabesa University?
Yeah, she's there. She's Elka. Dr. Mirela, can you share your screen? And please, Vicky, can you stop sharing your screen so that it should not intervene? Vicky, Momo, stop sharing your screen. And Dr. Mirela, please start sharing your screen. Dr. Mirela, can you share your screen? You told me you are Elka today. Please, can you share? If not, we have to continue to the next person just to gain time. Okay, you
Okay.
say yes. You said yes, she can stay. So please share your screen then.
Dr. Mirela? Okay.
Hello, Daniel.
Yes, Dr. Mirela, you can
Okay, thank you.
go ahead.
Hello, everyone. I'm honored to be part of this conference. I want to thankful all the organizers of this conference, especially Mr. Daniel and Miss Veronica. My name is Mirela Lușlari, and I'm from Albania. I work at the Institute of Applied Nuclear Physics, and I involved in the Department of Instrumental Analytical Methods. For today, I will be present assessment of lead concentration in surface soil in the industrial area. Here is the content of this presentation for today. And the focus of work in our lab in atomic absorption spectrometry's laboratory is determination and identification metals, essential and non-essential metals, heavy metals, in different kinds of samples. The nature of samples that analyzes can be in three aggregate states: solid, liquid, aerosol. But for aerosol, we use just the paper filter. And the kind of samples that are analyzed using atomic absorption spectrometry techniques can be environment, soil, water, aerosol, etc., biological sample, archaeological sample also. In the lab, there are two instruments for atomic absorption, and there are presented just photos of them here. And in this slide, has presentation a lot of, a short process for atomic absorption, just to see or to create the idea for these techniques. And the object of this work or study is selected the territory around the factory, the former factory exactly, to battery production in Berat, Albania. This factory has begun its activity in 1970, and it was designed to produce batteries for passenger cars and trucks, and is also for technical equipment. This factory has been operating at full capacity for about 25, 30 years. And in 90 years in our country has a lot of change. And in that time, its activity was stopped, and primary products, that was battery production, especially secondary products and industrial waste, were in uncontrolled and under atmospheric condition. Industrial waste in that time was mixed with soil near the factory, and pollution was uncontrolled even outside the territory of factory. People did not know and didn't any information for danger of these products. Later, this area was a hotspot polluted by lead, and several studies were done for this territory. The goal of this work is to assess the impact of the industrial lead waste on the surface soils around the former factory of battery production, also inside the building of the factory because this factory was destroyed in 1990 years. There are some main objectives to verify the lead concentration surface soil samples, to examination the distribution of lead concentration depend the distance from the factory, and in the end to compare the lead concentration found in samples with the maximum level concentration specified by the directive of European Community. Lead is one of the trace elements component of the Earth crust, but it's found. First of all, it's not exist in pure forms, but it's found just in the form of ores. This is the natural forms of this, but lead has good physical and chemical properties. It is resistant, very resistant to atmospheric conditions. There are two main sources of lead in the environment: natural or artificial or anthropogenic source. And lead we can find in the environment in different parts of it, in soil, in aerosols, in water, in vegetable, etc. Lead can be used in, especially for acid batteries, but it used also for construction, especially for hospital, for X-ray screens and nuclear station, because it's very protect there. Can be added in alloy, etc. Lead is one of the heavy metals with high toxic properties in low concentration. Presence of lead has negative effects on the environmental parts, and I would like to say that the negative effects of lead are dependent from the level of content in the part of in the environment in general, and the duration of the expose. The presence of lead in the environment exhibits for health problems, because lead can uptake from plants and animals through nutrition, and in this way reaching the food chain. There are 3 ways to expose of lead in humans and animals, that are food and water, respiratory process, and the skin also is one of them. Lead has a negative impact on the environment. Presence of lead has a negative impact on the environment. Pollution of the soil also results in pollution in water or in different parts of the environment, because it can be changed, exchanged with in different parts, because it transferred independent the weather condition or in different other conditions. And here is presented schematic pathways of human expose from all the source in the environment. Lead is one of the elements with high toxicity. For this reason, for it exists maximal level concentration, and we refer the European directive for not only for lead and for another elements. Lead from maximal level concentration by directive European is 50 up to 300 ppm. Also, I selected and lead in soil maximum concentration specified by FAO. Here is
Dr.
present.
Mirela,
Yeah.
sorry to interrupt. We would like you to round up in 2 minutes.
Sorry?
We would like you to round up in 2 minutes.
Okay.
Yeah.
Sampling points. Here is presented the sampling points. In the left is the map of Albania, and in the other as presented the map that were collected sample. This is presented in this slide. It was presented the coordinate of samplings. There are some photos when we are collected the sampling. And after take a sampling, we had prepared in the lab, and representative soil samples are digested according to analytical method absorption spectrometry. Also, for quality control, we had analysis use reference material SOIL 7 and internal standard. All the samples are prepared for physical and analytical or digestion. And after that, there are measurements for to found the lead concentration inside. First of all, we took a calibration curve, and after that, we had obtained the results. That all the results are presented in this slide. From result obtained, we can say that representative soil samples were collected from the factory building in up to 2,000 meter distance. The concentration of lead in surface soil samples was found to range from around 100 ppm to 4,000 ppm. The highest concentration of lead was found in sample collected inside the building of factory. And from the factory building up to 200 meter distance, the lead concentration found to be high again, but much lower if we referred inside the factory. Lead pollution was present up to 800 away from the factory building, and the concentration of lead in that distance has been around 300 up to 900 ppm. Over 800 meter distance away from the factory building, the concentration is below if we compare with maximum level concentration recommended by Directive European. The fraction of lead found in soil samples will compared with the maximum level concentration also from the Directive of European Community, and from result also obtained 12 representative samples, soil samples contain lead concentration above this value that we recommended for lead concentration in soil. From result obtained, we calculated the coefficient for representative soil samples, and this coefficient is ranged from 0.54 to 80 times more. Here is presented the concentration of lead in surface soil sample, and with red color is value from recommended by European directives. Here is presented the counterplot of lead regarding of coordinates north and east. Probability of plot of lead soil sample is presented in another slide. And here is presented the dependence of lead from distance, because we refer zero from coordinate 0 in the factory, like a source of the lead. and in a distance around 2,000 meters. And here is presented concentration, but are grouped from around the factory, in factory distance up to 200 meters, and in the end in agriculture soil, because we were collected on the agriculture soil when the cultivate different agriculture, like agriculture plants. Here is calculated this coefficient, calculated hazard quotient, but according the results that we are collected. And in the end, we can say some conclusion. During this investigation, the fraction of lead was found to be present in the all representative surface soil samples that were analyzed. The surface area inside the battery production plant is high contaminated. The contaminated territory with lead is located within the factory territory up to 200 meters. The level of lead in the soil is reduced in samples taken away from the factory in the distance around 100 meters. The level of lead concentration found in the cultivated soils, in agriculture soils, is below the maximum concentration level recommended by European Community. And from the result obtained, 12 representative soil samples around the factory contained lead content above the allowed level for lead concentration. In this area, calculated the hazard quotient was very high. This is in range, as we mentioned before, 0.4 to 20 times more than normal from the standard.
Dr. Mirela?
Okay, finish.
Sorry.
Okay.
Thank
Thank
you.
you very
Thank
much.
you for
There
your
are some pictures for my
presentation.
country, not all the picture with pollution with lead. Thank you so much. And thank you for your attention, for kind attention.
Okay, thank you for your presentation, although you have taken more time than you should have. So I don't know if we can give chance to one question.
Distance from factory is about just wait.
Dr. Mirela?
Yes.
Yes, we are waiting to have questions. Is there anybody with a question to her?
I think if there's none, I will just thank her. Okay, she represents our network in Albania, so she's national representative of ANSOL there, and yeah, so it's also good for us to have topics out of the box, not only solar, but also this lead contamination is an issue which we find in perovskite, people working on perovskite, yeah, where we're trying to do lead-free perovskite because lead is not environmental friendly. If we want to make a link between what she's saying and what we are doing here. I think we can continue with the next presentation. So thank you very much, Milela.
Thank you, and you. Thank you and congratulations. Thank you.
All right, our next presentation is going to be from Randa Bayot from
Yes, I'm here. I'm here.
Please, can you share your screen?
Yes.
Please, Dr. Mirela, stop your screen.
Randa, stop your screen. Stop sharing.
Okay.
Can you see my screen?
Yes.
Sorry. Good
Please
afternoon,
switch
everybody.
to presentation mode.
Can you see my screen?
Yes, good.
Good afternoon, everybody. I am Maranda Bayoud from Tbilisi University, Algeria, under the supervision of Professor Boudiba Louisa. My research focuses on the plant extracts. It's my pleasure to present my research with you under the title Preliminary Screening of Phytochemicals in a Plant Species from Eastern Algeria. Let me start my presentation by this question. Do you know what's the main chemical element that control the effectiveness of a herbal drug? I think after this presentation, you will be know. I'm going to start my presentation by introduction, methods and materials, results, and conclusion. Plants are autotrophic organisms that, in addition to primary metabolism, which is common to all living beings, possess another metabolism that enables them to synthesize and accumulate a wide variety of chemically diverse compounds. The bioactive compounds produced are known as secondary metabolites. Secondary metabolites are organic compounds that don't participate directly in the normal growth and development of an organism. However, their absence can lead to long-term modifications in an organism adaptability and survival, as they often contribute significantly to plant defense mechanisms. The therapeutic effects of herbal drug are attributed to the presence of secondary metabolites, whose composition varies depending on the plant's age and maturity. The selected plant for this study is a species native to Eastern Algeria. The aim of this work is to conduct a phytochemical screening of various extracts from the leaves and flowers of this plant species to determine the composition of its secondary metabolites. Functions of secondary metabolites, including antibiotics, are competitive weapons against other organisms such as animals, plants, insects, and microorganisms. Metal transport agent facilitating metal ion movement, agents for symbiotic relationship with other organisms, etc. The study was conducted at the Applied Chemistry and Renewable Energy Laboratory at Sheikh Al-Arabi Tbilisi University in Tbilisi, Algeria. This research focuses on the various extracts of an Algerian plant species and its different chemical constituents. Different parts of the plant were collected from the Sharia mountains. The samples were washed 3 times with distilled water, then shaded at room temperature. After drying, the plant parts were crushed using an electric blender and stored in an airtight container under dry conditions for further use. Preparation of ethanolic extract. 100 grams of the powdered sample was extracted with 500 milliliters of solvent for 24 hours. The contents were then filtered and evaporated using a rotary evaporator. For the preparation of aqueous extract, 100 grams of powdered plant sample was extracted with 500 milliliters of distilled water at room temperature for 24 hours. The procedure followed was the same as the ethanolic extraction process. Phytochemical screening tests were conducted using several standard methods for each metabolite to determine the presence or to confirm the presence or absence of phytoconstituents. 4 tests were conducted to confirm the presence of flavonoid in both leaves and flowers. 4 tests indicated the presence of alkaloid in flowers and the absence in leaves. Also, for glycosides, 4 tests were indicated a positive reaction with both flowers and leaves. For both tannin and phenols, 2 tests were indicated a positive reaction with both leaves and flowers, and the same thing for saponin. But for terpenoid, results indicated the absence in leaves and presence in flowers. Several tests confirm the presence of sterol in flowers and the absence in leaves. Results shows that the anthocyanin absent in leaves and present in flowers, phlobotanine, carbohydrate, quinone, and anthraquinone absent in both leaves and flowers. Cholesterol and cardiac glycosides present in flowers and absent in leaves. Quite the opposite, imodine and mucilage present in leaves and absent in flowers. Raising carboxyl acid and lignin absent in both leaves and flowers. The phytochemical screening revealed the presence of flavonoids, saponin, tannin, glycoside, phenols, and terpenoids in both the leaves and flowers, while anthocyanin, steroid, terpenoid, and alkaloid were detected exclusively in the flowers. Overall, these findings support the plant's ethnopharmacological potential and underscore the need for further studies on its isolated active compounds. These some references. Thank you for your listening.
Thank you very much for your presentation, and thank you for staying within the time. We are going to open the floor to have one or two questions.
I have a question. She asked a question at the beginning, so I want to have the answer at the end. She said we're going to have the answer. What is the answer of the question? Of your question that you asked?
The answer is the secondary metabolites.
Okay, okay. Which are they? Which are those secondary metabolites which you detected out of this extraction? What are they?
Sorry?
What are the secondary metabolites that you extracted from the plant that you think is
alkaloid, flavonoid, terpenoid, tannin, phenol, glycoside,
okay,
etc.
Okay, thank you.
Thank you.
Any other question, please? In the absence of any other question, we are going to move on to the next presentation, which is going to be from Prof. Luisa Nziba.
Thank you very much. The screen is shared?
Yes, go to presentation mode.
Okay, so I'm very glad, I'm honored to participate with you in this conference with a research entitled Impact of Mining Iron Dust on Phenolic Antioxidants and Biological Activities of Atriplex alimus L. This work was elaborated in the Laboratory of Applied Chemistry and Renewable Energies in Tbilisi University. So the presentation plan will start with an introduction, the plant material, the effect of iron dust on chemical composition of the plant, and the effect of this iron dust on the biological activities, and then after that, the conclusion. The Wanza iron mine in northeastern Algeria is a significant source of airborne particulate matter impacting air quality and environmental health. Mining activities such as drilling, blasting, and ore transportation generate substantial dust emissions, threatens both the workers and the nearby communities. This study examines the effect of mining-related dust on Atriplex alimus L, a wide distributed plant in arid and semi-arid regions, but whose response to pollutants remain poorly understood. Given its potential to produce protective secondary metabolites such as phenolic compounds, with antioxidant and antibacterial properties, Atriplex L offers a model for studying plant adaptation to environmental stress. By comparing plant samples from the mining affected Wanza region with those from the unpolluted Tebessa city, this research aims to assess changes in chemical composition and biological activities. The results will contribute to understanding plant responses to pollution, supporting ecological management strategies, and mitigating the environmental impact of mining activities. The plant was harvested in the northeastern of Algeria, in Tebessa city, and Wanza was in the north of Tebessa. The plant extraction followed this protocol. So solid liquid extraction, first of all, with methanol water, and after that, liquid extraction, conducting to dichloromethane, ethyl acetate, butanol, and aqueous phases. The effect of iron dust on the chemical composition of the plant. So simpler phenolic acids like parahydroxybenzoic acid, paracumaric acid, and caffeic acid are more vulnerable to oxidative degradation due to their less complex structures. Under stress, such as heavy metal exposure from mining dust, their levels decrease as plants prioritize producing more stable and bioactive compounds. Syringic acid, vanillin, and ferulic acid with methoxy groups and the higher antioxidant capacities are more resistant to oxidative stress and persist under adverse conditions. Taxifolin, a moderately active dihydroflavonoid, is susceptible to oxidation and degradation under stress. In contrast, stable flavonoids like quercetin, rutin, luteolin, and catechin with higher antioxidant and protective capacities are prioritized. So plants convert intermediates like taxifolin into these end products, enhancing their defense mechanisms. The effect of iron dust on biological activities of the plant. So the violacine is a purple pigment produced by certain bacteria, such as Chromobacterium violacinium. It's a secondary metabolite with antimicrobial, antioxidant, and anti-cancer properties. Violacine production is controlled by coromsensin, a bacterial communication system. So several plant-derived molecules are known to inhibit violacine production, targeting coromsensin, which regulates violacine biosynthesis. Even though they contained fewer secondary metabolites, Tebessa city extracts, among others, significantly prevented the synthesis of violacine and coromsensin by interfering with bacterial cell signaling pathways, especially those related to coromsensin. This low dose and the kind of polyphenols can reduce the generation of virulence factors and hinder bacterial survival. Mining iron dust influence their biosynthesis and enhance their amount, decreasing their effectiveness on coromsensin in Wanza zone. The swarming motility is a type of coordinated, rapid, and multicellular movement of bacteria across a surface. It is powered by flagella and is typically observed on moist and semi-solid surfaces. caffeic acid and ferulic acid are known to interfere with autoinducers, leading to reduced swarming activity. Concerning the biofilm inhibition, exposure to mining iron dust triggers stress responses in Atriplex alignus L, leading to the production of bioactive secondary metabolites such as ferulic acid, quercetin, rutin, and chlorogenic acid, which inhibit biofilm formation by disrupting quorum sensing, microbial signaling, and membrane integrity. Compounds like taxiphonin and caffeic acid suppress microbial adherence and biofilm matrix development. For the enzyme inhibition is a process in which a molecule, which is the inhibitor, binds to an enzyme and decreases its activity, preventing it from catalyzing a reaction efficiently. So interaction with mining iron dust induces stress responses in Atriplex alignus L, leading to the production of secondary metabolites like phenolics, flavonoids, and organic acids, which selectively inhibit the enzymes. So in conclusion, we can say that the study highlights the significant role of phenolic compounds in the response of Atriplex alignus to environmental stress caused by mining iron dust. The results demonstrate that certain phenolic acids such as caffeic acid, ferulic acid, quercetin, and rutin exhibit strong antioxidant and antimicrobial properties, particularly in inhibiting biofilm formation and disrupting quorum sensing in bacteria and fungi. The extracts from the plant also demonstrated significant antibacterial and anti-quorum sensing activity with TBSACT extracts, in particular showing strong inhibition of violacin production in Chromobacterium violaceum. These results suggest that Atriplex alignus L could be a valuable resource for developing natural bioactive compounds to combat microbial biofilms and oxidative stress in mining impacted environments. Thank you for your attention.
Thank you very much, Prof. Luisa Budiba, for your presentation. You're able to make your presentation within your allocated time. So right away, we are going to open the floor to have 1 or 2 questions. The floor is open. Any question?
I think I think there's no, I hope there were no questions so that we should gain time, because we are going to have an extra lecture which is not programmed here. So let's just move to the next presentation.
All right, we are going to have the next presentation from Bernard Wamboa. Do we have Bernard, please?
Yes.
Please go ahead and share your screen.
Guy, daddy, Nikki. Go to Metro Nita.
Catherine, please.
I've muted her.
We can see your screen. Go to presentation mode.
Yes, please. I have it now, okay?
Yes, right on.
Yeah, thank you. Okay, thank you for this opportunity to present this research that we have conducted in our institution on the extraction and characterization of this class of textile leaf dye and its application to cotton and polyester fabrics using some moderns.
Please, can you raise your voice a little bit?
Yes.
Please raise your voice a little bit.
Okay, just a minute then.
Allow him just talk, even if, continue. So
go ahead.
Okay, I can just continue.
Go ahead, continue to speak.
Okay, I was saying that color normally significantly improves the environment, and you'll find that the substances that have color are normally very enticing, and you can relate this in terms of how normally light transmits energy in terms of photons, and the amount of color that you can see will be related with the amount of light that has not been absorbed. And now that's coming in terms of light absorption, where they can give the fabric its color based on either it contains some chromophores, which are the color bearing units. It can have a conjugated structure, or even can also have a color. Sorry, I lost my connection.
All right, welcome back.
Thank you. So I don't remember where I got lost, but I'll just continue on the aspect of conjugation here. You can see in terms of this scheme, when you add a proton on the phenol base, you get the flagellam cation, which is the prominent structure, or even the component is present in this particular plant. And normally this plant in terms of extract has an issue of stability. So we are trying to have an extract which has a lower pH, and this is attributed to the flagellam cation. And this actually changes the electronic properties of the molecule. Therefore, you are able to see a different color based on which molecule or even is present in the plant. This is just some pictures on the electromagnetic spectrum which can relate the wavelength and the light that you are able to see. And this is the anthocyanidin, where you are able to get the anthocyanin which is present in the discus of Casella. And from this research, we were able to characterize the anthocyanin, and we actually got it to be found in 3-glucoside, as we are going to see in the preceding slide. And onto the problem statement, you can see that in 7 times 7 tons of synthetic waste are produced and used annually. And then getting our interest on the textile industry, which is our interest in this research, you can see the amount that is used in the industry. And these synthetic dyes normally contain carcinogenic constituents, which cause maybe difficulties in treatment of the dye in wastewater. And in terms of sustainability, they are very less sustainable. To be specific on the other dyes, they promote toxicity, mutagenicity, recalcitrance, which is the resistance to chemical degradation or decomposition, also the accumulation in the food chain. The significance of this study, it provides a potential substrate for natural dye extraction. This will also bridge the gap between the traditional practices and also the current scientific research. These were our objectives in terms of this research. It is some extraction of the leaves and also analyzing the properties of the dyed fabric. This was the methodology that we were able to use we collect our samples from Kisii County, Kenya, and they present in such a way that we first dried them for 2 weeks and carried on with the washing, crushing, and weighing. We did solvent extraction, where we use the soft plate extraction and the cold extraction for the leaves. And for the tannins from the eucalyptus globulus, we use the hot aqueous extraction at a temperature of 82 degrees for a period of 1 hour. Then from our extract, we're able to determine the percentage yield and also separate on polar and polar components using a exam, because we know that this extract will also contain some chlorophyll. From there, we took our extract and we did some LCMS analysis for the polar extract and GCMS for the non-polar extract. FTR for the polar extract was just to give a profile of the compounds that are present in our leaves. From there now we have our extract. We did some chemical tests and also now performed the dyeing of our fabrics, which was polyester and cotton, using now the modern spheres, which are able to aid in stability of the dye in the fabric. And finally conducted some tests for this fastness. And in dye, normally we use some isotest methods, which are actually applied in the test for the wet and dry lab, light wash and water spotting fastness test. And in continuation, this was the dyeing cycle. We modanted our fabrics at 50 degrees for 1 hour. That was the cotton, and for polyester, it was 80 degrees for 1 hour. This is normally to introduce now the mordant into the fabric, and from there we performed some cooling for 4 hours, then now perform the real dyeing, and finally we do some rinsing of the fabric. These are the parameters that we are able to optimize from the procedure. And now this is just a summary of the experimental procedures, what was carried out in history. In terms of results, this was the results for the chemical test in terms of alkaloids and the other phytochemical tests. You can see what was present in the each extract and also in the tannins, which was the globulus. In terms of percentage yield, we gained interest in knowing which amount you are able to extract using each method. And you can see the difference in the yield here could be attributed to the stability of our dye. Maybe you can see for the comparing now the cold and the soft slate. Normally the soft slate use ethanol at around temperature of around 80 degrees. So there was maybe some degradation. And now compare now the HCl and acetic acid extract. You can see there is a higher yield for the HCl extract. This may be attributed to the stability because it is an organic acid, and acetic acid is organic acid. And based on research, this one the HCl has been shown to contribute higher stability in this extract. And also you can see the yield for the tannins here. In terms of LCMS analysis, we got a profile of some of the compounds here. This data was correlated to what we have in scientific research and also what we are able to obtain from the software and also in terms of elution program. In terms of elution of these compounds, it was in a reverse phase column. So you expect the more polar compounds to elute fast. And this is also present in terms of molecular mass. You can see that compounds that have maybe high molecular mass and also in terms of polarity are eluting at different retention times here. And in terms of fragmentation pattern, this data was also available in research and we have correlate these compounds. In terms of anthocyanins, you can see our compound of was present in the plant, and this is what we are able to conclude that this is the main anthocyanin found in the leaves. And also according to research, this is what we have in research. This was just a fragmentation pattern that we got for compound of. In terms of STR, was the and we can attribute this to cell forms that are present in the extract based on what we got in our LCMS and also in our chemical test. That some, for example, the CO stretching, the OH stretching of an alcohol could be attributed to maybe intermolecular interactions of the flavonoids or even of the anthocyanin in the extract. So this year, again, we also gone in terms of profile, and these were also related based on polarity, volatility, what importance can also molecular weight. You consider in terms of molecular weight, it is increasing from the first compound to the last compound here, and also in terms of boiling point, if you go to research, for example, for this isomer, you're going to find that it has a lower boiling point than oxalate. After we did some dyeing, we did some test here to our color fastness, and you can see the values here. You can see the grade. 1 is very poor and 5 is excellent, and then you can range our values with what actually we had. We normally have a gray scale for color change, which is attributed to water spotting and also in light fastness. But gray scale for color change is normally for dry rub and wet rub. nested. These are the structures of the fabrics that we use in our research. Some of the you can see the structures here. In terms of that, you can correlate the stability of the dye in terms of hydrogen bonding. For example, you can see the mechanisms here that we tried to come up with in terms of dye. The middle one and modern. The one at the bottom is the dye, and actually the top is the one at the top is the fabric. And in conclusion, we are able to conclude that the yield of the ethanol was yes. Yeah, and for the community was given. You can see also this embryo process was the main amplifying, and we were actually able to conclude that this method is able to substitute the synthetic dye. I acknowledge the following here and my sponsor, the National University of Technology, Kenya, for offering me a scholarship to conduct this research. These are some of the selected references, and thank you so much.
Okay, thank you, Bernard, for your presentation. You were kicked out by network at the very beginning, but you were able to come back and do the presentation successfully. So right away, I'm going to open the floor to have one question so that we can buy time.
Okay.
Any question for him?
I'm just seeing a connection of what the other presenters, especially Professor Luisa and the other young lady who presented, with what he's doing. So it suits well. And if there's a possibility of collaboration one way or the other with the different group, that would be wonderful. That's what we say. I would just like for us to also gain time, let the Samuel Budiba, who wanted to present, just 10 minutes quickly. She was not programmed, but now that we at least two people did not present today, so I will just give her this opportunity.
Thank you, Professor Egbe. Thank you for this opportunity to let me be with you in this nice event. So can I share my screen?
Yes, yeah, share your screen.
Okay.
Yeah. So try to be short, 10 minutes.
No, maybe less than 10 minutes. So, hello, ladies and gentlemen. I would like to deeply express my sincere gratitude to the organizer for their dedication and efforts in successing this event. I have the honor to present you in this talk a part of the effort provided by our team to develop conjugated polymer containing anthracene in their backbone for optoelectronic application by designing and synthesizing an anthracene and based conjugated polymer via honor with immun polyphenation for enhanced photovoltaic performance. Faced to the increase in world energy consumption and the awareness of the harmful effect of the environment caused by the use of fuel on one side. On the other side, the problem concerning the oil producing countries, including Algeria, mainly or completely depend on this income, see their economy collapse due to the global economic crisis, and therefore the instability of the price of the oil. A large part of the world countries were being pushed to find other sources of clean energy. On one of the reflection with regard to these problems is to develop renewable energies such as biomass, wind and solar energy, the most developed because of the great hours of sunshine, especially in Africa. When we talk about solar energy, our thinking related to solar cells. The first solar cells realized in 1883 by the scientist Charles Fred was inorganic based on silicon with a yield of 1%. Nowadays, the silicon-based cell achieved up to 26% efficiency in laboratories. Unfortunately, these based silicon solar cells present many inconveniences, such as their expensive initial cost of production at high temperature, specialized maintenance and batteries, additionally to the limited availability of silicon, its brittle and rigid nature. To overcome this problem, we have organic solar cells, which present many advantages, such as their economic cost of production at low temperature, their flexibility, and integration facility. We noted that the material used was active layer in the photovoltaic organic solar cell could be polymers, oligomers, or small molecule. However, they must all have a p-conjugated system, allowing absorb in the visible, create charge, and then transport them. We were particularly interested to synthesize anthracene-based polymer because it's a rigid coplanar structure without electronic properties, which make it a potential donor motif for the construction of conjugated polymer having strong pp intermolecular interactions. This facilitates the transport of load carrier. Moreover, it gives great thermal stability to the developed devices. This conjugated polymer can be used as an active layer for OFED, OLED, or OPV. The specific electronic properties of this new class of decovered polymers, PAV, explain the search trend for material with increasing targeted properties to adapt them to various expected applications. The specific electronic properties of the new class of material, of the new class of polymer, can be explained by the search of material which increasingly targeted properties to adapt them to the various applications investigated. So in our work, we synthesized two polymer-based conjugated polymer were synthesized and characterized. This is some of their characterization, and because it is an ongoing paper, so I can't put more than this. So the purity and structure were confirmed. The NMR by different techniques, spectroscopic technique. This is in conclusion. And while cyclic voltammetry determined molecular energy level for bulk heterojunction application, the polymer showed promising photovoltaic potential with PC61BM, providing sufficient band gap for electronic transfer, and many other IV and EQ measurement revealed a good result. Additionally, overcast treatment removed an electrical blocking layer, facilitating better contact between the active layer and the electrode, making this material promising for future organic photovoltaic applications. By the end, this research, supported by ANSOLE'S organization, was conducted in collaboration between both Laboratory of Applied Chemistry and Renewable Energy at TBC University and the Institute of Polymer Chemistry at GKU University, Austria. I warmly extend my sincere gratitude to ANSOLE'S African Network for Solar Energy under the leadership of Professor Egbe for supporting my stay in Austria, and special acknowledgement goes to Professor Oliver Begeman, the head of the Institute of Polymer Chemistry, Linz, Austria, for his invaluable support and making this work possible by warmly welcoming me to his laboratory during my short-term visit. I'm also deeply grateful to all the members of the laboratory for their collaboration and assistance. And this is a photo for our last visit in GKU with Professor Egbe and Professor Bugeman. Thank you for your kind attention.
Yeah, thank you for making things for putting this very short. I want to say that Samuel Budibao was one of my early PhD student when we started the ANSOLE movement. And so I always tell a story. When she came to our lab, she wanted to give up, and she said she's going back home. I said, no, you stay. And now she's the head of a laboratory, professor, full professor. And I'm very proud. I'm very proud of her. And so that's why I had to go out of the program and give her this opportunity to present what we've been doing together. So we've come to an, I can say, we've come to an end of this day, but before we pass the word to all the organizers, Professor Ashmore. I don't know whether Paul is around. Maybe Paul came and he went. I don't know whether Professor Wekesa is around. But whatever the case, I want to thank.
Daniel,
Hi.
Karima Hanini is here.
It's yet too late, really. I don't know.
She's here.
Yeah. Does she want to? Can she speak in 5 minutes? Yeah, because she will have been on her time. That's the thing. Yeah. I would like to. I want just to give some last word before we close. We've been the whole day here, so. Yeah, Karima, can you present in 5 minutes what you wanted to present? Is it possible?
Yes, Daniel, I'm sorry. I tell my team, I'm sorry for this.
Because you were supposed to present a long time ago, you were not around. So and normally it's just because of yeah. Could you just give the basic result of your presentation?
Okay, my presentation based to substitute if my share is my presentation shared in your Daniel.
Yeah, then you can just say a few words.
Okay, my presentation based to substitute the cell inhibitor, the product obtained by way of synthesis by inhibitor product by natural product. This presentation tests the ethyl acetate extract of Taxus baccata as corrosion inhibitor for carbon steel in acetic medium. The test of this presentation we will based on polarization measurement and electrochemical impedance spectroscopy. These two parameters indicate the corrosion efficiency in 800 ppm of concentration of this extract. The measurement polarization efficiency, corrosion efficiency behave 78.45 and wait. And the polarization, I'm sorry, electrochemical impedance spectroscopy, also in 800, the efficiency, corrosion efficiency is 82.08. These results indicate the ethyl extract, ethyl acetate extract is a good inhibitor, green inhibitor in carbon steel acid medium. Okay.
Okay, are you through? Okay, thank you very much.
In brief, Daniel, I'm sorry.
Okay, thank you very much for
Thank you.
for the brief presentation. It's almost like a poster. You gave the potential results. I'm seeing as I said, I'm seeing a possibility of cooperation between the groups in Tebesa and also South Africa with Professor Esther, and also Kenya. The possibility of cooperating. This is the essential thing of us meeting here, and I want to thank all those who have presented. This last session, all those presented today was also very rich. I will just end up before giving the word to, is Professor Ashmore around and Dr. Wikesa, are they around?
I am around.
Okay, it's good that you're around. So I will share my screen just to talk about why we are doing this thing. Why are we why is ANSOL existing? And I will not talk about what yesterday we had issues. Let me share my screen. I've not yet, maybe you done it. Finish. I would like just briefly to talk about the principle of passing it on, that which governs our activity. So we've been here for two good days, and we've had more than today. Yesterday we had 25 lectures. Today we have 24 lectures, or yeah. So 49 lectures in total. 2 people did not appear, so we will have had if everything was, we'll have had around 52 lectures. So it's been 2 days of hard work, and I thank all those who've been here. And it shows your ability to sharing your time. And this is why I want to end up by sharing this principle of passing it on. So to share what you have, you receive, and you pass it on. And as somebody who is a Christian, I want just to say ANSOL was created. When ANSOL was created, we received these 2 words, one from Genesis, which is the beginning of the Bible, and Revelation, which is the end of the Bible. As Genesis 12, verse 2, I will bless you and shall be a blessing. So we receive to give on, to pass it on. So you are blessed so that you can be a blessing. So I just want us to keep this in mind. And when God opened the door, and this is the second word, behold, I've said before you an open door, which no one is able to shut. And I believe we are now 14 years old, and it has not been easy to be here. Many people have tried to shut the door, but God kept it open. That's what I want to say. But the most important thing, which I would like to share with us at this end of this conference, for 14th anniversary conference of ANSOL and the WAITRO SDG7 working group first international conference, is the principle of passing it on. And in Israel, you have 2 streams, or 2 seas, the Sea of Galilee, which receive water from various tributaries and pass it on to the Dead Sea through the Jordan River. And the Sea of Galilee is lively. So you see the Sea of Galilee receive and gives. So when you receive, you receive and you give, you are applying this principle. And you are full of life, and you are useful at the end of the day. And for me, I try to relate it to the thermodynamics, to the first and second law of thermodynamics. When you receive and you give, you have the second law mindset. I will explain it briefly. And the Dead Sea only receives and doesn't give water and is dead. That's a first law mindset. So, and the Dead Sea, if you go to Israel, the Dead Sea is dead. It's a totally dead sea, dead because there's no life in it. And it's also the deepest point on earth. So you can be a person living just when you are too egocentric, and the new generation, that's what I've noticed. When we're growing, we were brought up differently, but now the new generation, extremely egocentric. Everybody is just thinking about him or herself. We are not ready to share. But for me, ANSOL family is a family to share. And that's why we accept different things, accept people to come. Even if you are not in energy sector, you can come and give a lecture. We bring people together. We are a family. We are a family to share. And so for me to explain why am I trying to link this principle of sharing, of receiving and giving, just at the Sea of Galilee, it receives and gives. It is lively. And for those who read the Bible, that's where Jesus performed a lot of miracles. And if you go to the Sea of Galilee, people bathe there. It's life. There's life, and the Dead Sea is dead. So, and if you go to the laws of thermodynamics, I would say the first law of thermodynamics, which say which states that the total energy of an isolated system remains constant. Even if it is converted from one form to the other. So in the first law of thermodynamics, you focus only on the system. You focus on yourself. You focus on the system. I, egocentrism. Yeah. But in the second law of thermodynamics, I try to illustrate the second law with this, where I have a system, I have a surrounding. So you are not only focusing on yourself, you focus also on the surrounding, which is very important. And I will go to the next slide, which shows you the Gibbs-Helmholtz equation. And in the second law of thermodynamics, you have the entropy law. So it is the second law, which states that any spontaneously occurring process will always lead to an escalation of the entropy. What is the entropy actually? Is the degree of disorder. And if you take into this equation of the Gibbs-Helmholtz equation, you have delta G equals to delta H minus T delta S. And this delta S, this difference of entropy, is the entropy of the system and the entropy of the surrounding. So the surrounding, the people around you play a big role. And when you get at the end, you have this Gibbs-Helmholtz equation, which gives you the free enthalpy. And the free enthalpy is the non-expansion energy, and I call it is the useful energy. Okay, the useful energy, in this expression of the useful energy, you always have entropy. You always create entropy. I always tell people, you have to create entropy to be useful. I will always extrapolate it and translate it into even mistakes. If you are not ready to do mistakes, you cannot be useful. So, for people who understand even the gospel, I say God made us to do mistakes. That's why Jesus had to die on the cross of Calvary, because if we're perfect, if delta G is always equals to delta H, we are perfect. But the disorder is always there to make us understand that we are just human. But when we do mistakes, when we are ready to do mistakes, we are useful. So this is the message that I want to give, so that you can only be useful when you do mistakes, but you can also be useful when you are ready to think about your surrounding, because in this delta S, you have the delta S of the surrounding. The surrounding, the people around you play a big role. And the whole concept of what we are doing, what I am doing, what Professor Ashmore is doing, what all of us should be, we want to be useful to our surrounding. We want to be a blessing to people around us. Let's stop thinking only our own, my. Go from the first law mindset to the second law mindset, which I say the second law mindset is the way I think about my surrounding, and I'm a blessing. It makes me to be useful. And I will go to one point, what's asking the African community. Yeah, this slide I used to use in my talks. But what I want you to read from this slide is this number 3. Africans should start trusting themselves and be ready to do practical mistakes. Going back to this second law of thermodynamics, practical mistake with the, if we are training engineers, if we are training, innovators, and at the end of the day, when we have big projects in Africa, what we do, we call the Chinese to come and build our roads. We call, I don't know, the Europeans to come and do the project for us. Why can't we allow our young engineers to do mistakes? And by doing mistakes, they learn from their mistakes and they improve. I will always take the case of China. China, let me say 40, 50 years ago, when products were coming from China, people were laughing. But now China is the fabric of the world. They learn from their mistakes and they are improving. I will take an example. China have taken the Transrapid, what Germany developed, Siemens in Germany developed a magnetic train. It has never been used in Germany, but it's now being used in China, in Shanghai, linking the airport of Shanghai with the city center, because they always learn, they improve and improve. They learn from their mistakes, and they are now leading in everything. Africans should go, we should start trusting our engineers. Our leaders don't trust our young people when they have projects. They prefer to call the foreigners. Let us learn to do mistakes. That's this entropy part. Without the entropy, if you don't want to create entropy, you are useless. Mistakes are part of our life. I see it as a human. This is a philosophical end of this conference. Mistakes are part of our life. Be ready to forgive somebody who does mistake. Okay? People who don't do mistake, I have people in my family who prefer to sit beside, say nothing because they don't want to do mistake. They are just there to criticize when you do mistakes. But when you do mistake, if you are doing something, you always do mistake, you always create entropy. But your intention is most times you want to produce useful energy. You want to produce delta G, which is a useful energy. And I want to encourage us, don't be afraid to do mistakes. Do it for the benefit of humanity. That's the end of my word today. And I thank all of you for being with us all these 2 days. And I thank those who helped me. I want to thank Professor Ashmore, who has been supporting in many ways. I want to thank Wekesa to accept to be a co-host. I want to thank Paul, who is no more here, but we are happy that we gave him the opportunity to give his last keynote lecture as Secretary General of WAITRO. I thank all the more than almost 50 presenters of these 2 days. It has been a wonderful thing for me. And as we said, we want the good papers. A lot of good papers were presented today. We'll contact you soon, especially Professor Asma and I will contact you for you to submit the full paper for publication. It will be peer-reviewed. This is an Elsevier journal, the Scientific African. So we'll contact you for you to submit your paper. Do it in a good manner. Don't think that, okay, because it's a special issue, it will be peer-reviewed, and if the paper is not good, it will be rejected. So present something good, and so that this conference should remain in a way. But the other aspect is that we've seen already what I started doing, the proceeding, the compilation of the abstract and so on. We'll make it in a good refined form. If we need some information again from you, we'll ask you the information to prepare a conference proceeding which is going to have an ISN number. So it is also, you can use it also as a citation. So, and the other aspect is which I want to ask you is that all those who have presented, please send us your presentation to the email address of the conference, because I've received sometimes presentation to my WhatsApp is confusing. Please send it to that conference and so that we can collect all the presentation. We'll make out of it a PDF. If you have results that you don't want to share, you can remove it for the moment, and so that I want to make one PDF, then I will share it to everybody. So please send that in the next days. If your data is too large, you send it through WeTransfer, but the email address that you will put will be conference@ansol.org, which is so that everything should go to one email address. And I think this is what I want to say. And what else? The next conference that we are planning, we were discussing it early this morning, at the 15th anniversary, which will be combined also maybe with WAITRO and any other person who think that we can work together to make the 15th anniversary conference next year. It might be end of February, beginning of March, or later the year. We want to do it in Kenya. We've said Mombasa. Dr. Wakesa was saying they have possibility. Let's see how the things evolve, but I prefer Mombasa so that we can also have time to go out and go and swim and at least have combined conference and leisure. So this is what I want to say. Thank you. I want to thank everyone, and I give the floor to Professor Ashmore to give some few words of gratitude and farewell.
Yes, thank you, Professor Daniel. Firstly, I would like to thank all the speakers and everybody who was involved in the conference. It was a hectic 2 days, but what I can conclude is that Africa really has good research. We need just to focus, and we need just to see ourselves some way. We have a lot of problems in Africa. I was just thinking to myself, I mean, we had network problems. What if we develop a device that we plug to our devices and switches onto the next network when we don't have a network? Let's make it a challenge. We don't have IT specialists, but we could develop it in Africa. We have a problem with networks. It switches, even if it can even switch to electricity, fiber, and so forth. That's a good, project to think about. It could be a good PhD project. That's what I was thinking with all these problems in the network. Besides that, I would like to thank everybody who participated in this conference. I have to mention the countries that were represented. We had, firstly, I'll talk about the major countries. That's Cameroon. Thank you, Cameroon, for representing with a lot of papers. Algeria, thank you. You had quite a number of papers. Also, where I'm based, South Africa, thank you a lot for a lot of papers. I think we had 8 papers. There was also papers from Ghana, France, Austria, UK, India, South Korea, Uganda, Kenya. Kenya also presented quite a lot. Albania, Ukraine, Latvia, and Germany. I hope I didn't miss anyone, but thank you.
Madagascar also.
Yes, Madagascar. Thank you very much, Daniel. And it shows that our research is going there.
Jordan.
And Jordan, yes, and Jordan had 2 papers. Sorry about that. Just was collecting, as I went through. But thank you very, very much for all these presentations. It shows that our work is relevant to the type of atmosphere. So the next thing I want to talk about is the special issue in the Scientific African Journal. The special issue is going to be on sustainable energy transitions in Africa. However, if people still have good work, if your work is not within the scope, you can still submit it to Scientific African. I am a journal editor at Scientific African, and when you submit the special issue article, you have to click onto Scientific sustainable energy in Africa. Please do not submit to another, to the normal way, because it might be rejected. However, all of the work I think is relevant for Africa. If your work does not meet the scope of Scientific African, the special issue, you can still submit it to Scientific African. It is possible to publish a paper, and there's a lot of good work that we've done. And I just encourage all colleagues, even if it's not within the scope of our special issue, which is more on a focus of sustainable energy, you can still submit it to Scientific African. I would have said, as we discussed with David and Daniels, what did we say? We say selected papers. I don't think we should select. Let people submit. But there's a catch. There's going to be thorough peer review. At least if it's peer reviewed, and even if it's rejected, you improve on it. So I would say, people, I'm going to send, when it's out, the call for the papers, I'll send it to my team, Daniel, I think Prof. Onudio from the Northwest University, Prof. Oiroth from Chiambogo University, and also Prof. Wekesa from Multimedia University of Kenya. I'll send them the call, and they're going to circulate to you the call, so that you can put forward your brilliant work. In my own opinion, what has been presented is brilliant, and Africa should strive to be better. And the good thing about Scientific African, it promotes work from the African continent. So, I mean, it's not limited only to researchers who are actually based in Africa, but who have African origin can also submit. But the main focus, for your own information, is that it's work done on the African continent. That's what we prioritize first. So if you are doing work from another region, unfortunately, the paper will be rejected on submission if you do not declare that the work has been done from the African continent. Then finally, before I say bye-bye, let's meet in Mombasa. I would like to thank Veronica. She was on the forefront to actually spearhead this conference. I also want to, acknowledge Daniel. Thank you very much for the ANSOL, and thank you very much for making me involved. And I also want to thank Dr. David Wekesa for working together to make this possible. So lastly, I would want to say, let's see you in Mombasa. Let's hope this will be bigger and better. And please, 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 colleagues, can you share your experiences to your networks, so that in Mombasa, instead of 30, 40 participants, 50 rather papers, we have 200 papers. That will be a big success story for ANSOL and WAITRO also. And by the way, before I forget, Paul, I hope he's still here. Thank you very much for accepting to give us the keynote. There's one thing he said: the technology is always in the lab. Let's make it practical. Let's learn from past mistakes and make real devices that people need. Let's not just, do research without involving the community. Let's actually involve the community. Let's try to understand what the community needs, and we can map a way forward. Once we can save our own communities, I think, as Daniel says, as a Christian, we can save God. Thank you very much. So I hand it over to Dr. Wekesa, if you are there.
Thank you so much, my co-host, Ashmore, and also our chair, Daniel. I think I'll start with, first of all, looking forward to the Mombasa conference. I will do my best, being here in Kenya with the other team, like Catherine and also other Kenyan scholars who are here, to ensure that actually we guide you and give you any information that we need, and also get in touch with the universities, like Pwani University. There is the Technical University of Mombasa, just to see on the logistics how we can capitalize on that synergy, especially on the goodwill side. Mine, having actually attended this conference, is to say that a lot of things have come up. I saw major and many ideas on OPVs, organic photovoltaic solar cells, and I think a number of topics across the entire energy sector. And one thing that I also want to pick just from other scholars, there is also an opportunities to do with collaboration. I saw an opportunity for networking and partnerships, and I'm happy the way even the abstracts have been, structured and shared to us. We have email of all authors that actually have done the presentation. Let's keep in touch, see where you can connect the topics that you are interested with. I saw an opportunity also on benchmarking. Sometimes it's very good to understand what others are doing, that actually gives you an opportunity to do a peer review to actually assess where your own research maybe stands globally. And that can only happen in such kind of a forum. And lastly, I think Ashmore has talked about the special issue. I'm part of his team and the team of Daniel on the editorial board, especially as a guest editor. We look forward to actually look at maybe your manuscripts so that they meet also the international standard. Otherwise, thank you so much, Daniel, for making me part of this team, and we look forward for a successful conference next year here in Kenya, in Mombasa. Thank you.
Yeah, thank you. I think Paul is not around, so we, as we said, would have liked to wish him all the luck for his, let me say, new duties as a non-Secretary General, but I know he's a very active person. But we are happy that he used this, we gave him this opportunity to organize the last conference and give his last keynote lecture, yeah. So I would just say thank you for once more for everyone. And we've got the message about the papers to be submitted, about your presentation that you have to send to us so that we'll compile it and forward it to everybody, about those who want to pay their registration fee, who can pay, please, you can do it. If you want to talk to me, you can talk to me too. Yeah. And then the Mombasa event, which we would like to see many of you, and next year. So we'll try to work on it as quickly as possible as the year goes on now. And I hope WAITRO is going to be. We can continue to work together with WAITRO, and we'll get sponsorship. We'll need sponsorship really to mobilize people to attend this event. So let's just pray and hoping that God is going to open doors for us, as he has said. So I wish all of you a wonderful rest of the weekend, especially tomorrow, and rest well this night and enjoy your Sunday. Thank you very much.
Thank you, everyone. It was a pleasure really working with everyone on this project, compiling the abstract, reading through them, and I'm happy and we had a successful conference, and I look forward to meeting everyone in person next year. Thank you all.
Yeah, okay, thank you, Veronica. You forgot to give you the word, but I want to say that you played a big role behind the scene, and you contributed. You came on the right time, as I was saying yesterday. You came on the right time to support me in doing this conference. Thank you for your contribution, also, Veronica. So thank you, and have a nice weekend and stay blessed.
Daniel, I would like to thank you, all organizing committee, for excellent organization of the conference. It was very interesting, very good reports, presentation. Thank you, and I wish success in your activity. It's great, really.
So let's make it the last picture. Let me not forget that one. The last screenshot, those who have stayed up to this level. Catherine is still around? Somebody should do because my screenshot is just, sometimes it doesn't take everybody. If somebody can do the screenshot, let the person can do it for us. Let's put on our cameras on, and then we have the last screenshot. Can someone do it for us? Is somebody, Mr.? Are you able to do that? Or Lily? Or Bernard?
My PC is down. I can't do it, except I'll go with my mobile phone.
Who else has his PC on? Jerome. Who is ready to do it? Because I can do it, but I'll just get those. Let me see. I can do something, but it's not going to this one. Okay. So you have to click those who click. If the picture is, then I will. All those who've clicked, then I can make a good picture. If you've accepted, then I will make a good picture. Let me see. Okay. So I have only 1, 2, 12 people whose pictures are, yeah. But I would like us, just even those who are not, did not open their camera. I just have the picture of those who open their camera. But we just need a screenshot with everybody, if it's possible. That's why I was asking someone else to do it. Okay. Can someone do it? Nobody is ready to do the screenshot, or you don't have the possibility. Ashmore, can't you do it?
Just do it.
No, I just did. My problem is that I don't know what I just did a picture of those who had their camera open. I will try again with that one. But I wanted
Bernard has volunteered to do it.
Bernard, can you do it? Bernard, can you say something? I should know. Okay, then you've done it?
Yeah,
okay,
he has typed.
Yeah, it said he has taken.
I also took some. I'll share with you on Monday.
Yeah, okay, you sent it, so you shared with me. Thank you, Lily. Okay. So thank you all. So we have a nice evening. So bye.
Bye-bye.
Bye.
Bye-bye, and good weekend
Thank you
to
for your
everyone.
contribution. Thank you for the time, for being patient and
bye-bye. Thank you. See you next week.
Bye-bye. Thank you, everyone.
Bye.